to the KU and KADH International Conference on Digital Humanities, held in celebration of the 120th anniversary of Korea University. My name is Yujin Jung. I'm the Associate Director of Youth and a Professor of Linguistics at Korea University. It's truly my pleasure to serve as the host for today's opening ceremony. We are delighted to have you all here to explore new possibilities for the humanities in this exciting area. So now we are honored to invite President Dong-won Kim of Korea University to deliver his congratulatory remarks. Please welcome him with a warm round of applause.
예, 반갑습니다. 아주 해외에서도 많이 오시고 오늘 가을에 선선한 날씨에 아주 훌륭한 이 포럼을 하게 되어서 아주 기쁘게 생각합니다. 존경하는 국내외 학자와 연구자 여러분 반갑습니다. 고려대학교 개교 120주년 기념 국제학술대회에 오신 모든 분을 진심으로 환영합니다. 특히 국내외 각지에서 참여해 주신 학자와 대학원생, 연구자 여러분의 헌신과 열정에 깊이 감사드립니다. 아울러 본 학술대회를 공동으로 개최해 주신 한국디지털인문학협의회, 한국학중앙연구원 디지털인문센터, 고려대학교 문과대학과 인문사회 디지털 융합 인재 양성사업단 관계자 여러분께도 감사드립니다. Reimagining the Humanities, Big Data, Culture and the Public 이라는 주제는 고려대학교가 120년간 지켜온 인문학의 전통 위에서 미래 인문학의 새로운 비전을 모색하는 뜻깊은 이슈라고 생각합니다. 고려대학교는 자유, 정의, 진리의 기치 아래 인문학 연구와 교육의 정통을 이어왔으며 이제는 디지털 전환의 시대 속에서 인문학과 과학기술의 융합을 통해 학문적 상상력을 확장하고 있습니다. AI와 빅데이터가 인간의 사고와 창의를 변화시키는 AI 대전환 시대에 인문학은 기술을 비판적으로 성찰하며 인간과 사회의 의미를 새롭게 모색하는 지적 책임을 지니고 있습니다. 기술의 혁신이 인간의 상상력을 대체하는 것이 아니라 그 가능성을 확장하는 방향으로 나아가도록 이끄는 것, 그것이 인문학의 역할이자 사명입니다. 이번 학술대회는 그러한 사명을 새롭게 상상하고 확장하기 위한 자리입니다. 오늘과 내일 이틀간 이어질 발표와 토론이 학문간 경계를 넘어선 협력과 통찰의 계기가 되기를 바라며 이를 통해 지속 가능한 인문학, Sustainable Humanities의 미래를 열어가길 희망합니다. 준비에 힘써주신 모든 분들과 발표자, 참석자 여러분께 깊이 감사드리며 여러분의 지적 교류가 인류의 더 나은 미래로 이어지길 기원합니다. 감사합니다.
Thank you very much, Dean. Thank you very much for the President Kim. Now, before President Kim leaves for his next engagement, we will take a short group photo on stage. May I kindly invite Dean Hee-kyung Lee, Professor Jin-Ho Park, sorry about that, and the precious guests, please move on the stage. Now, for the take a picture. 네, 사진 총장님께서 다음 스케줄 때문에 이동을 하셔야 돼서요. 그 발표자분들, 그다음에 토론자분들 무대 연단 위에 올라오셔서 사진을 같이 찍어주셨으면 합니다. 그리고 저 위에 빔 좀 잠시 꺼주실 수 있으실까요? 그리고 스크린도 올려주시면 네.
여기 카메라 보실게요. 네. 촬영하겠습니다. 하나, 둘, 셋. 한번 촬영하겠습니다. 하나, 둘, 셋. 이번 하나 때만 파이팅 한번 하고 촬영하겠습니다.
총장님께서 굉장히 바쁜 일정이 있으셨나 봅니다. 예, 바로 이동을 하셨고요. 예. 다음으로는 저희 개회사를 하도록 하겠습니다. May I kindly invite Dean Hee-kyung Lee, Professor Jin Bak, and our for our opening remarks. Yeah. Dean Hee-kyung Lee is the Dean of the College of Liberal Arts, Korea University.
Good morning, esteemed scholars and researchers from Korea and around the world. It is with great pleasure to welcome you all to this international academic conference, which celebrates the 120th anniversary of Korea University and is organized by the College of Liberal Arts in collaboration with HUS and the Korean Association for Digital Humanities. This morning's opening ceremony marks the beginning of an event that will bring us together to explore new directions and possibilities for the humanities in the age of artificial intelligence. The humanities have always been a discipline devoted to understanding the meaning of human existence, society, and the world we live in. Today, we find ourselves at a historical turning point as artificial intelligence and big data are transforming the very foundations of human thought and creativity. In such an era, the role of the humanities become all the more vital to question anew the essence of human values, ethics, and imagination within the tide of technological innovation. Our mission is to share the fruits of that inquiry with future generations. The College of Liberal Arts at Korea University has long carried forward the proud tradition of the humanities by expanding the frontiers of human understanding, even amidst constant change. In an age when AI is generating vast amounts of information, the humanities must serve as a beacon that illuminates the meaning and direction of technology. The digital humanities represent a creative endeavor that transcends disciplinary boundaries, interprets data, and uncovers new dimensions of human value through technology. I hope this conference will serve as a stimulating forum for collaboration and reflection, inspiring us to envision and shape the next century of the humanities. Before I conclude, I wish to extend my sincere appreciation to HUS, as well as to the Brain Korea and Humanities Research Centers, the organizing committee, and the staff members whose dedication and effort have made this conference possible. I hope that the meaningful dialogues and diverse perspectives shared here today will serve as a driving force for a new era in the humanities. Thank you very much.
Next, we hear the opening remarks from Jino Park, Chair of KADH and Professor at Seoul National University. Please welcome him to the podium.
예, 한국디지털인문학협의회 학술대회를 이번에 고려대학교 120주년을 기념하여서 이렇게 공동으로 개최하게 되어서 매우 뜻깊게 생각을 합니다. 잘 아시다시피 생성형 AI의 발전으로 사람들의 공부하는 방식, 교육하는 방식, 연구하는 방식에 큰 변화가 일어나고 있습니다. 제 주위의 지인들이나 SNS를 통해서 이런 이야기를 많이 듣고 있습니다. 양자역학, 상대성 이론 같은 어려운 물리학 이론, 양자 컴퓨팅 같은 최신 기술에 대해서 알고 싶어서 책을 읽다가 몇 번이나 포기했던 사람들이 최근에 생성형 AI와 대화식으로 공부하면서 그런 어려운 이론에 대해서 내가 훨씬 더 깊은 이해에 도달했다라는 증언들이 쏟아져 나오고 있습니다. 왜냐하면 생성형 AI에게 내가 이런 것들은 이미 알고 있고 그런데 이런 부분이 특히 좀 어렵고 잘 이해가 안 돼. 그런 부분을 잘 친절하게 설명해 줘라고 요구함으로써 생성형 AI가 그 사용자의 지식 상태 수준에 맞게 설명을 해주기 때문에 훨씬 더 사용자 맞춤형 교육과 공부가 가능해지고 있습니다. 따라서 교육이란 무엇인가, 또 대학이란 무엇인가에 대해서도 재정의할 필요가 생기고 있습니다. 우리가 기존에 공부해왔던 방식과 상당히 다른 방식의 공부, 또 가르치고 배우는 일이 앞으로 가능해질 것이고, 또 대학에서 그런 여러 가지 가르치고 배우는 일을 어떻게 체계적으로 잘 조직할 것인가 하는 문제도 새로운 도전, 또 새로운 가능성들이 많이 열리고 있습니다. 고려대학교는 우리 한국을 대표하는 명문사학입니다. 영국에 옥스포드, 케임브리지가 있고 미국에 하버드 같은 명문사학이 있듯이 한국을 대표하는 사립대학교입니다. 그리고 고려대학교는 이 개교 120주년을 맞아서 또 이런 생성형 AI 시대에 새로운 도약을 준비하고 있습니다. 따라서 고려대학교가 지금 직면해 있는 도전과 문제, 그리고 우리 한국의 인문학계가 직면하고 있는 문제, 그리고 특히 우리 디지털 인문학 협의회가 고민해온 문제들은 서로 동떨어진 것이 아니라 상당 부분 일치하고 서로 교류함으로써 많은 것들을 얻을 수 있습니다. 그래서 오늘 고려대학교와 저희 한국디지털인문학협의회가 공동으로 개최하는 이 행사가 매우 뜻깊다고 생각을 하고요. 그래서 이렇게 우리가 고민하고 있는 이런 거대한 문제는 어느 한 사람의 머리로는 해결책을 찾기가 쉽지 않을 것이고 전 인류가 함께 지혜를 모아서 해결책을 같이 찾아 나갔으면 좋겠고, 그런 점에서 오늘 여기에 국내 또 국외의 훌륭한 연구자들이 모여서 자신들의 연구 성과를 공유하는 이런 자리가 마련된 것을 매우 기쁘게 생각을 합니다. 오늘 또 내일 양일간 이루어질 이런 학술적인 활동이 매우 큰 결실을 맺고 또 참여하신 분들이 많은 성과를 거두고 돌아가시기를 기원합니다. 이 행사를 이렇게 성대하게 충실하게 치를 수 있도록 도와주신 고려대학교 관계자 여러분, 그리고 한국디지털인문학협의회의 임원 여러분들, 그리고 기조 강연을 해주실 하비에르차 교수님, 그리고 그 외에 많은 발표자 선생님들, 토론자 선생님들, 또 좌장, 사회자 선생님들께도 깊이 감사드립니다. 예, 이상입니다.
Thank you very much, Dean Lee and Professor Park, for your inspiring words. So before we move on the keynote speak, let's make a little memory together. So I'd love to take a quick photo of everyone here from the stage. 제가 여기서 사진을 찍을게요. 여러분들 다 같이. So let's move on the keynote to speak. Professor Seung Lee will introduce the Professor Javier Cha.
Good morning, everyone, and welcome to our keynote session. My name is Seung Lee from Korea University, and I have the honor of moderating this keynote session. It's my great honor to introduce our keynote speaker, Professor Javier Cha from the University of Hong Kong, a distinguished digital historian. Professor Cha specialized in the intellectual and cultural history of East Asia, and his research bring together medieval Korean studies, big data methods, and digital humanities. Today, Professor Cha will deliver a keynote titled Big Data Studies or an Analytical Bibliography of Web 2.0 Infrastructures. We look forward to his insights on how digital methods are reshaping humanities scholarship for the 21st century. Please join me in welcoming Professor Javier Cha.
Thank you so much for that very kind introduction. It's, to say the least, it's an incredible honor to be here. Thank you so much for your kind invitation. I actually can't believe I'm standing here. Korea University is a very special place for me. My cousin graduated from here about 25 years ago. Maybe I shouldn't reveal her age for the whole world to hear on YouTube. In Russian literature. So I'm quite familiar with the university. I visited here several years ago. Beautiful campus, and thank you so much for being here in this beautiful autumn day in South Korea. And I would like to congratulate this very distinguished university for the 120th anniversary, and wonderful to make this joint event with the Korean Association for Digital Humanities. It's fantastic to see KADH becoming a part of the Alliance of Digital Humanities Organizations and hosting the next year's DH 2026 event in Daejeon. So this hopefully will be the stepping stone toward an even bigger presence that will be established in the global Korean studies, digital humanities community. Sorry, I have two distinct identities as an academic, one in Korean studies and digital humanities. Sometimes Korean studies kind of automatically comes out of my mouth. What I want to talk about today, it's actually research that the foundations of which were laid while I was employed by Seoul National University between 2017 and 2022. Of course, on the technical side of things, there's a lot of attention, as we saw in the opening remarks from the president of the university, president of KADH, and also our dean about generative AI. I will talk about AI toward the end. On Saturday, I'm going to give another lecture in Daejeon where I exclusively talk about AI. But today, I will talk about this toward the end because what I want to talk about today is what precedes it and continues to shape the kind of platforms and services that we more or less take for granted as everyday researchers in academia. So the topic today is titled Big Data Studies. I operate a lab called Big Data Studies Lab. And I want to talk about where this began. I was hoping to see Lev Manovich here. I think he will be here this afternoon, but it kind of began with Lev. When I was a young student back in 2011, so I started studying digital humanities in 2008. I heard about this very famous scholar named Lev Manovich. Doesn't identify himself with digital humanities, but is a very influential scholar in new media and new media theory. And he happened to be an important part of a National Endowment for the Humanities funded workshop. And how times have changed, right? Because what happened to the NEH since then? So this was at UCLA, and turns out that this Panda Express location is also gone from UCLA campus. We had a fast food lunch together, Lev and I, and he was very interested in my attempt to use digital methods to study medieval Korean social history. And Lev was genuinely interested in what I do. And I was just eager to just learn something from this major figure in academia. Had a conversation and kept asking me about, what's happening with this genealogy? What do you plan to do with it? And then toward the end of the conversation, he just made a remark. I guess as a lot of senior scholars tend to do. I guess he just thought about what I do and left a remark that really got me thinking. Toward the end of the conversation, he asked, so Javier, that's very interesting. You're a historian, I get it. You study the distant past. Have you thought about looking at anything contemporary? You're interested in digital humanities, modern technology, something contemporary. How about that? Yeah. I didn't make much of it, but just kept thinking about it over the years, since 2011. And then the next time this became a serious topic of conversation was when Redmond, Washington is a suburb of Seattle. Headquarters of an important company is based here. You might have heard of it, right? I have a really good friend here who lives in Redmond. And I will not name which company, but he used to work for one of the largest cloud service providers in the world. Yeah. In 2016, there was an Asian Studies conference, and for the first time, we had a gathering of Asia specialists, humanists, and an engineer, and discussion of digital humanities came up. AI wasn't a part of the conversation, but Web 2.0 was. Social media was. And because my friend works in the cloud industry, we talked about data centers. And that kind of planted the seeds of what later I will start calling big data studies. I started thinking, what does it mean to do humanities research with big data? Okay. And by big data here, I don't mean like casually just defining big data as analytics, big data as just very large data set. Like how big does it have to be called big data? We use this term rather casually without a clear definition as to what it means. So in defining what is big data studies, I started questioning, so what generates big data? What hosts it? What makes it possible? Right? So big data initially, in the beginnings of the Web 2.0 era, referred mainly to user-generated contents of the Web 2.0 era, right? Primarily social media, right? In a bit, I want to talk about like what kind of scale we are talking about here. And because we're talking about extremely large scale, astronomical amounts of data, it requires a very distinct type of infrastructure. Okay? Talk about this transition as well. Actually, companies, Web 2.0 companies have to creatively devise ways to design a very new kind of infrastructure. Not today, in the age of generative AI, we continue using. Right? We haven't moved away from it. We actually intensified the kind of infrastructure that was defined with the beginnings of the age of social media. We're talking about, of course, data centers. Okay? This is a Google data center in Jakarta. I will show you several examples of data centers in some of the later slides. Okay? So how does this relate to digital humanities and digital history more specifically? It has a lot to do with my ongoing research, and I've published several articles about this, that makes a clear distinction between a digital approach to humanities research versus diving right into computational approaches. Right? The distinction is not always made very clearly. And we sometimes take computational approaches and digital approaches rather for granted. Right? But if you were to reflect on this and think about, as I do with my digital humanities seminars and introductory courses for undergraduate students, digital humanities used to be called humanities computing, used to be also called humanities informatics. Some of this nomenclature still persists even today in the 21st century. But going back, say, 1970s, the 1970s, if you look at the work of the historian Ian Milligan, he mentions how already in 1970, there was a reflection. There's a series of 3 articles written by this historian, Robert Surerenga, about CLIO computers. Right? And when you read this piece, it really strikes you as a digital historian today or a digital humanities scholar today, how mostly computers were there to compute, to tally up figures, statistical analysis, something that we continue doing with more advanced computing power and more advanced algorithms. Right? But it was, at this time, very difficult to imagine a digital approach to humanities research. Right? That comes later, in the 1980s, with the dissemination of personal computers. Right? With the dissemination of personal computers in the 1990s, we have digital historians such as Roy Rosenzweig in George Mason University, thinking about also how to do research in a web environment and a digital environment, thinking about curation of materials that humanities scholars collect and want to present to the world. We also begin to talk about public-oriented humanities, public history, public humanities as well. All these approaches were very difficult to execute with computing in the 1970s, but increasingly becomes possible with the spread of personal computers. And with the advent of the web, new kinds of research being made possible and historians reflecting on it. Right? What does keyword search do to historical scholarship? Right? To what extent does keyword search contribute to the rise of something called a transnational turn in historical studies, right? And additional scholars like Ian Milligan reflecting on this in more depth, right? So what does it mean to do humanities research through digital means, right? And to illustrate this, I think this is a very appropriate place to bring up this project. I got inspired by a project based in Korea to think about this phrase, something I've been saying a lot in the last few years, called digitally rereading the sources of the past. Right? Digital readings or digital rereadings of primary sources. What I mean by this is taking sources, historical sources that look like this, and then through digital mediation, think about in what new ways can we approach this source? What does digital media enable us to do that would have been very, very challenging to do before, or maybe impossible to do before? And the project that inspired me to think about this phrase and this perspective is, in my opinion, one of the most successful digital humanities projects in Korea, called the GM Diary Project. Right? In this, I don't think I see Yu In Tae here at the moment, but I think we will see him tomorrow. Right? So the digital humanities side of this project was led by Professor Yu In-tae in Jeonnam National University. And it's a wonderful project where he takes, there's a team of scholars who deciphers cursive form of classical Chinese that looks like this, which is, to me, I wouldn't be able to read this. It requires special training to read cursive form of Chinese. Turned it into Unicode text, created a collaborative platform as a custom-made wiki, and then transformed this traditional document into 7 to 8 distinct data types into databases, and then enabling this source to come to light. It's a diary written by a 17th century patriarch based on one of the remotest parts of the Korean peninsula. Not exactly easy to read, even if you were to read it in Unicode. Right? You can browse now the document through all the locations referenced in the diary, all the events identified in the diary. You're now digitally rereading the diary in completely different ways. Right? So inspired by this, I did something very similar. This is the project that I referenced earlier during my story about the encounter with Reimagining. One of the most reliable genealogies to be published in the Korean Peninsula, also the oldest extant comprehensive genealogy from the Korean Peninsula, the 1476 edition of the Andong-Kwon genealogy. I converted into edge list and note table. Also converted a set of epitaphs, tombstone inscriptions from medieval Korea. In this case, I got quite a bit of help from a large language model to speed up the process of doing entity recognition, and then engaged also in digital rereading of a genealogy. Genealogies are very difficult to read, and if you want to trace kinship formation, in-group marriage patterns, you have to read across multiple sections, multiple pages. Very difficult to track something like this, but using digital means, now you converted the medium, you can do something very, very different, right? Something much more in-depth that would have been very challenging to do before. Right? I don't say impossible, because there is a historian who used to be based in Seonggyungwan. The Korea specialist in the audience might recognize his name, Miyajima Hiroshi. It turns out that he did something like this manually 20 years ago. But of course, by digital means, I was able to extract similar patterns that this historian identified manually, but at much larger scales. I was able to identify 60 plus examples of in-group match patterns in the genealogy. Okay? Well, that's digitally mediated approach to historical research, but we're not talking about Web 2.0 at the moment, right? This lays the foundation of the kind of questions I've been asking over the last 17 years or so as a digital humanities researcher. So if you take this idea, right, and then think about, as a digital historian, what does it mean to now, instead of looking at, go back to what Manovich told me, instead of looking at materials from, say, 600, 700 years ago, thinking reflectively about what kind of materials are we producing today and how is that going to reshape the way we do historical scholarship in the future. So thinking about more contemporary materials, right? Of course, in digital history, we tend to use modern technology, cutting-edge tools, software systems, artificial intelligence approaches now as well. But now thinking about what kind of source materials are being generated, and looking toward the future, what will the next generation of historians say and want to learn about today's world? I'm talking about very recent decades, since the advent of Web 2.0. And this brings me to big data studies. There's a much bigger, very challenging topic to pursue. Digital humanities already is a challenging topic, but big data studies, there's something even bigger to consider. So in 2019, while I was in Seoul National University, I was very fortunate to receive one of those high risk, high reward funding. Seoul National University was very generous and provided the funding to create a new lab called the Big Data Studies Lab. And basically, we're thinking about, we spent the last, how long has it been, 6 years, with different members coming and going, thinking about what updates do we need to make to the digital humanities paradigm for the age of big data, the Web 2.0 era. And building on the strength of how we are trained as humanities scholars, we're a global and multilingual team. I believe we operate with 7 or 8 distinct languages, look at source materials very, very carefully. And one of the things that we decided to do is not to theorize hastily. We just started collecting information as to what is big data and what is Web 2.0 and what are data centers. And it turned out to be a very, very meaningful experience. If you're interested in more about it, you can go to bigdatastudies.net. We explain some of the ongoing projects there. And these are the 4 major research areas. And it's not just me alone working on this topic. We have, this is Juyeon Kim, who was my student, now a very successful CEO of an important startup company here in South Korea. Worked with also a student from India, now is a very active software developer based in India, used to work in Canada briefly as well. 2 graduate students who are now based in MIT and University of Southern California. An engineer with a history degree as well, a bachelor's in history and computer science, moved on to Oxford and now works at Google DeepMind. And we have 2 postdoc researchers based in the lab. Just many, many members. These are some of the key members that contributed to the research I'm about to present to you today. So let's maybe begin with this. So instead of rather casual approaches as to what is big data, to provide a formal definition, out of all the definitions of big data, there are only 2 that I really like, that really speaks to me. One is, believe it or not, it's from the dictionary. Oxford English Dictionary, in my opinion, provides the most succinct and most to the point kind of a definition of what is big data. So if you look at this here, of course, yes, it means very, very large size. But what is important here is this second part, and many of us tend to miss this second part. Big data, one of the key definitions of big data is that it contains this challenge. Right? Data has become so big that it begins to present significant logistical challenges. Big data, if it fits on your personal computer, or even a couple of computers that you have at home, that's not really big data. Right? It needs to present significant logistical challenges. It cannot fit here. Right? The historical sources I'm used to parsing in digital history, they're not that big. At most, we're talking about a gigabyte or less. Right? Big data is distributed. It undergoes something called sharding. Right? Files that you see on your Amazon S3, it doesn't really exist in one device. Right? Files are more or less presented as abstractions. Right? For security reasons, for performance reasons, if you have one file, even if it's just 1 megabyte in AWS S3, it will be broken down into hundreds of parts and distributed across this rack here. Okay? And of course, if you scale up to terabyte, petabyte scale, we're talking about much, much larger infrastructure that needs to, in order to make that storage and computing and management possible. So how much data are we talking about is truly astronomical in size. So we went up to 120 plus zettabytes as of 2 years ago. So how much is 120 zettabytes? Is the total amount of data produced around the world by all machines available. Okay? 120 zettabytes, if you were to store 120 zettabytes on a Blu-ray disc, and a Blu-ray disc is able to hold about 25 gigabytes of data, and if you create if you imagine a rack, a tower of Blu-ray discs, which is about 8 millimeters thin, it will reach 14 times the distance between the Earth and the Moon. It's quite literally astronomical in size. And what is shocking about this is that global data production is only growing exponentially. It's quite possible that at this point we already hit 20 to 25 times the distance between Earth and the Moon. So what is responsible for the generation of this much data initially was social media. Now I think we're starting to see new types of data that will replace user-generated content. Okay? Compared to the Web 1.0 era, there's just incredible amount of content as more and more users participate on the web and create content on behalf of the platform providers. Right? We're talking, say, billions of photos being uploaded on a regular basis to Google Photos, to Instagram. Facebook stopped disclosing, so that the data we have about this is out of date by 12 years because of privacy concerns. So they just stopped telling us how much data they have, but we can kind of guesstimate how much data they might be managing around the world. They have so many, the billions of active users, right? And this is also very interesting from my point of view. More than 100,000, so that's 100 millennia of video content is already up on YouTube. Right? So imagine if you're a historian and you just want to focus on video content, YouTube, one platform. We're not talking about Youku, we're not talking about Naver, just YouTube, 100,000 years as of 5 years ago. Okay? There's so much data that in order to transport it, you don't use traditional means. Right? Sometimes you have to bring an entire truck filled with hard disks to transport data between facilities. This is the amount of scale, the scale we're talking about here. Okay? And big data tends to be managed in facilities that look like this. This is Naver's flagship data center in Chuncheon, South Korea. It started out with 120,000 servers. The number of servers actually didn't increase so much in the last 11 years because the capacity just increased per server. Right? But we're talking about 6 figures, right? 100,000 plus. That's very common. Servers in one facility when you talk about hyperscale data centers. And the language being used is also really fascinating from my point of view as a humanities scholar. Right? They use the language that normally we would associate with the National Library of Korea. Right? You leave them behind. You leave behind information about you. Right? And we will protect your information. This is something actually the National Library should be doing. But Naver claims in its motto that they will do it on behalf of the Korean citizens. Right? We will bequeath the records of today to the people of tomorrow. Right? What is going on here? And when it launched, they claimed to have more information than 10,000 National Libraries of Korea combined. Later, that figure was updated to 25,000. The most recent claim is 1 million. Naver alone has more data than 1 million National Libraries of Korea combined. Okay? So is it possible to create an archive of this? What is going to happen in the future? Right? Can we study the 2010s and the 2020s as objects of historical research? Okay? So on this research, on this aspect of archiving big data and how necessarily partial and isolated will have to be, I draw a lot of inspiration from the work of Matthew Kirschenbaum. Right? And something very interesting about this one story here, among many things I learned from Kirschenbaum's research, is one where the relationship between funding and recoverability of data from various type of digital storage materials. Why do I bring this up? Is because digital materials are incredibly fragile. This is research that we already know from the generation of Matthew Kirschenbaum, starting from 20 plus years ago. The contrast between today's digital media and, again, more traditional historical research I do. This is one of the most popular encyclopedias published in the Korean Peninsula in the 15th century. is titled Gujin Shuwen Leiju. In Korean, it's called Samun Yuchi. In the court of King Seongjong, every official present in King Seongjong's court wanted a copy of this massive encyclopedia. It's multiple hundreds of volumes in size. Right? Very high quality. And when I was a PhD student, I was very interested in book history. That it turned out to be one of my PhD fields. I wrote a paper about this encyclopedia. It's so durable that the librarian allowed me to bring it to class. This is more than 500 years old. This is incredibly durable. Can digital media last so long? It turns out that it cannot. Right? There are some newer technologies that I will show you in a bit. But in most cases, the devices that we use today and also the data center facilities that provide the online service that we rely on are designed for real-time processing, to be short-lived, for performance only. Right? It's not meant to last for centuries. Okay? Which means from a historical perspective, this is no longer going to be possible. Right? The kind of serendipitous discoveries that historians make. One good example is this is a desert oasis town in the region called Dunhuang in China. And a series of discoveries really ended up groundbreaking for the field of East Asian history. We found documents related to Shilla here. There were Shilla pilgrims on their way to India, and there are some records about them here. We were able to do social history of the Tang Dynasty using divorce agreements, land deeds, and so on. Documents that were not intended to be preserved were preserved because the documents managed to last for centuries. But what if your sources are e-waste? Is it going to be possible to read 500 years from now, let alone 20, 30, 40 years from now? Kirschenbaum actually argues that it actually might be possible, but you might have to prepare to spend something like $30,000 per hard disk. Okay? This is something we discovered when we had Wall Street very sensitive financial information in the September 11th terrorist attack, and they had to recover data because it's worth so much money. And for each hard disk, they took it to a forensic specialist and spent $30,000 each, and they were actually able to recover data. It might be possible that if you were prepared to spend that much money, it's possible to recover it, but in most cases, it will be lost forever. Okay? And of course, web archives, right? The internet is ephemeral. Okay? If the server goes offline, unless you have a snapshot of it, it will disappear. Thankfully, we do have some responses to this conundrum since the 2010s. We do have some media like M-Disk that is meant to last for 1,000 years. It's also sunlight resistant, humidity resistant. We also have experimental storage devices proposed by Microsoft Research that is meant to last for tens of thousands of years, possibly maybe 1 million years. But in most cases, the industry still uses backup media, backup storage that is only lasts for about a few decades. But it's not simply a matter of storing 25 gigabytes, 100 gigabytes at a time like this. The scale is just incredibly large. So the Library of Congress in the United States, a while ago, this is almost 10 years ago, attempted to make an archive of the public-facing collection of tweets. And we're talking about Twitter in the early days. This was back in 2015, 2016. Twitter was much smaller compared to today, right? And also wasn't owned by Elon Musk back in the day, right? So much smaller scale compared to today's Twitter. They tried to make an archive of Twitter, and it completely failed. We take this for granted. But what happened when the Library of Congress tried to make an archive of Twitter? If you make an archive of Twitter, you need to enable search. They try to run a keyword search on this massive data set. You know how long it took to execute one keyword search query? It took 24 hours to return the result. We expect instant results when we use these platforms. The amount of engineering capacity, the infrastructure required, the computing power required to make that possible, we take it for granted. But even the Library of Congress struggles with this. And that's just Twitter. There was actually an attempt to make an archive of Twitter, but in most cases, a lot of these online platforms disappear on a regular basis. What is happening to video game worlds? Very important in South Korea, right? Among many other places. And other similar social media platforms as Facebook, like Cyworld, right? Almost went offline. Right? It's still not archived properly. Right? What is going to happen with that? Right? But there are also other characteristics of big data, and here I'm relying on Doug Laney's, this is the second definition of big data that I really like, notion of 3 V's. You may have heard of this: volume, velocity, and variety. Okay? Talked about volume so far. Big data isn't simply about volume. It's dynamic in nature. It's sharded in existence. At the moment where you have something managed by a cloud service provider, data is broken down and sharded across multiple devices, right? But it's also streamed constantly. It's not a static data set that we are used to seeing in digital humanities research. And also, a lot of these online service providers provide services to a global audience, so data moves around. A Facebook user based in South Korea, if you have any data that is no longer active in use, you would quite likely migrate to another facility that manages cold data. Cold data means low usage data in a facility in Oregon. Another unique characteristic of big data is that it moves around constantly. Okay? So jurisdiction matters. It's hard to locate and pinpoint exactly where. Also makes it very difficult to contextualize what it is, right? And new types of data being generated. Right? Beyond user-generated content, increasingly we have new types of sensors. Depth sensors, LiDAR scan, time of flight, infrared, location, user behavior. Quite intrusive, actually. When you're browsing through Instagram, a lot of these apps and web browsers do tracking as to where your cursor is going, where you're paying attention to. A lot of this information is being collected for various reasons, for advertisers, for the companies to gain more insights about their user base, etc. Potentially could be an incredible historical source, but also there are many ethical considerations to keep in mind here, right? And creating a profile of you. Right? You can actually access this yourself if you have a Google account. Right? Everything here is correct. It's all machine learning generated, except I'm not a high-income earner. That's the only thing that is incorrect here. But I do have an advanced degree. I am interested in technology. All the languages that I know. Age is actually correct. Right? And this, something that we have become much more aware of in recent years with the rise of generative AI, the energy requirement and resource-intensive nature of Web 2.0 infrastructure. I do have a study coming out in January. It's taking a long time for the publication process to go through the editing and etc. So I actually finished drafting this chapter before ChatGPT came out, and I had to make some updates in the conclusion to talk about ChatGPT. But it basically talks about how digital media and non-digital media have different, very distinct energy requirements. So if you think about how non-digital media, it could be energy intensive. If you think about a bronze inscription or even wood block printed books, it requires certain resources. You need human labor and so on. There's energy input to create the resource. Right? But to read it, you simply just pick it up and read. Interesting thing about digital media is that in order to retrieve and read the data, you need an energy source, an external energy source. It's not a big deal if your data set fits on your computer, Even if everything else goes wrong, all you need is a solar panel, and you can power up your notebook computer. But what if your source is big data, right? And you scale up. Naver's data center is connected to 6 hydroelectric power stations. What do? Right? We also saw the problem in the Library of Congress. Archiving itself was a challenge. What if you do succeed in archiving? How are you going to power the servers in order to retrieve the information you're looking for? Okay? So we started in a very micro scale, started measuring how much energy is required for input and output, for reproduction and for production and preservation and so on, and explored various kinds of proposed laws, predictions that failed, started measuring individual units of a server, of a storage device, of a computer, and then try to scale up and think about the energy costs needed in order to retrieve and also process data. Okay. So, infrastructure of Web 2.0, something called big data studies. But I think many of us here, because of the times that we're in, might be interested in the last bit that I want to share today. And I'm kind of more used to talking about this aspect of our research than infrastructure these days. Something called algorithmic reading. So assuming that the infrastructure problem can be resolved, how do we read big data? Right? And here, our traditional research and more big data-oriented research began to converge a bit. So we started out about 3 years ago with an attempt to make a custom large language model, not really that large, but transformer-based language model for classical Chinese exclusively, and has some interesting results. Made some embeddings out of it. We noticed that custom models outperform commercially available solutions or other competing solutions available on Hugging Face. But went a little beyond and try to propose a general framework so that we find general workflows that most historians share and think about how deep learning can be applied to our understanding of the past. Come up with a framework called Deep Past. Some of the details of what Deep Past project is about is available on our website, but basically comes out like this, where using is an iterative pipeline where we use what we generally call AI, right? So transformer-based machine learning, to create various types of outputs. So we're not simply summarizing or using chatbots, but pre-processing historical sources. We are starting out with pre-modern materials, but we are slowly transitioning into more recent materials like web archives and Web 2.0 snapshots. And then creating custom models to analyze and process. After pre-processing, gain insights from the materials. We have various pilot projects to experiment with this approach. We're making basically AI modular so that each module specializes in a very specific task only. We're not trying to create an artificial general intelligence. Right? The human researcher is always in the loop, and we're treating AI as an information retrieval system rather than something that is a sentient agent that is able to conduct things without human input. Right? But the custom-made task-specific models do have to perform with very, very high accuracy. One experiment we did, I'm going to show you a quick demo, is something called virtual philosophers, AI philosophers. You can choose, this is developed by our postdoc, Choi Dong-hyuk. Some of you might know him. Yes, you know him. David Hume, Voltaire, and Juche are available. You can talk to Juche, you can talk to Voltaire in any modern language that you wish. Of course, Voltaire left behind his writing in French, Juche in Chinese. You can speak to Voltaire in Korean, in Japanese, or in English. You can ask some very challenging questions about ancestor worship in Neo Confucianism. Right? You can also use something like this to create convert your course syllabus into an AI system attached to a knowledge base. This is an experiment I'm going to show you in a live demo. This is my Introduction to Digital Humanities course converted into embeddings. Right? And you see where the professor is located in this conceptual map of various ideas that have been proposed in the digital humanities community. Right? Each point here represents a paragraph, right? And you get to see basically digital historians are here, Matthew Kirschenbaum reference earlier is here, and I am situated somewhere here. Right? I'm not a literary scholar, so it makes sense that I'm here, but I'm also not a Milligan-style digital historian at the same time. I do have some connection to Lev Manovich as well. It's very interesting. We didn't provide any citations. Purely by semantic representation, we got something like this. We also work with low resource languages, like Manchu, right? For early modern Chinese history, very important, right? And we're also trying to go a little more advanced and work on something that was very difficult to do in the past, before the rise of transformers and generative AI, which is a digitally mediated approach to intellectual and cultural history. So this is what we are working on. So one of the things in the pipeline, what we're doing is a lot of the technology related to AI today, generative AI, relies on semantic representations. By that, I mean meaning, right? So it does a really good job. If you make embeddings using AI, using an embedding model from OpenAI, from QN, from a model provided by LG, etc., or Naver, this is all done by semantic representation. But historically, writing wasn't simply about meaning. Writing was also about the writing style, rhymes, rhythm. Right? Korean, not so long ago, had rhythm. Some of the vowels had to be elongated, and it would have a different meaning. Nun, as in I, and nun, as in snow, are pronounced slightly differently. Can a language model capture those nuances? We're trying to train a custom model that captures those nuances. In classical Chinese, it matters a lot. Right? I did a translation project with a very distinguished professor who's in his 80s now. He reads classical Chinese very differently than I do, because he was trained in the old way. The way you read matters. The rhyming patterns matter. Even when you read prose, trying to create another workflow that captures those nuances. But also new types of search that this new paradigm will enable. So much of what we do, we take this for granted, relies on keyword search, which has been groundbreaking. My research has been influenced a great deal by keyword search being enabled on the corpus that I examine in traditional research. But what if it can use embeddings to find materials that, say, for example, if you're looking for articles that talks about tiger as a theme, as a topic, but doesn't mention the character tiger in the article. We do encounter many situations like this. This is one of the reasons we have trouble finding materials when we try to revisit something. When you remember something in the back of your head, try to find it, but you cannot remember exactly where. One of the reasons the keyword search doesn't return the result you're looking for is because maybe that keyword is missing. How do we do this? It turned out to be actually quite a challenging task, but we are working on this right now. Can we combine also, make a hybrid search mechanism that combines keyword and also semantic search? Okay. So this is using the generative AI paradigm to study more traditional historical materials, but it is possible to develop methods with sources that we're familiar with to now begin thinking about something more recent, such as the GeoCities Web Archive. Right? Hundreds of terabytes of data captured by basically a team of hackers. It was never formally archived, but it is available on torrent. Right? How do we browse through this? Right? So can we use algorithmic reading to browse through this? And unfortunately, Web 2.0, social media, quite likely will not be archived as cultural heritage for future research use. But what we will have is individual users who volunteer who voluntarily make snapshots of their user data, and hopefully will make it available for future researchers to investigate, right? Which means it will be removed from its context. Web 2.0 data necessarily will be captured in snapshots, isolated, and as static data sets, even though its original existence was not in the form of static data sets. And hopefully we will have a very, very tiny portion of the data that we're generating out of the 120 zettabytes plus. Not even 0.001% will survive in the future. But hopefully even that will be so enormous that we will need to rely on an AI system to even browse through and investigate. So that is algorithmic reading. And the last bit is trying to run all these things locally in an environmentally responsible manner, right? So we try our best to run our compound AI systems using low power machines locally, right? On your laptop or Mac minis or a server that runs in our own lab. Okay, so this is the end of the presentation, but I want to just show you very quickly before we take some questions what I just mentioned. This is AI philosophers, and it's a very simple retrieval augmented generation system, and this is you're asking questions. So Professor Park Jin-ho mentioned that new ways of learning, right, enabled by generative AI. But I've been increasingly thinking about, I originally designed these platforms to help my students, but sometimes I find that it's so incredibly useful that I started using it for lecture prep. And eventually we want to make a spin-off platform that is designed for research use cases. Right? So here's an example of a Neo-Confucian question, philosophical question, and every entry here you'll find a citation. The answer is based on, it's also a way of exploring this semantically. You could say that this summary here is a type of semantic search. Right? It's very hard to ask a question like this using keyword search, right? But this points to a specific source. Here's the Manchu system. You can actually go to this link and try it yourself if you have a Manchu document. And the last thing is that this is the teaching platform I mentioned. And I've done all kinds of interesting experiments this semester. One of the things I did is because generative AI translation is so good that I started assigning articles in Korean to students who cannot read the Korean language. So now they can learn about South Korean historiography, say, article written by this professor, Lee Tae-jin. I assigned it in Korean and in GPT-5 translation, and also made this available in this AI learning platform. You can ask questions about it. All the assigned readings, ask questions about historiography. You can select a portion of the syllabus, and students can also contribute their own documents and ask questions about it. Or if they're stuck, they can also ask, I'm stuck, can you help me formulate some questions? Okay. It's meant for students, but I think we're going to eventually see this being used regularly by professional researchers like ourselves as well. Okay, so I will stop here. Thank you for listening.
Yeah, thank you very much, Professor Chap, for your inspiring keynote lecture. What I found particularly fascinating was your point that our culture and historical traces, what we write, record, and create, are now being preserved as digital data. It's fascinating to think that these vast traces, when combined with artificial intelligence, can lead to entirely new research methods in the humanities, offering fresh ways to explore meaning, context, and connection. This shift not only transforms how we study the past, but also opens new ways of thinking about the humanities in the age of big data. And I must admit it also made me think perhaps it's a relief that some of the old things I wrote online when I was younger didn't survive the digital record. Yeah, maybe forgetting too has
Felt the
its
same way.
place in the age of big data. Yeah. We now have a few minutes for questions or comments from the audience. If you'd like to ask a question, please raise your hand and our staff will bring a microphone to you.
Need a microphone.
Hi, thank you for the wonderful lecture. I truly enjoyed that. So my background is linguistics. So I don't know much about history or literature or even data storage things. But my question, it seems that you make a clear distinction between computational approaches and digital approaches. So you mentioned that, but I still don't get it quite. So what is the difference between the two, if indeed there is a clear distinction between the two methods? So one of your slides,
Yes.
I remember that it's a digital versus computational. So to me, there is a huge overlapping. So making a clear distinction between the two is not that easy. But that was my understanding from your talk. Thank you.
I think it's one of those distinctions that is useful to conceptually make them distinct, but in practice, there's of course overlap, right? One thing that I would say is you are creating your own data set. You are digitally transforming something. So in the case of more traditional digital humanities research, the sources that we're looking at were not originally in digital form, and then we digitized it, right? In more traditional quantitative and computational approach, you either tally or you basically abstract an information from the source without preserving the original source material itself. But you have to go through a conversion process.
Okay,
right?
so that means digital method implies some types of archival properties. Am I understanding it correctly?
That is one way of looking at it. It's
Okay.
primarily about medium,
Okay.
whereas computational to me is method. You can use computational methods on now a source collection that is now in digital media, right?
Thank you. Any question?
I can also add one more thing. There's a scholar named Ted Underwood, who in the very beginning of the transformer paradigm, when BERT was first introduced, he wrote this wonderful piece in the Chronicle of Higher Education, where he kind of made a very distinct prediction that turned out to be mostly true, that machine learning approaches are becoming so sophisticated and so multidimensional. Literally has, I think OpenAI ChatGPT has, like GPT models have 3,000 plus dimensions. The distinction between quantitative and qualitative approaches are going to be blurred. And I think with the rise of large language models, we are starting to see the blurring of the two. So it's a very interesting question and a very complicated question. It is possible to be interpretive, but also computational. Whereas we are so used to thinking that computational approach necessarily has to be quantitative and has to involve statistical modeling. Yeah.
Thank you.
Okay, thank you very much for your presentation. It's been very interesting. I know that the fact that we have more and more information poses some challenges, which is higher energetic cost. And well, we have a lot of problems with that, with spending more energy, et cetera, et cetera. However, there is one aspect which I don't know if you've addressed, but is the fact that now information is more available to everyone. It means that the access to information is more democratic, let's say. So obviously it comes to a cost. I mean, we have more energy that needs to be spent, etc., etc. We have more information, but there is a positive outcome, which is the fact that now information is available to almost everyone. I mean, there's internet connection, which is worldwide available. And I think that this is a positive thing. Do you think that the cost of managing this huge amount of information is worth, because now it's more available to more people?
I see. One thing I've been hesitant to do in the Big Data Studies Lab is making a judgment call. We try to make observations first. I have my own personal thoughts on this, but we found that as a researcher, found it much more fruitful to simply find details. And also because there are activist groups and there are environmental movements, they write articles about the environmental costs of running infrastructure like this. The building of nuclear power plants has received a lot of attention with the rise of generative AI. These are all valid concerns from my point of view. But I also found that sometimes the details can be quite misleading. So just finding reliable information has been the priority because we're academic researchers, right? Is it worth the cost? Instead of answering that, I would say something new is happening. And I think it's, from my point of view, something that has been already ongoing. And that is that historians we take this for granted largely, but we are used to seeing primary sources that are made by human observers. Or you have a hearsay and then you make an account about this. Right? Increasingly, we are producing, in today's world, source materials that future historians will use that are not generated by humans, but they're making very, very detailed and precise observations about the world. And a lot of those things come from sensors. There's in philosophy of technology and STS, there are discussions about how we have become like 6 billion human individuals that are not really human, we are cyborgs. We carry a smartphone. We tend to underestimate how sophisticated this device is. There are sensors in this device that are collecting all kinds of data in real time, right? And could be potentially useful as, they are basically future primary sources. But what is starting to happen now with generative AI is that what we used to call user-generated content has a direct machine mediation. We use ChatGPT, DeepSeek, etc. to refine our phrases. Or we use a touch-up when we upload a photo on Instagram using an AI enhancement tool. Right? So increasing the content themselves are human-machine mediated. Right? They're a hybrid form. What are the implications of this? I'm not sure, but we are basically observing at the moment.
Yeah, just one more question.
Thank you so much for the great lecture. I learned a lot. Actually, because I'm an English professor, I want to learn more about the kind of multilingual aspects of your research, because when I was learning about the kind of current digital archives and like using generative AI to translate English into Korean and Korean into English, and checking the capacity that Naver created recently, HyperCloverX, they advertised it so widely that this is a very smart generative AI for the Korean language. But when I asked some questions in Korean, the level of the Korean language that HyperCloverX was speaking was very low. And so I asked Clover, how did you learn Korean? And it said, I just read blog posts. And I was thinking the level of the English language that the ChatGPT was using, it was so elegant and sophisticated. And Hyperclover X was just using Naver blog posts and without accessing the kind of Korean articles, academic articles that uses very elegant academic language. And I was impressed by the scope of the multiple languages that your research is touching on. Like you're using Korean, like 지아밀기, the old Korean, and contemporary English, and also Chinese characters, and you said you briefly used some translators, like generative AI, to translate some of the Korean text into English, so that the people who cannot speak Korean can access the materials. But how do you evaluate the level of the translators, capacity that was using digital methods? And can you tell us more about the current status of the multilingual capacity of your archival research and that uses generative AI or digital tools? If there are some limitations, and if you're using human speakers to judge and evaluate, what are the kind of most desirable standards? And
Sure.
Thank you.
I think that's a wonderful question. And I think this is a reason we prefer to run our systems locally, because we have more control over this. So one of the reasons the Web 2.0 paradigm really took off, and we continue to be a part of this, is if you think about how Google designs its interface, it looks like this. And ChatGPT also looks like this. We call this minimalism, right? Minimalism has its advantages. It feels very clean, very easy to use. Online platforms, they're cached. There are all kinds of mechanisms behind the scenes, infrastructure that makes that possible when you book a flight to go on your business trip, for example. But the users don't have control over this. It is possible to click on some settings and maybe make it more advanced. In the case of ChatGPT and most general purpose large language model systems, don't really give you access to that. But if you run your own, you can change your prompts. You can customize your system prompts. So I think, so this is made by our wonderful team member, Tongyak, in the back there. This is a custom system that we run locally in our lab server. So GPT OSS 120 is loaded here. It's also possible to load this on your own laptop. This is GPT OSS running on my MacBook Pro right now. I actually asked the question about, tell me something about Korea University. You can try that again. Try one more time. And just to show you that it's actually running on my computer. It's running locally, on battery actually, very low power, right? It's supposed to be just almost as good as GPT-4. But here you see that you can change how much reasoning you want to introduce, how much randomness do you want? Do you want it to be more creative but potentially hallucinate, or you want to control this more? But generally what we need to do is, as domain experts, not to rely so much on a system that is meant for generic, general purpose use. That's why we encounter problems. We are subject experts. We should treat increasingly large language models as speech emulators. They're very good at predicting the next token, speaks like humans. That's why it kind of fools us into thinking that this is artificial intelligence. Right? But if you want very specific domain knowledge, that domain knowledge has to be separate from the language generation part, which is why DeepPath has a modular approach. If you look at Nabi, the domain expertise coming from the readings on the syllabus are separated from the large language models that generates the natural language that students encounter. The language part, because it's open to any model that you choose, you can actually enable interaction in something like 150 to 200 modern human languages. But this part is made by using something called embeddings. And this requires a different type of model. And this part, we are discovering that it's not as multilingual as we like. So the English embedding models and the Chinese and the Korean ones have to use different approaches. And it's hard to also make them compatible. But once you have something like this going, it's also possible for you to choose. So what is hidden here is that we give the user control. You can choose GPT-OSS, QN, Claude, or Gemini. You can also add additional models and see which one does the best job. How do we evaluate this? You evaluate this with the input from the subject expert, which is the teacher, you. Yeah, I think that's the important part here, right? It's not going. So the discourse that we have in the media about AI replacing workers, etc. Yes, there will be some of that, but I also think it's a little bit too hyped up. This is, I think, where it's headed, but it's going to also change the expectations of what we do in the classroom and what we do in our publications. Just like how digitization and keyword search change, we can also reflect on this, how it has changed our research in the last 20 to 30 years. Imagine doing research before JSTOR, imagine doing research before digitization of all these pre-modern materials. Research has changed. We haven't reflected so much on this. Some of us have not, but AI will have another paradigm shifting influence, and we'll start thinking about, reflecting on what are the implications of this.
Okay, thank you. I'm sure many of you still have questions or comments, but unfortunately, we are running short on time. So please feel free to ask continued conversation with Professor Javier Cha during the lunch break. So this concludes the keynote session. Please give a warm round of applause to Professor Javier Cha.
Thank you.
Yeah, before we conclude, just a quick announcement about lunch. For those who registered in advance, lunch sandwiches are prepared outside. Yeah, outside the conference room. We will start session 1 at 1:10 p.m., so please enjoy your lunch and be back here on time for the afternoon session. Thank you. it's time to begin our first session. Please have a seat. 네, 잠깐만 계시면 될 것 같아요. Good afternoon. Hope you enjoyed good lunch and maybe a nice cup of coffee to help you get through the afternoon sessions. Welcome to session 1, Big Data in Society and Culture. My name is Seung-Eun Lee from Korea University, and I'll be moderating this session. We are pleased to have 3 distinguished presentations this afternoon, each of offering a unique perspective on how big data and computational approaches are transforming our understanding of literature, culture, and humanities. Each speaker will have about 30 minutes, and a 10 to 5 minutes warning will be given our assistant toward the end of each talk. After all the presentation, we will have a discussion led by Professor Soo Her from Seoul National University and Won-hee Jo from Yonsei University. Thank you for joining us today, and let's begin with our first presentation. Our first speakers are Professor Jong-won Park and Sarah Ellefson from University of Minnesota. Professor Park from the Department of Linguistics at the University of Minnesota specializes in syntax, morphology, and digital humanities research, connecting linguistic structures with computational text analysis. Professor Ellefson focuses on 20th century American and British literature, bringing in perspectives from women's and gender studies, trauma theory, text, and the digital humanities to explore how literature represents trauma and recovery. Together, they will present trauma expression analysis across English translation of All Quiet on the Western Front. Please welcome Professor Park and Professor Ellefson.
Good afternoon. Thank you for being here today. It's an honor to talk about the work my colleague Jong-won Park and I have been doing. A special thank you to Korea University and the Korean Association for Digital Humanities. Our talk is organized in 5 parts. We'll begin with a brief discussion of contemporary debates around war, gender, and trauma before introducing the novel and some theoretical context surrounding our work. We'll then introduce the impetus for our research and our research questions. Next, we'll discuss the methods of our study and our results. Finally, we'll offer some thoughts on our findings and potential next steps. To begin, let's take a look at how a novel that's nearly 100 years old still has deeply contemporary applications. You see on the screen here the American President Donald Trump, who's in town this week, and his pick to helm the department formerly known as the Department of Defense, Pete Hegseth. The year before his nomination, Hegseth published a book entitled The War on Warriors, Behind the Betrayal of the Men Who Keep Us Free. The War on Warriors argues against having women in combat roles, and as Secretary of War, Hegseth continues to raise the debate. In a speech just earlier this month, he argued for what he termed the, quote, highest male standards of military preparedness. The assumptions that underpin Hegseth's concern reverberate in discussions that surround war fiction. And as we'll see, All Quiet on the Western Front is a novel that lets us explore the complexities of militarism, combat, and trauma. All Quiet on the Western Front was first published as a German-language serial in 1928 and as a German-language book in 1929. Due to its popularity, the novel was promptly translated into 23 languages, including Arthur Wesley Ween's 1929 English language edition. This is the edition most English-speaking folks encounter. And I should note, Ween was chosen for the job in large part due to his status as a World War I veteran, the same as Remarque. Though in fact, Ween had significantly more experience than Remarque at the front. Remarque was wounded after 6 weeks and spent the remainder of the war in hospital. In 1993, the civilian Brian Murdoch gave a more faithful translation of the text. Katharina Rout prepared her translation in 2024, and Kurt Beals released another edition just this year. The research we'll be discussing today focuses on Wien, Murdoch, and Rout translations. This gives us 3 takes on the novel: Wien, a male veteran; Murdoch, a male civilian; and Rout, a female civilian. In terms of the novel itself, the text has had an outsized impact on the English-speaking imagination and understanding of the real experience of war. The novel is generally read as a Bildungsroman, or a coming-of-age story. Its narrator, Paul Baumer, is a young German soldier who enlisted along with his classmates at the behest of their school teacher. However, while the novel gives a first-person perspective on the experience of basic training and deployment to the Western Front, it also offers a nuanced examination of what modernists would call the rift between conventions of the past and the new reality, a reality created in part by the new technologies and the scale of the destruction of the war. The novel opens with this epigraph: "This book is neither to be an accusation nor a confession, and least of all an adventure, for death is not an adventure to those who stand face to face with it. It will try simply to tell of a generation of men who, even though they may have escaped its shells, were destroyed by the war." We take this metatextual element as a key signal that the novel offers insight into the psychological destruction, meaning trauma, of World War I. Our approach to this project draws from 4 main disciplines: literary theory, trauma theory, translation studies, and the digital humanities, specifically computational linguistics. From literary studies, we acknowledge that it can be tempting to make claims based on idiosyncratic close readings. To counter this, we believe that computational analysis can offer a backstop to stretching too far with our readings and interpretations. From trauma theory, we argue that understanding psychological trauma can help us better treat and support populations impacted by military conflict. In other words, borrowing from Phil Cly, we posit that civilians have a moral stake in war, as well as in the well-being of service members and the military affiliated. And from translation studies, we recognize that different translators make different choices that both reflect and shape their contemporary moment. We believe that understanding the choices in various translations of All Quiet can help us see these historical moments and ourselves more clearly. Now to 3 key considerations that guide our work. First is that, as a diagnostic category, trauma has a complicated and much debated history. For example, psychological trauma has been known by conditions including railway spine, hysteria, neurasthenia, shell shock, post-traumatic stress disorder, and more recently, moral injury. Crucially, contemporary debates frequently center on the unrepresentability or unsayability of psychological trauma. This is an assumption our research seeks to engage with. Similarly, war, specifically combat, is often understood as an epistemologically separate category of experience. The literary scholar James Campbell coined and resisted this notion of combat Gnosticism. Finally, we acknowledge that metaphors, as well as literature and film, have the power to create a reality rather than simply give us a way of conceptualizing a pre-existing reality. And as we see at the highest levels of debate within the Department of War, even today, the representation of military affiliated and the traumatized influence our perception and thereby reception of their counterparts in the real world. That brings us to the impetus for our research questions. First, as Kiyoshi Gu, a literary scholar, argued just this year, those who have experienced trauma possess distinctive perceptual frameworks that remain largely inaccessible to those who have not shared in the same encounter. This is the assumption that guides much reading, writing, and discussions around military and veteran experience. This assumption is so pervasive that it leads to the idea that the veteran experience is inaccessible to civilians, or that trauma is literally unspeakable or unsayable. Then, as Brigitte Bush and Tim McNamara argue, linguistics may play a role as one of several approaches to the study of trauma, described as a complex knot that binds together multiple strands of knowledge and which can best be understood through plural, multidisciplinary perspectives. And linguistics seeks, on the other hand, to explore to what extent engaging with trauma can contribute to a better understanding of the discourses of the unsayable. Put differently, while it may be true that things can be hard to speak about or unpleasant to hear, computational linguistics may offer an opportunity to better understand these challenging, though not unsayable, experiences. The pervasive assumptions about combat Gnosticism, the unsayability of trauma, and questions of who has access to these experiences led us to 3 research questions. First, how stable is the language of traumatic experience when it is refracted through different translators and different publishing contexts? Second, do veteran translators have special access to the discourse of trauma due to their veteran status? And third, a comparative close reading suggests that the non-veteran translators psychologize the narrative more. We want to ask, does a computational analysis yield the same result? Before we explore our methods, I'd like to share our findings at the outset. Across aligned sentences, Wien, Murdoch, and Rout's translations are largely equivalent in their trauma-relevant signals. Where differences appear, they are small, localized, and not systematically attributable to translator identity within the limits of our measures. The instruments show convergence on broad patterns of traumatic affect, even as they highlight specific loci where lexical and semantic choices admit modest variation. These results suggest that All Quiet exhibits a robust, translatable core of trauma language that survives re-expression by different translators, while still leaving room for meaningful, fine-grained differences that critics can explore through close reading. And now Dr. Park will discuss our methods.
Okay. Already I feel like we are running out of time, so I will make my portion short and sweet. And mine is not that exciting, like Sarah's. And I had to generate lots of Python scripts for my part. And I learned first programming in Python from my former teacher, Richard Sprott, who is sitting over there. So thank you so much. If it does not work though, then maybe that's not my fault. I don't know. So now, okay, I'm going to walk through our methods. Once again, if we are running out of time, I'm going to skip most of my slides. I'm going to explain what we measured, how we built the data set, and how we tested for meaningful differences. I'm going to also show how 3 complementary instruments let us see explicit wording, semantic fields, and inferred emotion. Think of this section in my portion as the blueprint that holds the results together. This is the overview. Our goal is strikingly simple and straightforward. We compare how 3 English translations render distressed language in dialogue and interior thought. So we align content at the sentence level so we can compare apples and apples, apples to apples. Then we score each sentence 3 ways. The first tool we used is called LIWC. It's a psychological word classes, determined and identified. W matrix tags semantic domains. Go emotions with BERT estimates fine-grained emotion. Combined, they give a fuller read on trauma language. So before I show the method, okay, I have to justify why we chose 3 distinct tools, because each tool sees a different slice. LIWC is a dictionary-based. So it counts words linked to anxiety, sadness, anger, or self-focus, etc. That anchors us to concrete lexical choices. So it's really tied to lexical words. W matrix, a little higher, okay, groups words into semantic fields. It can treat panic, shell shock, and panic attack as one domain, even if phrased differently. And this widens coverage beyond fixed lexicon. Of course, BERT, that one, reads context as well. So it assigns probabilities to emotions that often signal trauma. So you can register fear or grief, even when explicit terms are absent. That helps us figurative language or understatement. Using all 3 reduces blind spots and cross-validates what we find. This is our pipeline. The diagram here shows the flow, our workflow. We started with the manual separation of dialogue and interior thought. So I'm going to explain why we did so. And we split into sentences, then align translations within a tight window. Then we exported 1 file per sentence per translator. After that, we scored with LIWC, W matrix, and Go emotions. Finally, we merged outputs and analyzed the aligned triplets. Each step keeps provenance and supports checks. So, as Sarah explained, the translations, we compared 3 translations, Win, Murdoch, and Route. This best limits content to dialogue and interior thought, because we assumed that the characters' direct voices, where distress cues are clear, are found in those parts, not the narration part. And also we kept surface forms, which means no lemmatization, because the tools already provide the lemmatized forms. So as a result, we retrieved and we extracted a clean, comparable subset across translations. Then the separation, initial separation, was done manually, but we made, particularly Sarah, made clear rules for our assistants. So they followed our guideline. We started first with the rules, that we didn't change it later. So the assistants followed our guidelines, and when there were some disputes, and we advised and give some information. And we also used conservative rules for sentence splitting. We respected titles, initials, ellipses, and quotation fragments. So multi-sentence lines were split so that alignment and scoring run at the sentence level. This makes cross-translator comparisons precise and reduces noise from long terms. So local alignment here. So the translation, as you know, can be different depending on translators. That means translator A's first sentence is not always sentence 1 in translator B's translation. So we extended the window ±5, so we found the best match using TF-IDF. But on top of that, for short words, we use short word sentence, we used character 3 to 5 grams. And the result here is clean, Murdoch, Win, route sentence triplets. So sentence by sentence alignment. So I call it local alignment. The per sentence export, 1 file per sentence per translator to feed external tools that work by file. And after scoring, then we reattached all metrics to the same row. Okay, that's what we did. And W matrix post-process, it was surprisingly hard for me because the output was in HTML, so I had to code. Okay? I had to create lots of scripts to clean the data. So yes, okay, after cleaning it, we got the result. Then the measure, okay, LIWC scoring. Once again, LIWC is based on lexical entries. So we calculated, and W matrix calculation, okay, was done automatically. And I used BERT, Go Emotions. And Go Emotions assigns probabilities to many emotions. So for trauma, we sum sadness, fear, grief, remorse, and nervousness into a soft score percentage, which means we averaged the scores. So Go Emotions have total over 27 emotions, but we chose 5 and we averaged it out. But all 3 tools now output different numbers, so we have to standardize or we have to normalize. So we used pooled z-scores across translators. So scales are comparable. So after that, we built mixed effects models with a random intercept for utterance. Each sentence brings its own baseline intensity from the source. So the model separates that from translator style, which means our interest is in the translator styles, not the original text intensity. After that, we used 2 one-sided tests. The smallest effect of interest is plus or minus 0.210, because this is convention. Then after that, we did a little bit of a sensitivity check by increasing the number to 0.15. Then quality checks and reproducibility. So we recorded everything. So we created everything using Google Colab's notebooks. So anybody can run the same analysis with the same data. So the total we retrieved, extracted was 1,038 sentences. And once again, we extracted only thought and dialogue. The results here, this is forest plot. And look at the plot here. Each dot is a paired mean difference for a translates pair. So bars show uncertainty. Dotted lines mark plus or minus 0.1. So win and route are equivalent. Murdoch's is slightly lower than both unselected LIWC categories, yet close to 0. The practical gap is really small. This is W matrix tool, the forest result, the same layout. All 3 pairs fall within plus or minus 0.1, which means practical equivalence on trauma-related fears like death, injury, and fear. Semantic domain choice appears stable, which means W matrix, again, across the translators at aligned sentence. The final one is Go Emotions. The neural emotion score shows a nuance. Murdoch and Win are equivalent. Pairs that include route show small shifts that exceed the 0.10 band. But still, these are modest. They suggest route's rendering sometimes carries slightly higher or lower inferred effect than the other 2. So what if we extend the window slightly more? So threshold widened to 0.15. Then every text falls into the same range, which means practically they are very stable. So this is a pairwise scatter of method signals. Unfortunately, this is not that pretty because they are so similar, so it's really hard to read. So here each dot is a sentence. I assume that you know the scatter plots, but it's not that great. So I will show just one example here. Okay? Here, the middle right panel, that one, okay, it's just a vertical, right? Go Emotions on the y-axis and W matrix on the x-axis. The vertical spread shows co-emotions differentiates among sentences more along those domains, while W matrix is flatter there. The two cover related ground but respond with different sensitivity. So blend Altman agreement now, I'm showing that. So the plot here compares the average of the two scores against their difference. The center line is near 0. That shows broad agreement with natural scatter. So co-emotions runs slightly higher than LIWC on average. The typical spread between them is about 0.038 in standardized units. I'm showing another blend Altman agreement. So I'm gonna just sum up the result. And across dialogue and interior thought, trauma relevant language is stable across translations. W matrix shows full equivalence at 0.1 for all three translators, and LIWC and co-emotion show small localized shifts, all pairs equivalent at 0.15, more extended unit. So if I summarize everything in one sentence, different translators render distress in speech and thought in very similar ways. Any differences are small. Of course, okay, we have lots of limitations, so I will not read all of them, but one conspicuous limitation is, say, co-emotion was trained on modern English data, but the text we are dealing was from 1920s. So there is a big difference. And what about the historical gap between the two? And then, so sentence level analysis definitely loses cross-sentence build-up, irony, and extended metaphors. So we are planning on those things too. So Sarah will close our talk. Thank you.
For a very brief discussion, first, our research inquiries were: how stable is the language of traumatic experience? Do veteran translators have special access to the discourse of trauma? And it does appear, upon a close reading, that the non-veteran translators psychologize the narrative more. Does computational analysis bear that out? First, we found trauma is sayable. All three translators are talking about trauma, and to largely the same degree. As Paul Fussell suggested in The Great War in Modern Memory, we have made unspeakable mean indescribable. It really means nasty. In other words, our computational methods provide interpretive accountability. They resist contemporary debates that claim that trauma is unsayable. Second, a translator's habitus is less important. As I described earlier, it was Wien's veteran status that helped him land the role of translating the novel into its first English edition. And while the truism is, you had to be there to understand, we found that whether they had a military background or not, these translators arrived at essentially the same place. Third, literary analysis and close reading still matter. You see here the Wien translation, words, but they hold the horror of the war. Murdoch uses the more loving embrace, and Rout the more sterile encompass. These differences matter. So too, Wien would describe it as a panic, Murdoch, shell shock, and Rout, a panic attack. In closing, our results illuminate the extent, or lack thereof, of translator effect. We offer a distributional profile of the lexical semantic encoding of traumatic stance, distinguishing prevalence from intensity. We also model interpretive accountability. Computation emerges as a means of testing theoretically motivated claims with transparent, reproducible evidence. Thank you.
Thank you for your inspiring presentation. I think this was a wonderful example of interdisciplinary collaboration between linguistic studies and literary studies, showing how emotion and programming, interpretation and computation can meaningfully overlap in studying trauma and translation. Please give Professor Bach and Professor Alfson another round of applause. Now we will move on to our second presentation by Professor Byung-jun Kim from Cultural Informatics Program at the Academy of Korean Studies. His research focuses on data science-based approaches to the humanities and social sciences, combining computational method with cultural and literary analysis. Today, he will be presenting a paper titled Cultural Analytics of Korean Literary Studies, Academic Field Transformation and Social Dynamics Leading to the 2024 Nobel Prize. Please welcome Professor Kim with a round of applause.
이거 넘기는 건 어떻게? 아, 네. Hello, my name is Byung-jun Kim from the AKS. So actually, I originally planned to give my presentation in English, but after seeing the performance of the AI, the real-time AI system, interpretation system today, I thought it would be fine to present in Korea because my new baby was born 2 months ago. I don't have enough time to sleep today. And then we are planning to introduce a system like this in next year DH conference in Daejeon. So I also like to use this as a test. And okay, I will start my presentation. 한국어로 발표하겠습니다. 이거를 네, 왜 안 넘어가지? 네네. 이상 안 넘어가네요. 된다. 네. 네, 오늘 할 발표는 제 혼자 한 건 아니고요. 올해 DH 컨퍼런스에서 리스본에서 열렸던 DH 컨퍼런스에 한림대학교 여기 계시는 김용수 교수님과 같이 했던 연구를 같이 소개해 드리려고 합니다. 그래서 오늘 굉장히 영광인데요. 레브 마노비치 교수님이 오늘 오셔서 제가 이제 사인도 받고 Cultural Analytics라는 책에 사인도 받았습니다. 그래서 굉장히 큰 영광이고 오늘 그에 굉장히 큰 저는 이제 임프레션을 받았고 그래서 그거에 관련한 여러 개념들도 같이 생각하면서 발표하도록 하겠습니다. 작년에 한강 작가가 노벨상을 벌써 받았고 이거에 대해서 많은 이야기들이 있지만 왜 과연 한국문학이라는 것, 한국에서 문학 연구학이라는 것에 대해서 학술적으로 연구하면서 이거를 한강 작가가 왜 노벨상을 받았고 한국문학이 어떻게 국내, 한국 혹은 국외 학계에서 어떻게 보여지고 있는지 어떤 연구가 되고 있는지에 대한 연구로 오늘 제가 꼭지를 잡아봤는데요. 우리의 리서치 퀘스천은 이렇습니다. 세 가지의 area가 있고 첫 번째는 Korean Literary Study in South Korea. 그래서 한국 문학 작품의 한국 문학 연구가 한국에서 이루어지는 한국 문학. 그리고 Global Korean Literary Study 해서 한국 문학 연구가 한국 밖에서 이루어지고 있잖아요. 한국학, 해외 한국 문학 연구. 그래서 그런 것들도 같이 들어오고 그리고 그 중간자적인 역할로서의 English Literary Study in South Korea에 우리가 학술 데이터베이스 분석을 통해서 여기 안에 어떤 다이나믹스가 있는지를 분석하는 게 이 연구의 목적이기도 하고 이런 것들을 통해서 한국 문학 연구가 어떻게 펼쳐지고 있는지를 밝히는 것이 우리의 목적입니다. 얼마나 많은 KCI, do you know KCI, Korea Citation Index, in what is it, SSCI, ANHCI, this is the domestic index. 그래서 국내에 많은 연구자분들이 이제 논문으로 KCI 논문을 쓰고 있는데 얼마나 많은 연구들이 매년 쏟아질까요? 이른바 제가 지금 여기서 쏟아진다고 한 표현은 1년에 대략 한 18,000편 정도의 인문학 연구가 게재되고 나오고 있습니다. 사회과학의 경우 이거보다 한 거의 2배 가까이 됩니다. 지금 인문학은 18,000편, 사회과학은 이거보다 거의 2배 정도 되고요. 그래서 생각보다 여기 계신 인문학 하는 선생님들, 교수님들이 연구를 정말 많이 하고 계세요. 그래서 그게 한국과 비슷한 뭐 경제 규모를 가진 다른 나라들도 과연 이럴까? 한국은 굉장히 이게 이례적으로 큰 것입니다. 한국의 사이즈에 비해서 한국 그 뭐 대만이나 일본이나 여러 도메스틱 저널의 시스템에서 굉장히 많은 이만큼의 논문을 생산하는 곳은 좀 드문 편이기도 하고요. 그래서 데이터셋은 이렇습니다. Korea Literary Study in South Korea에서 저널 아리클을 가져왔어요. 그래서 왜 2008년부터 시작하느냐? The KCI 시스템이 established in 2007. 그래서 2007년부터 KCI 시스템이 본격적으로 도입이 됐고 2008년부터 데이터가 그나마 살아있기 때문입니다. 제대로 되어 있는 게. 그래서 거기에 있는 2008년 이후에 abstract, title, 뭐 keyword 이런 것들을 다 가져왔어요. 그래서 한국문학에서 52종 정도의 데이터를 가져왔고 약 17,000편 정도의 아리클을 데이터셋으로 삼았습니다. 그리고 두 번째 데이터셋은 글로벌 코리안 리터리 스터디인데요. 오픈 알렉스라고 하는 굉장히 큰 데이터베이스가 있는데 아카데믹 데이터베이스 중에 가장 크고 이게 오픈 액세스로 접근할 수 있어요. 그래서 한국 코리안 리터처, 코리안 컬처, 코리안 웨이브 같은 것들을 키워드나 이런 토픽 개념을 가져와서 이거에 관련한 논문들을 총 한 뭐 한국 문학 관련한 건 220건 그리고 한국 문학, 문화 그리고 뭐 코리아 한류, K 웨이브 관련 저널의 아티클을 1,500건 정도를 가져왔습니다. 그리고 English Literary Study in Korea. 그래서 여기 영어 영문학 하시는 선생님들 많으실 때 그 영어 영문학 그 저널에서 1955년부터 2024년까지 발간된 논문들을 가져왔고 아시다시피 그 KCI 시스템 등재 시스템 이전에는 논문이 그렇게 많지 않고요. 2002년부터 2024년에 2,580건 정도의 아티클을 가져왔습니다. 그리고 영어 영문학계의 이 영어 영문학 저널 말고 다른 영어 영문학계 저널을 또 31개 정도의 저널을 가져와서 데이터로 삼았습니다. 메소돌로지는 이렇습니다. 첫 번째 메소돌로지는 세멘틱 네트워크 애널리시스를 활용을 했고요. 그래서 거기 안에 있는 논문의 키워드를 co-occurrence를 가지고 와서 거기 제목에 있는 그 단어들을 가져와서 활용을 했고 두 번째는 스트럭처럴 토픽 모델 그래서 이제 구조적 토픽 모형이라고 하는 것을 가져왔는데요. 여기서 가장 중요한 변수는 그 저자의 메타 정보인데 되게 재미있는 것은 한국은 거버먼트가 그 학술적인 데이터베이스를 다 통제하고 있기 때문에 저자의 성별이나 세대나 이 사람이 어느 대학 나왔는지 이런 것들 저자 정보를 다 우리가 가져올 수 있어요. 그래서 이게 되게 특이한 점이죠. 미국이나 다른 곳에서는 사실은 이 논문의 저자의 성별이 뭔지 우리는 뭐 대충 맞출 수는 있지만 정확히 알 수는 없잖아요. 근데 한국에서는 그런 것들을 다 데이터를 가지고 있어서 그 데이터를 다 가져와서 분석에 활용했습니다. 그래서 첫 번째 코리안 리터러리 스터디에 관련한 네트워크 분석인데요. 한국문학 연구 안에서 뭐 컬처럴 피리어드 스터디라고 해서 한국문학에서의 이제 일제강점기 연구라고 하죠. 제페니즈 콜로니얼 피리어드 스터디가 있었고 그 다음에 오른쪽에 보면 그 페미니즘 관련한 우리가 오늘 발표할 내용에서 페미니즘이나 젠더 스터디가 굉장히 큰 요소로 나옵니다. 한국문학 연구나 혹은 영문학 연구에서 그게 굉장히 큰 연구로 그 토픽으로 우리가 볼 수 있겠는데요. 그래서 한국문학에서 이런 것들, 이런 뭐 근대 혹은 뭐 문학이란 단어는 당연히 나오겠죠. 해방 이런 식민지 이런 단어들이 중요한 키워드로 등장하고요. 그래서 이런 연구들, 그래서 그 이후에 그 콜로니얼 피리어드 이후의 연구들까지도 한국문학 연구에서 가지고 오고 포스트 콜로니얼리즘과 어떻게 연결할 수 있을지 이런 것들 뒤에 조금 더 분석이 나오게 됩니다. 그리고 아까 방금 말했던 페미니즘 스터디, 그래서 워먼이나 뭐 그런 젠더, 메모리, 에틱스 이런 단어들이 문학 연구에서 주류를 이루고 있고 이게 일종의 웨스턴 리터리 티어리, 그래서 서양의 그런 문학 이론에 큰 영향을 받았다고 우리는 볼 수도 있겠죠. 그래서 이 데이터를 가지고 이번에는 그 토픽 모델링을 한번 해봤는데요. 그 토픽 모델링에서 중요한 거는 이제 우리가 이 젠더라는 변수예요. 그래서 1저자 논문을 여러 명이 썼을 경우는 대표 저자 1명, 1저자 first author의 젠더를 우리가 확인을 했고 그걸 가지고 토픽 모델링을 돌려봤습니다. 그래서 퍼블리케이션 이어와 그 논문 게재 연도와 같이 포뮬라를 구성했습니다. 그래서 총 11개의 토픽이 나왔는데요. 이게 지금 토픽의 비중입니다. 숫자는. 그리고 옆에 나온 건 토픽의 그 연구자, 저랑 같은 연구자 팀이 같이 그 토픽의 이름을 붙인 겁니다. 그래서 뭐 네러톨로지나 파이틱스, 에식스 같은 것들이 주요한 토픽으로 나왔습니다. 뭐 여기 보면 콜로니얼 피리어드 스터디도 있었고, 그래서 이런 여기 페미니즘 스터디도 여성 중요한 연구로 나왔죠. 되게 재미있는 점은 그 방금 했던 그 식민지 관련한 콜로니얼 피리어드 스터디의 연구에 대해서 그 연구가 점점 감소하고 있어요. 계속 이제 식민지 연구를 많이 안 하고 있다는 거죠. 근데 식민지 연구는 더 재미있는 거는 이제 이 방금 젠더 변수를 넣었잖아요. 파란색은 남성이고 빨간색은 피메일 여성입니다. 보시면 남성이 좀 더 전통적인 연구를 많이 해요. 근데 이거는 사실은 문헌정보학이나 비블리오매트릭스에서도 좀 밝혀진 사실인데 남성 연구자들은 좀 더 전통적인 연구를 하고 여성 연구자들은 좀 더 새로운 연구를 하는 경향이 있다는 건 다른 뭐 사회과학이나 이런 곳에서도 밝혀진 사실이기도 합니다. 그래서 전통적인 연구는 남성 연구자들이 좀 더 많이 하고 있고, 예를 들면 젠더 스터디 같은 경우는 이때 2015년 이후로 급증하게 되는데요. 여러분들 여기 제 발표에서 2015년에 좀 집중해 주십시오. 왜 하필 2015년입니다. 2015이 왜 중요한지 2015년을 집중해 주시면 좋겠는데, 2015년 이후에 굉장히 연구가 활성화되기 시작하는데 이게 남성 연구자들은 사실 지지부진해요. 그렇게 이 주제에 대해서 큰 관심이 없다고 볼 수 있고, 여성 연구자들이 2015년 이후에 뭐 엄청난 큰 차이는 아니지만 그래도 상승하는 곡선을 우리가 볼 수 있어요. 이게 그 성별 변수로 인해서 연구 경향성이 달라지는 그런 패턴들을 우리가 확인할 수 있었고요. 이 이유가 무엇이었을까 많은 고민을 해봤는데, 제가 계속 2015년을 고민하라고 했잖아요. 제가 이전에 다른 연구에서 밝혀냈던 사실 중에 하나는 2015년을 기점으로 한국문학 연구에서 여성 연구자들이 남성 연구자들보다 더 많은 논문을 생산합니다. 생산하다는 표현이 좀 이상하긴 한데 논문을 낳고 막 이런 건데 좀 이상한 표현이기도 한데 논문을 더 많이 씁니다. 그래서 논문을 더 많이 쓰고 더 많은 연구자들이 여성 연구자들이 더 많아지게 되는 거죠. 숫자적으로. 그래서 2015년 이후에 남성 연구자들을 추월해서 더 많은 연구를 여성 연구자들이 하고 있는 겁니다. 그래서 그런 이유로 이 문학 연구장에서 젠더라는 변수가 굉장히 큰 요소로 떠오르게 되죠. 그래서 2015년은 여러분들이 알다시피 10년 전에 뭐 페미니즘 리부트라는 한국의 어떤 사회적인 현상도 연결되어 있다고 생각을 하고 있어요. 그래서 최근에 그 10주년을 가지고 많은 매체에서 페미니즘 리부트 이후의 10년을 일종의 학술적인 이벤트로서 주목을 하고 있기도 하고요. 그 두 번째는 글로벌 코리안 리터러리 스터디 혹은 컬처럴 스터디에서의 네트워크 어널리시스입니다. 이 데이터셋 같은 경우는 그 데이터셋 샘플 자체가 너무 작기 때문에 조금은 유의해서 볼 필요가 있는데요. 여기 보면 뭐 한국 문학 연구와 조금 경향이 다른 걸 볼 수 있어요. 예를 들면 뭐 차이니즈나 노스 코리아 이런 단어들이 조금 더 보이는데요. 조금 생각을 하면 디아스포라 관련한 단어들이 좀 보이기 시작했어요. 여기 안에서는 아무래도 해외의 한국 문학 연구는 뭐 K 디아스포라라던가 코리안 아메리칸 리터처라던가 이런 단어들이 있기 때문에 한국 문학이 해외에서는 이런 식으로 연구되고 있구나라고 우리가 좀 경향을 파악할 수 있었고요. 이것도 마찬가지로 좀 다르게 이번에는 이제 문학만 한 게 아니라 컬처 관련한 논문까지 넣었을 때 K-웨이브라고 하는 단어, 한류 이런 단어가 여기 옆에 보이죠? 한류. 그래서 이런 단어들이 보면 이제 한국 문화 연구가 일종의 K-컬처, K-한류 관련한 연구로 각광받고 있다는 걸 우리가 볼 수 있겠고, 그래서 K-팝 컬처 인더스트리 도미네이츠가 있음을 또 알 수 있었습니다. 그리고 그 다음은 이제 English Literary Study, 그래서 영어 영문학 저널, 한국에서의 영문학 연구였는데요. 지금 이렇게 보니까 좀 잘 안 보이시죠? 그래서 조금 그 설명을 좀 다시 드리면, 그 영어 영문학 제가 이제 영문학자가 아니기 때문에 김용수 교수님의 일종의 분석을 제가 같이 따라왔는데요. 되게 일종의 어떻게 보면 이게 한국이지만 외국 문학을 연구하는 되게 중간자적인 입장이 영어 영문학 연구자인 것 같아요. 물론 모르겠어요. 제가 영어 영문학 전공자는 아니지만 거기서 해외 이론에 대해서 굉장히 밝고 해외 이론을 빠르게 수입하기도 하고 그걸 가지고 한국 안에서의 해외 문학에 대한 연구 이런 것들을 계속 꾸준히 해오는 집단이 영어 영문학 집단이겠죠. 그래서 뭐 한국어와 영어, 로컬과 글로벌 그래서 이런 식으로 계속 어떤 중간자적 위치에 있는 것이 아닌가라는 생각을 해봤고요. 그 1994년이라는 게 일종의 그 변곡점으로 되어 있는데 1994년이 왜 변곡점이었냐면 아카데미 랭귀지의 문제였어요. 그래서 기본적으로 이제 한국어 그리고 영어를 이제 어떻게 보면 논문을 쓸 때 그 언어로 택하게 되는데 이때 이후에 이제 한국어 또는 영어 이런 식으로 해서 영어로도 영어 영문학 저널에 영어로도 논문을 싣고 실제로 영어 영문학 관련한 저널에 보면 KCI 한국 문학 쪽에 등재된 것만 있는 것이 아니라 해외에 있는 유수한 그런 뭐라고 할까요? 뭐 ANHCI, SSCI 인덱스에도 등재가 돼 있죠. 그래서 그런 것들도 같이 고려하는 그 언어 선택의 문제도 있었습니다. 그래서 영어 영문학계가 일종의 사우스 코리아 한국 내에서 영문학을 공부한다는 것이 어떤 자의식을 가지고 있는지 그런 것에 대해서 계속 영어 영문학자들이 고민을 해왔던 것 같아요. 그래서 94년 이전에는 이런 단어들이 같이 등장을 하게 됩니다. 그래서 뭐 한국어로 된 단어, 영어로 된 단어, 뭐 셰익스피어 같은 단어도 있고 옆에 이제 문학이나 소설, 엘리엇 이런 단어들도 같이 보이는 걸 볼 수 있는데요. 94년 이후에는 그 양상이 많이 달라지게 돼요. 앞에서는 어떻게 돼 있냐면 이 네트워크가 일종의 하나의 뭉쳐진 네트워크로 기능했다면 뒤에 가게 되면 이제 이게 이분화 스플릿하게 됩니다. 그래서 그 분리가 되면서 영어로 쓰는 단어들과 한국어로 쓰는 단어들이 이제 네트워크가 이제 이원화되게 되는 현상도 나타내게 됩니다. 그래서 이런 two complete different generation of scholarship이라는 문제, 그래서 87년 세대 뭐 이런 문제도 있겠고, 그래서 세대의 문제가 그 학자들한테 어떤 언어를 쓰는 것이나 학문을 함에 있어서 어떤 큰 요소로서 작용을 하고 이게 패러다임 시프트로 영문학계에서도 적용을 한다는 거죠. 우리가 뒤에 이제 제가 성별이라는 큰 요소를 토픽 모델링의 결과로 넣었지만 이제 추후에는 연구자의 세대, 제너레이션 문제도 이야기를 해보려고 해요. 네, 그래서 여기서도 굉장히 중요한 여성 혹은 woman이라는 단어가 큰 카테고리로 묶이게 돼요. 그래서 한국어에서의 그 단어의 여성이라는 단어가 키 허브로서 페미니즘이나 포스트 콜로니얼리즘 연구에서 큰 포션을 차지하게 됩니다. 그래서 영문학계에서의 이런 연구 경향도 확인해 볼 수 있겠죠. 지금 몇 분 정도 남았나요? 네. 10분 남았습니다. 네. 조금 빠르게 가보겠습니다. 네. 그래서 다르지만 비슷한 뭐 이런 식의 월드 리터처 혹은 포스트 콜로니얼리즘 관련한 단어들이 나왔습니다. 그래서 뭐 엠파이어나 인종의 문제라든가 포스트 콜로니얼, 에이시안 이런 단어들이 있었고 페미니즘 관련한 단어도 당연히 아이덴티티, 뭐 섹슈얼, 워먼 이런 단어들도 같이 등장을 하게 됩니다. 그래서 그 한국의 영문학 연구에 어떤 역할을 하고 있는가, 한국의 영문학 연구가 어떤 역할을 하고 있는가. 그래서 잠정적인 저희의 그 가설이자 결론은 이게 일종의 메디에이터 역할, 중재자로서의 영문학자들의 그런 역할을 우리가 하고 있지는 않는가. 그래서 전 세계적인 세계문학 연구자와 한국문학 연구자를 잇는 연구 경향이 일종의 영문학 연구자들의 그런 그래 안 나왔어요. 죄송합니다. 네네네. 네 계속 하겠습니다. 네. 갑자기 땀이 나네요. 네. Okay. Last part in English literature study. in 31 academic journal for network analysis. So you can see the KCL English Literature Journals of the semantic network. There's two part where 네, 다시 돌아왔나요? 네, 감사합니다. 내년 DH 컨퍼런스에서는 이런 일이 없도록 준비를 잘 하도록 하겠습니다. 네. 깜짝이야. 네. 네, 그래서 왼쪽에 한국어로 쓴 단어와 오른쪽에 영어로 쓴 단어가 이분화되어 있는 영향을 볼 수 있고요. 네, 그래서 여러 워먼 아메리카 그래서 계속 비슷한 얘기입니다. 포스트 콜로니얼 스터디와 페미니즘 연구가 계속 연결돼 있고 그것이 굉장히 주류의 연구로서 기능을 하고 있다라는 이야기였고요. 네, 뒤에 조금 이제 토픽 모델링 결과를 보여드릴게요. 그래서 31개의 영문학 저널 안에서 토픽 모델링한 결과인데요. 포스트 콜로니얼 스터디 그리고 파이틱스, 링기스틱 여기 안에는 영어학, 언어학 연구도 포함되어 있기 때문에 토픽도 그렇게 묶여 나옵니다. 그래서 페미니즘과 포스트 콜로니얼리즘의 토픽 10번 같은 경우도 있고요. 페미니즘 연구나 포스트 콜로니얼리즘 연구는 계속 이 영문학 같은 경우는 제가 젠더 변수를 확인을 못해서 성별 변수를 분석하지 못했고 추후에 할 예정입니다. 그래서 이런 부침이 있었고 트라우마, 토니 모리슨, 전쟁, 이런 레이시즘 이런 단어들은 2005년부터 확 증가를 하기 시작합니다. 그래서 지금도 굉장히 주류의 연구 중에 하나가 되고요. 그리고 그에 비해서 감소하는 토픽들은 전통적인 연구가 감소를 하게 되고요. 아마 국문학계에서도 굉장히 그런 전통적인 연구들이 계속 감소하고 있는 것과 비슷한 상황이겠죠. 네. 그래서 제가 좀 정리를 하겠습니다. 세 개의 필드, 세 개의 트래젝터리를 가지고 있고 우리가 한국문학, 한국에서의 한국문학, 그리고 글로벌 코리안 스터디로서의 한국문학 연구, 그리고 잉글리시 리터처 스터디 인 코리아라고 해서 세 개의 집단의 다이나믹스를 보려고 노력을 하고 있고요. 이게 완성된 연구는 아니기 때문에 이 집단 사이에 어떤 인용관계라든가 혹은 내용의 교류라든가 이런 것들을 좀 추후의 연구로 밝혀내고자 합니다. 네, 컨클루전입니다. 그래서 짧게 좀 하면서 마무리하도록 하겠습니다. 그래서 한국문학에서의 한국에서 한국문학은 어떤 전통적인 식민지 연구와 그리고 페미니즘과 컬처럴 스터디로 2015년 이후에 굉장히 급부상했다라고 볼 수 있겠고 그 전에 이제 남성들이 주로 전통적인 연구를 많이 해오고 있다. 그리고 글로벌한 한국 문학 연구는 K-팝이나 K-컬처에 관련한 연구들이 디아스포라 이런 것들이 같이 있었다. 그리고 English Literary Study in South Korea. 그래서 이 한국에서의 영문학 연구하는 것들이 메디에이터로서 중재자로서 혹은 가교로서 영문학 연구들이 이루어지고 있었음을 우리가 밝혀냈습니다. 그래서 앞으로 이제 여기 제 지도 학생들과 김용수 교수님이랑 같이 할 연구들은 추가적인 데이터를 가지고 오고 또 거기 안에 참고 문헌 리스트를 가져와서 서로가 서로를 어떻게 인용하는지 같은 것들을 보려고 합니다. 앞으로 잘 이 국제학술지에도 내보려고 하고요. 열심히 한번 연구를 이어보고자 합니다. 네. 네, 들어주셔서 감사합니다. 여기까지 하겠습니다.
Thank you for your insightful presentation, Professor Kim. We often say that literature reflects society, but listening to your talk, I was reminded that the themes and methodologies of research also reflect the society we live in. Please give Professor Kim another round of applause. Our final speaker is Professor Lev Manovich from the Graduate Center of the City University of New York. Professor Manovich is a distinguished scholar of digital culture, new media, and he founded the Culture Analytics Lab, pioneering the use of data science and visualization in culture and media studies research. Today, he will be presenting a talk titled Culture Analytics and Artificial Intelligence. Please welcome Professor Manovich with a round of applause.
Perfect. Okay. Good afternoon. I'm very, very grateful for organizers of this conference for inviting me because it gives me the opportunity to tell you something which probably will be surprising to most of you. So I am indeed professor in the university in New York City, but since the COVID started, we kind of moved all the classes on Zoom. And it so happens that since 2020, so for the last 5.5 years, I'm actually based in Korea. Okay, so I'm local, and lots of my colleagues around the world have know it, but I keep meeting people in Korea who have no idea, because maybe we can't imagine that somebody like me would be living in Korea. But why not? I can give a whole lecture why I love Korea so much, but not today. So I'm looking forward to more interactions with local researchers, participation in new events, meeting new students, and so on and so forth. So what I'll try to do today in my half an hour is to first kind of briefly summarize my earlier work, which some of you know, but not everybody, on cultural analytics, and then can make a bridge to generative artificial intelligence, which is the subject of my most recent book. And as you'll see, I will claim that both kind of cultural analytics and actually digital humanities as well, on the one hand, and generative AI kind of share certain common limitation, which comes from the use of big data, statistics, and data science. So another reason why I'm kind of happy to give this talk today is actually I got this idea for cultural analytics exactly 20 years ago. It was November of 2005. It was kind of a few years before social media became really popular around the world, but the internet, of course, already existed, and all the museums, universities, design studios, and so on had already websites. So I got this idea that what we can do is we can create software, right, which will visit hundreds of thousands or millions of these websites, grab announcements of conferences, grab announcements of exhibitions, descriptions of projects, right, and then use data analysis to analyze cultural trends and see how these cultural trends emerge, spread, and so on and so forth. And I think actually when I come up with this idea, I anticipated by about 3 to 4 years the emergence of exactly this kind of analysis in the industry, right? So today, let's say Meta, right, does this analysis with Instagram. So the machines analyze, all the posts of 3 billion users, and they kind of recommend, right, what posts you should look at, what other people you should follow, and so on, right? Around 2009, 2010, you have emergence of new type of software called social media monitoring, right? And today used very widely. So any company, like $30, $40 a month. So companies, right, subscribe to the software, and you can put, the concept of the name of a company, the name of a brand, and it will show you all the conversations, right, related to the topic around the world. So the industry kind of actually is doing cultural analytics at large scale, but of course we're interested in particular questions, right, related to kind of making money, brands, marketing, advertising. So we're not really doing, right, like kind of, let's say, more humanistic cultural analytics, which is what I imagined. So this is a homepage of our lab. And as you can see, like in trying to describe it, I could have talked about all the museums which digitize their artifacts, right, their collections, but I wanted to focus on something else, which to me actually differentiates cultural analytics, right, from digital humanities. Right? So digital humanities, especially 20 years ago, was completely focused on text analysis, right, and lots of usually literary text. I think today is a bit broader, but as you can see from a program of this conference, this kind of focus on text still remains. Because I came from art, right, from painting, from design, from new media, I was interested more in images, but also I was interested to create methods which will allow us to analyze contemporary kind of trends across contemporary culture, right? Both a culture created by professionals, but also kind of user-generated culture what today we call content economy, where hundreds of millions of users, right, creating content for social media. So today, people around the world create, share, and interact with billions of new digital artifacts every day. We need new methods for seeing culture at its new scale and velocity. Okay. Sorry. Try to. Okay. Which button do I press? Okay, not this button. Sorry, which button?
Red.
Which one? Well, I pressed this button and nothing happens. Okay, so yeah, nothing. You sure it's red? Maybe green? No. Okay. Okay. No. Okay. Okay, I'll try. Green one, yeah, that's what I thought. Yeah, perfect. So now a thing I should mention is this idea of cultural analytics came to me because in 2005 I was at the opening of a new large research institute on the campus of my university, University of California, San Diego, where some researchers were creating this kind of huge visualization walls, right? So you see here like image taken a few years later, me and people from my lab, and we're not looking at a big painting, we're not looking at a big poster, we're actually looking at a wall made from 70, 30-inch screens, and behind it are PCs. So basically, essentially, it's a visual supercomputer, and we developed software which would allow us to put thousands of images and then manipulate them in different times, in real time. So basically, we created a kind of tool for analyzing trends and patterns in image collections, right? In real time, and again, this is kind of very different from our kind of text-based analysis. So as you can see, 20 years ago, right, when I thought about this idea, my vision was incredibly ambitious and perhaps very, very utopian. So we started by kind of doing mock-ups, right, of potential interfaces of how the system would look like. Right, so these are interfaces. You have network view on top. You have a long tail of culture in the middle. You have, let's say, connections between different kind of themes, right, in contemporary global culture. And then we started by kind of putting these mock-ups on this wall, right, where we're not interactive. There was nothing behind. We were taking pictures as a way to kind of present our vision. And then we started to apply for grants and try to collaborate with scientists at our university to actually build such a system. So I will show very briefly just a few examples of the work we actually did. Again, it's familiar to some of you. So this is visualization of all the covers of Time magazine. So about over 5,000 covers published between 1923 and 2009 when we did download. And the idea, right, was to create visualizations which don't reduce the data to kind of points and lines, right? Essentially kind of throwing away most information, but to actually create visualizations from small thumbnails of the actual images in the data set, because this way, right, we can kind of zoom in and see what the content is and see more trends, right? And then we can zoom out and see more patterns. Like I'm not going to describe all the 14 patterns I found here because it'll be in our lecture, but here you can see some kind of patterns, changes in color. You can also see how things get more saturated. If you look more closely, you will see changes in kind of design strategies, and so on and so forth. Right? And then this is the kind of view of the same data set, right? So what's important is that actually here, okay. No, it's okay. Yeah, so here we're not measuring anything. We're not using computer vision. We're simply kind of visualizing these images in a particular layout. And then, of course, because I had background in computer vision, I realized that we can also apply various measurements to images and videos and use these measurements to plot the data, right? So here on the x-axis, you have time, 23 to 2009. And on the y-axis, the position of each cover is determined by its average saturation, which is the color intensity, right? And again, sorry. And what you see here is this particular visualization reveals kind of interesting patterns in changing variability, right? So the most desaturated covers, kind of black and white at the bottom, the most saturated one on top, and you can see how like this spike, like there's this larger range, which is around 1960s, even 1970s, right? It goes smaller, and then it goes bigger again. So again, here you can actually see kind of statistical patterns, but you don't have to know actually any statistics because they're revealed by visualizations. Okay? And then we're slowly kind of moving towards bigger and bigger data. So one of the projects we did is we worked on manga. So we downloaded all the most popular manga, which are translated in our languages, 883 titles, 1 million pages. And here's visualization of this 1 million pages, where you have two visual properties, one on the X, one on the Y. And this is more traditional visualization, where you visualize each page as a point, and you do see a particular distribution, right? There is kind of more manga in the center, but you have no idea what this manga is, right? So this is the same visualization where we actually replace points by these manga covers, and you actually see 1 million manga, but of course from this distance you don't know what we are. This is like a close-up, and you can zoom in and out and so on. The whole visualization is 40,000 by 40,000 pixels, and to me, like what was interesting about it is I expected to see various clusters, right? I expected to see various kind of stylistic areas, and actually we are in manga, but at least according to the two dimensions which we use here to sort these images, there is a complete continuity, right? So I realized that using big data can potentially kind of help us to question our assumptions, right, about the culture. If we look at the culture on large scale, such as that there are different styles, there are different aesthetics, sometimes we are, and sometimes actually culture realizes every single possibility. And then eventually we kind of move towards social media. This was like the very first visualization of Instagram we did in 2012. So this is, I think, 50,000 images shared over a few days in Bangkok, visualized using different layout. I think you have brightness on the, which is distance to the radius, and you have saturation, which goes around the color. We also did visualization related to content, but at this, because you're sitting kind of far, right, and at this scale, I'm decided to show just a few examples of visualizations which focus more on visual features, because then you can very clearly see kind of different patterns. And this is a comparison, right, of people sharing photos on Instagram in 2013, 50,000 photos in New York on the top and 50,000 photos in Tokyo at the bottom, right, over a few days. And you can see how it gets dark at night, but doesn't get completely dark, and it gets lighter during the day. You also see that people sharing more photos in New York, right, because there are few with waves, so each day is longer. And if you zoom in, you start seeing like very interesting sort of patterns related to the content. So you have lots of kind of brownish, kind of yellowish food in Tokyo and other things in New York and so on and so forth. So eventually, I stopped doing the projects and I kind of published this book in 2020, Cultural Analytics. And I just want to kind of highlight a couple of ideas. Okay, so this we talked about. Okay, this is fine. Well, so I basically had in the book 12 research challenges, and I think we are very, very ambitious, and it's kind of utopian. And I mean, I don't think that 5 years later today or 5 years from now will be realized. So they're kind of impossible challenges. At least I don't think that anybody was able to actually do it. But maybe some people do. So how can work with big cultural data help us to question our stereotypes, assumptions, concepts, and existing knowledge about culture, right? So that's all fine. In our challenge is number 5, right? So most of digital humanities, I think maybe all digital humanities, is using it as data, like already kind of published, kind of static, right? Cultural artifacts like newspaper articles, novels, and so on. But of course, today we live in the era of interactive digital culture, right? People play video games, they interact with AI, we interact, we sort of chat on messengers. And I don't think there was like much work, or maybe any work, in DH or cultural analytics, which actually deals with how to analyze this interactive culture, which actually characterizes our time. And then number 6, is also, I think, very ambitious and very, very difficult. What theoretical concepts and models do we need to deal with mega scale and velocity with user-generated content and user interactions online? Right? Our 20th century theoretical concepts in humanities are enough, or do we actually need to create new concepts? And what I realized after many years is actually when we start doing DH or cultural analytics, in a certain sense, this quantitative approach actually prevents us, makes it more difficult to come up with new theoretical ideas, right? Because we kind of take for granted existing units of analysis, text, offer, sentence, and word, right? So in a way, using digital methods kind of solidifies our existing thinking, right? And then these last ones, right? Can we describe cultures both objectively and as we perceive them as statistical distributions and combinations of elements, themes, and strategies, right? Kind of atomistic approach, right? Or is culture about gestalts, not reducible to their parts, right? If the answer to the second question is yes, this will make cultural analytics impossible, right? Because when we do this quantitative analysis, we basically extract features. They can be words, they can be topics, they can be some compositional patterns, some aesthetic patterns, right? And then we kind of assume that, the cultural wholes, right, the cultural artifacts are kind of made from combination of these features. So by looking at these features, we get some insight into the culture, but maybe that's not how human perception and cognition works, right? Maybe culture is about gestalts. So maybe if you're analyzing a film, it's not about average shot length, it's not about cinematography. It's everything kind of working together in a way where you can't really take it into parts. And then finally, number 12 is maybe the biggest challenge and kind of my favorite idea. So what I realized is that both data, statistics and data science operate by reduction and aggregation, right? You reduce data to distributions. When you do cluster analysis, you reduce data to clusters, right? And in fact, one of the definition of statistics is the science of aggregation and summarization of data. And of course, every summary, right, condenses some information, throws away other information, right? So the biggest kind of issue in DH and cultural analytics, and as we'll see in AI also, is that you kind of throw away lots of information, and perhaps you throw away kind of unique points because you're trying to aggregate and summarize your data in the best possible way to see the pattern. But the pattern by default is something which is repeated, which means that if you kind of look at reality, look at culture from a statistical point of view, it actually makes it very difficult or impossible for you to see actually unique things, right? So is reduction a wrong approach? If contemporary authors, right, if both modernism and contemporary period want to create unique artifacts and experiences that can be duplicated, right? Everybody wants to create something unique today in a very modernist fashion. Will we inevitably miss true uniqueness in our quest to track larger trends? So when in 22, right, like many others, I was super excited about big progress in generative artificial intelligence, and I started using AI image tools, kind of creating artworks, and also publishing my insights online. And together with my colleague from Europe, we kind of published this book online. We completed it in September of last year. I'm happy to tell you that now it's being translated into the Spanish translation just came out last week. I also have a contract for Korean translation, Chinese, Italian, and Japanese. The whole book is online, so I don't have to tell you about it. You can kind of download or use AI to summarize it. But I just want to use my last 7 minutes to tell you what I was going to tell you, what I promised, which is what is the connection between cultural analytics and AI? Well, the first connection is that both can be seen as effects of a web. Right? So in 1993, the web starts exploding. We create kind of duplicate, right? Like a digital double of our society. We create digital culture, right? By trillions of web pages, trillions of images. And this proliferation of digital culture has multiple effects. So just to name 3, the first effect is the switch from directories and hierarchical knowledge systems to search in the N90s, right? Because there is so many objects out there. Right? You can't analyze, there is no time to analyze them hierarchically in categories, so we just use the search. Another effect was emergence of data science as a new field around 2009, have realization that there's lots of big data in our society, in companies, in scientific experiments, but of course, the prime example of big data was the social media, right? The industry, the economics, the society realized that we can combine the trends, right? So data science becomes the new discipline, and data science at the time was described as dealing with data at such a scale that traditional statistical methods are not enough. And then my own little paradigm of cultural analytics was kind of part of the same wave, right? Realizing that there is so much culture now in digital form that we can start systematically analyzing kind of cultural patterns across these data sets. And then yet another effect of the web is emergence of generative AI, right? Because what generative AI is doing, right, is these models are being trained on trillions of web pages, they're being trained on billions of images, and then we kind of learn, right, also the patterns. So in a way, we're doing kind of cultural analytics, but of course, these patterns, right, are impossible to actually reveal because they're hidden in a way it's our model, and the networks are trained not to give you these patterns, which is what I would like, right, as a kind of humanities person, but we're trained to generate new artifacts with the same statistical properties as in the data, right? So that's one connection. Both cultural analytics and artificial intelligence and a number of other developments are part of the same kind of movement, which are effects of the web. And generative AI is not the last effect, right? We'll see more effects, we'll see new disciplines, we'll see new type of knowledge, new type of instruments emerging, I think, in years to come out of this unprecedented accumulation of cultural and social data on the web, right? So that's, I didn't want to go. So that's one thing, right? And then there's like another sort of connection, which is about limitation, right? So as I claimed, when we analyze large cultural data quantitatively, we use statistical tools, and statistical tools are designed to do reduction, and we can miss kind of unique works, and we can also miss like small kind of subcultures, right? Small islands of cultural content. And actually something similar happens with AI, right? Because AI trained on these huge cultural data sets, whatever patterns dominating these culture sets, right, is being learned by the model. So while AI models are very good in generating like kind of text or ideas or images or videos using familiar genres, right, using kind of type of content strategies or aesthetics, which are very common, when you try to generate something very unique, right, they kind of break down, right, because we're not trained for this uniqueness. So this actually comes from a book, right? So what happens when you actually try to generate something non-existent, rare, or unfamiliar to them? Something which hasn't been done before, right? Something which doesn't exist on the web. Well, they can do it, but not perfectly. So the quality of generated results becomes lower, aesthetics are inferior, mistakes appear, and generated scene is not coherent. Or the tools substitute the content and aesthetics you want with more commonplace alternatives. So you describe something you want, something very subtle, something very unique, and when you get something, both when you use like AI to generate text and when you use them to generate images or video, something which is more or less fits what you wanted, except it's in a more commonplace aesthetics, it's more commonplace ideas, right? So, because again, this is what it knows. You get a coherent scene, figures and faces with correct anatomy, right? Interesting composition, but the image is composed of more generic cliché elements. The aesthetic parameters are shifted towards more common values. And I'll finish in 2 minutes. So over the last 3 years, I created tens of thousands of images. I had exhibitions. I had 2 personal exhibitions. With this work, one was in Seoul. And I've been kind of struggling and using my 50 years of experience in visual art to try to figure out how I can tweak with AI tools such as Midjourney, right? Now we have Nano Banana and so on, to make this very unique kind of subtle things, right? Which is not what I'm designed for. And more or less, I think often I was able to do it, but I had to pay the price, right? So for example, like I wanted to generate this image, right? Of this kind of socialist kind of, right, kind of modernist building. And then there's a cloud, right, which is on top of this building, and the cloud is connected to a building by kind of ropes. And after tons and tons of trying, right, this is the best I was able to do. Right? You have a strange wires, and they're not even connecting correctly, because this is just not something which I think was ever like, maybe there are a few images like this, but probably none. right? So you try to make something which is completely non-existent, and at the same time not in cliché aesthetics, and you get mistakes, right? And then this is from another image series called Drawing Rooms. So here, like, I mean, I can't describe the whole process of how I do it. It's not just writing prompts. It would be like another lecture. But basically, I really like, right, like this kind of background, how you have these objects, right, which are not completely merged, kind of broken, right, with kind of endless still life. And then, but the price I had to pay is that the figures, right, also have anatomical mistakes, which is maybe okay. But as you look at the faces, right, the faces are very generic, kind of beautiful, right, kind of faces. So the faces kind of come, right, more from popular culture, while only some things are unique. And then, this is another image which I really like. So I think here I was able to get something where like I'm satisfied with everything. Again, the price I had to pay is that if you look at this structure, they're kind of broken, right? You see how the top pole doesn't connect properly, but I don't mind, right, this brokenness, because I kind of use this surrealist, modernist aesthetics, where the world I want to create is not perfect. So I basically had to accept that this is the price I have to pay and do that. So again, to finish, I'm actually on time, which is amazing, although I probably was speaking like way too fast. So both cultural analytics, NDH, and artificial intelligence can be seen as effects of the same kind of process. Our society trying to explore how we can use big data, specifically data on the web, and at the same time, right, we both have its limitations, but basically behind them is statistics and data mining, machine learning, and both statistics from 18th century onward and machine learning of 20th, 21st century are very good tools for aggregating data, for extracting general patterns, but they're not really very good tools to deal with like small islands of content, small islands of uniqueness, or like unique cultural points. And I think to me, this kind of really limits potential usefulness of this approach to culture. Thank you so much.
Thank you very much, Professor Malovich, for your inspiring lecture. Many of our undergraduate and graduate students who are deeply interested in digital humanities are here today. And I'm sure your lecture has given them a new inspiration and motivation to explore this emerging field further. Once again, please give Professor Lev Manovich a big round of applause. We will now begin our discussion session. We are pleased to have two discussants today, Professor Soo Her from Seoul National University and Professor Won-hee Jo from Yonsei University. Yeah, please have a seat. All the presenters coming outside. I think we don't have enough time, so each discussant will first share their comments on the presentations, and then the speakers may respond in order of their presentation. If time allows, we will also take a few questions from the audience afterward. Before we start, I'd like to let our presenters and discussant know that the laptop in front of you provides real-time subtitles in both Korean and English. You can follow the translation there throughout the discussion. So I'd like to invite our first discussant, Professor Soo Her, to begin. Professor Jo will follow. Professor Her, the floor is yours.
네, 방금 소개받은 그 허수입니다. 저는 서울대학교 국사과에서 한국 근대사를 공부하고 가르치고 있습니다. 저는 이제 디지털 인문학 중에서도 텍스트 마이닝, 토픽 모델링을 통해서 한국 근대사 자료를 분석하는 일을 하고 있는데요. 그래서 오늘 네 분이죠. 그 발표에 대해서 아주 전문적인 토론을 하기는 어렵지만 좀 일반적인 차원에서 토론자로서의 의무를 다하고자 합니다. 많은 것을 배웠고요. 순서대로 말씀을 드리겠습니다. 첫 번째 박종훈 사라 아일프슨 교수님의 발표에 대한 말씀을 드리겠습니다. 이 발표는 두 가지 면에서 좀 저는 인상 깊게 들었는데요. 이 기존의 번역본이 통계적으로 유의한 차이가 보이는가라는 소극적인 접근을 넘어서 번역본이 실질적으로 동등한가 하는 적극적인 연구 질문을 설정한 점이 주목됩니다. 두 번째는 이 LIWC, BERT 등 세 가지 상이한 분석 도구를 활용해서 명시적인 이 의휘, 주제적 의미 영역 등 다층적 차원에서 분석을 수행한 점이 견고한 어떤 그런 연구라는 생각이 들었습니다. 연구 결과 해석에 관한 질문을 두 가지 드리겠는데요. 첫 번째는 분석 기준의 사후 조정에 대한 부분입니다. 선생님들께서 플러스 마이너스 0.10이라는 엄격한 동등성 기준을 사전에 설정하셨는데요. 그런데 이 LIWC BERT 분석에서 라우트 번역본이 이 기준을 충족하지 못할 때 민감도 분석이라는 이름 하에서 기준을 플러스 마이너스 0.15로 완화해서 모든 번역본이 동등하다는 결론을 도출하셨습니다. 사전 설정된 여기에 관한 질문인데요. 사전 설정된 엄격한 기준을 충족하지 못한 결과를 오히려 번역가 정체성에 유의미한 영향을 보여주는 중요한 발견으로 해석할 가능성은 없는지 궁금합니다. 기존 완화를 통한 결론 도출보다는 이러한 예외가 번역 연구에서 가장 문학적으로 의미 있는 핵심 발견일 수 있다는 생각도 들었습니다. 이에 관한 선생님의 그 의견을 듣고 싶고요. 두 번째는 분석 범위의 제한성입니다. 본 연구는 소설의 서술 부분을 제외하고 대화와 내면 사고만을 분석 대상으로 하셨는데요. 제가 잘은 모르겠습니다만은 그 트라우마와 같은 복합적 정서는 종종 서술자의 의도, 분위기 설정, 의도적 침묵 등을 통해 더욱 강력하게 전달되는 경우가 있지 않을까 생각을 해서 이 질문은요. 번역가의 해석적 개입이 가장 현저하게 나타날 수 있는 서술 부분을 배제함으로써 결과적으로 번역본 간의 안정성을 과대평가할 이유는 없는지 여쭙고 싶습니다. 두 번째는 김병준 선생님 발표에 대한 논평입니다. 선생님의 발표는 이 한국문학 연구의 통합적인 지형도를 제시한 점이 좀 인상적입니다. 국내 한국문학, 글로벌 한국문학, 국내 영문학 연구 이 영역을 통합적으로 분석을 해서 한국문학의 국내외 수용과 발전 과정을 입체적으로 조명하신 거요. 그래서 노벨 문학상 수상이 개인이 아니라 학술장의 복합적 발전 과정으로 보신 것이 설득력이 있고요. 두 번째는 디지털 인문학 반분을 효과적으로 활용해서 시멘틱 네트워크 분석과 스트럭처럴 토픽 모델링을 통해서 정량적인 변화를 살펴보신 부분이 인상적인데요. 추가 논의가 필요한 지점이라고 생각되는 두 가지만 말씀드리면 첫 번째, 발표에서 다루신 국내 한국문학, 글로벌 한국문학, 국내 영문학이라는 세 영역을 선정한 구체적인 이론적 방법론적 근거가 무엇인지 궁금합니다. 물론 이제 노벨 문학상 수상의 배경이랄까 요인들을 보신다는 것은 이해하는데 조금 더 구체적인 연결고리가 있으면 좋겠고요. 두 번째는 사회적 역동성 개념에 관한 건데요. 이 소셜 다이나믹스라는 것이 본 연구 맥락에서 어떻게 정의하고 계신지 이것도 좀 궁금합니다. 그다음에 세 번째, 레프 마노비치 선생님 발표에 대한 질문인데요. 세 가지입니다. 첫 번째, 교수님의 초기 연구에서 탁월하게 구분하신 내러티브 논리와 데이터베이스 논리 사이의 근본적인 차이를 고려할 때 문화 분석이라는 실천은 문화 연구의 데이터베이스 논리를 적용한 것으로 이해가 됩니다. 교수님께서 제시하신 12가지 연구 과제에서 언급된 지속적인 긴장, 즉 대규모 데이터베이스적인 패턴 발견과 개별 문화 작품의 고유한 내러티브적 통합성 보존 사이의 긴장을 현재는 어떻게 해결해 나가고 계신지 궁금합니다. 두 번째는 선생님께서 그 발표문 뒷부분에 네 번째 큰 아이디어에서 제안하신 범주 없이 문화를 관찰한다는 급진적 가능성은 이미지 플롯 등의 도구에서 훌륭히 구현되고 있다고 봅니다. 그런데 잠재 공간에 고차원적 범주 체계를 구축하여 작동하는 생성형 AI 시대에 이러한 범주 없는 분석이라는 이상이 여전히 유효한지, 아니면 이제 AI가 문화에 부과하는 새롭고 불투명한 범주들에 대한 비판적 분석에 더 집중해야 하는지에 대한 교수님의 견해를 듣고 싶습니다. 마지막 세 번째입니다. 교수님께서 12번째 연구 과제인 맨 마지막에 환원의 문제, 그 리덕션이라고 하셨죠. 이것과 독창성 상실을 고려할 때 모든 시각 문화를 재조립을 위한 통계 모델로 환원하는 생성형 AI가 이러한 과정의 정점에 있는 것처럼 보입니다. 이론가이자 예술가로서 이러한 도구들과 작업하고 계신 선생님, 교수님께서 보시기에 AI가 필연적으로 양식적 평균으로의 회귀를 야기할 것인지, 아니면 진정한 새로움을 창출하고 문화적 다양성을 확장하는 도구가 될 가능성이 있는지에 대한 견해를 공유해 주시면 감사하겠습니다. 이거는 이 세 분에 대한 제 논평은 그냥 코멘트라기보다는 제가 잘 모르는 분야에 대한 질문이라고 봐주시고 좋은 말씀을 좀 부탁드리겠습니다. 감사합니다.
Okay, hard to follow up with this. Thank you very much for giving me this opportunity to discuss these three fascinating presentations. And I do have to admit, I am a historian of early modern East Asia, China, and I actually abandoned English language and literature as my undergraduate major. So in other words, it's a little bit ironic that my past has come to haunt me, like, Wani, do the kind of literature and stuff. So I guess that's how life goes on. I have a kind of overall comment about the panel, which I think, and I'm curious whether this was intended or not, but I think the fascinating thing about this panel was that it started with something very small, 3 translations. Then we went on to a kind of broad picture of Korean literature studies, and then we ended with a much more broader concept of culture and things like that. So I don't know whether it was designed by coincidence, but the 3 methodologies kind of expanding the scope shows both the kind of breadth and versatility of what we can do with these digital humanities methods. But at the same time, I also think there's a sense of continuity. So like the traditional methods of the humanity insight, or the same questions that we go on and on are also increasingly repeated in all of the 3 papers. So with that, I do want to thank all the presenters and the organizers. Again, I think I am similar with Professor Hall in the sense that I'm asking most of these questions out of curiosity. To keep things short, yes, I'll do it very shortly. So for the first presentation, the thing that I wanted to ask is about, basically, I think it's fascinating that you bring into the account of the status, being veteran or not, or female or the gender, the female not being a kind of starting point for research. And if somebody forced me to do that, I don't think that's going to happen. But if that happened to me, I would think that would be a very logical place to start that research. With that said, I wonder if there's anything, previous studies that have kind of addressed this question, right? Has actually the kind of translator status, gender or profession actually had an impact on these studies? And I think that if you could answer that question, you'll bring a little bit more insight in showing how, as you kind of hint, how the expectations of those having a factor didn't actually play out that much. So that was the question that I wanted to ask to the first presentations. Second, to Professor Kim and Professor Kim. Well, actually, since I'm speaking in English, Byung-jun and Young-soo, yes, I finally did it. I think your conclusion compellingly demonstrates some of the kind of intuition that we had. So yes, global Korean studies will have a more kind of contemporary aspect, and the gender of the Korean studies, people will have some kind of different approaches. And I do agree with that, but I did want to kind of bring up the question of gender, and I think you kind of answered it to some degree. So it wasn't clear in the kind of pre-circulated materials, but you did say that recognizing the gender of the different orders was something you could only find in the Korean database sources. But I still wonder if the gender and feminine thing is only restricted to that. So does gender actually play another role or different roles in other researches? I think that will be something that we'll be all be interested on. Professor Levmanovich, I really don't know if I'm supposed to be doing a kind of commentary on this. I feel a little bit overwhelmed. But one thing that I was curious, and this is mostly related to methodology, is at least based on my limited experience, like when digital humanities, again, the kind of traditional one where we kind of focus on text, we are very much concerned about the kind of copyright issues and that kind of thing. And as someone who is very much ignorant in this field, I wonder how these kind of large-scale cultural analytics deal with the issue of copyrights, scraping data, and what kind of challenges, implications. And I hope that this question helps the students who might want to dive into this field, think about how they deal with this kind of copyrights and that kind of stuff. So those are the three questions that I had. Thank you very much, and that concludes at least my limited commentaries. Thank you very much.
Okay, thanks for the wonderful questions and comments. And we have three questions, two from Sue and one from Won-hee. And I'm going to answer the first question, and the other two questions will be answered by my colleague, Sarah. The first question was about the equivalence band. So we adjusted the number. We actually fixed the number at plus minus 0.1. That's arbitrary, just like 0.05 in statistics, right? So that part, yes, that was not real question. His question was, we extended it to 0.15 to see the sensitivity. At that level, every text was equal. So is there any chance for us to miss? I mean, we have missed something really meaningful and small. Yes, there is. So I completely agree with you, and your comments are valuable. So unfortunately, I had to skip the limitations part. I mentioned that part in my limitations. So we can go either way. Yes, there is a really small difference. Then let's take a look at, take a closer look at those things. What kind of small differences are they? But I'm just showing, we just showed two possibilities. One is totally equal, I mean, largely equal. The other possibility is, yes, if we just fix it at 0.1, then, yeah, there are really small and meaningful differences. Number two.
Yes, terrific questions. Thank you. So this is in response to, was our focus on veteran thought and speech, possibly missing elements of tone, atmosphere, or intentional silence? And my answer would perhaps be no, yes, and maybe. So one thing to consider is, and I'm arguing that this novel is a modernist novel. It is not just a coming-of-age story, simplistic tale, here's our beginning, middle, and end as this young person arrives to manhood. I shared with you the epigraph, which is a comment on what the novel is attempting to do. What I didn't share with you was the last page. It is also metatextual. So you have this novel about his service. At the end of his story, there is a large gap, and at the very bottom of the last page, the novel is now written in the third person, as if someone else is writing his story. We learn in the novel that Paul is an aspiring author. He would like to write a play, he would like to write books. So it is this highly constructed text that ends with this note that suggests this is even more constructed than you imagine. So one reason why we chose to focus on veteran thought and speech was that we believed it would grant greater access to the interiority of the veteran experience, closer to the truth of their experience. So maybe that's my yes. I have more, yes. However, we also think that that is an excellent question, and the next phase of this project would be to explore the full texts of all three, actually I should say four, now that Kurt Beals has released his translation. The Beals edition came out after our proposal and before our talk today, so that is a future step. And maybe my maybe is the novel was translated immediately into 23 languages. There's also the original German language to consider. Shall I do the question? Excellent. Yes. Wonderful. To the last question about veteran status or gender, I'll share that in a past life, I worked for the National Veterans Art Museum in Chicago, Illinois. It was previously the National Vietnam Veterans Art Museum. And one of the key distinctions is you needed to have your DD-214, your discharge paperwork. You needed to be a veteran. One of the big moves that those veterans made was to include women artists in the conversation more intentionally. So am I convinced that there is a distinction in the gender? No, absolutely not. But I think that part of the discourse of war, and your War and Women Human Rights Museum here in Seoul was such an inspiring space, strikes me that there may be more work to do here. Yes, and you saw on our slides in his private correspondence, it's in the archives in the Australian National Library, Arthur Wesley Ween took a diary note that said, "I was chosen by virtue of my experience, by virtue of having been a World War I veteran, not because I was a particularly good translator." And in fact, Brian Murdoch in 1993, when he did his translation, said, "This is not a very good translation," but his veteran status carried the day.
네, 두 번째 발표를 맡은 김병준입니다. 그 허수 교수님께서 여쭤보신 두 가지 질문인데요. 첫 번째 질문은 결국 이제 데이터 셀렉션의 문제입니다. 그래서 데이터 셋을 어떤 데이터 셋을 선택하고 그게 한국문학 연구와 뭐 해외 한국문학 연구와 어떻게 연계되는데 그거를 대표적으로 어떤 데이터를 쓸 것이냐의 문제라고 저는 이해를 했는데요. 데이터 필터링 과정에서 이제 국어국문학과는 이제 기본적으로 3분과 체제로 있어요. 그래서 현대문학, 컨템퍼러리 리터러처, 현대문학 연구, 그리고 고전문학, 그리고 국어학, 어학 연구가 있는데 이 데이터를 필터링하는 과정에서 현대문학 연구만 따로 제가 손으로 다 연구자들과 같이 해서 그걸 뽑아냈습니다. 그래서 아무래도 그런 식으로 대표성을 하기도 그 뽑는 과정에서 데이터 필터링을 거치기도 했고요. 물론 이제 그 문학장에서 그 이른바 비평, 크리티컬 하는 그 텍스트는 논문만 있는 것은 아닙니다. 당연히 현장 비평이라 그래서 뭐 매거진에서 나오는 다양한 문학 비평들이 있을 텐데 그런 텍스트도 사실 같이 들어가면 굉장히 좋을 것 같고 또 그 예를 들면 한국 문학 연구를 꼭 그 국어국문학과에서만 하는 건 아니잖아요. 그래서 뭐 사회학이나 뭐 정치학이나 심지어 정치학, 사회과학에서도 당연히 그런 문학 연구를 할 수 있을 텐데 그래서 향후 어떤 한국의 그 인문학, 사회과학 전체 분야에서의 그런 이런 한국 문학에 대한 연구로 나중에는 좀 확장을 하고 싶은 마음이 당연히 있고요. 지금 현재는 데이터를 그런 식으로 좀 선택을 해서 필터링을 했고 그걸로 가지고 이제 처리를 했던 어떻게 보면 한계일 수도 있고 그런 데이터의 성격을 가지고 있고요. 두 번째는 소셜 다이나믹스를 우리가 어떻게 측정할 수 있냐, 매저할 수 있냐. 그 점은 사실 이 연구의 약점이기도 하고 아직 더 드러나지 않은 것인데 예를 들면 지금 연구팀에서는 이런 가정을 가지고 있어요. 뭐 한국 그 문학 연구 논문에서 해외 다른 연구를 인용한다거나 아니면 어떤 해외 이론을 띠어를 가져와서 어떻게 쓰는지 그런 텍스트를 가져오는 인용 관계 분석 같은 것도 해볼 수 있을 것 같고 혹은 국내 한국 내에서 영어 영문학자들이 쓴 논문을 한국 문학 연구자들이 또 인용할 수도 있잖아요. 서로의 인용 관계 같은 것들을 가지고 와서 거기 안에서의 소셜 다이나믹스를 보고 싶은 게 일단 추후에 할 연구이기도 하고 그 지도 학생들이랑 같이 잘 진행을 해보겠습니다. 네, 그래서 그 두 가지 질문이 있었고 또 이제 조은희 교수님 여쭤보신 거는 그 젠더의 그런 질문이 있었는데 사실 발표 때 좀 어느 정도 해결이 되긴 했어요. 그래서 젠더 요소 분석이 왜 한국문학 연구에만 국한돼 있냐 그건 사실은 데이터 어베일러빌리티 때문입니다. 그래서 데이터를 지금 영어 영문학 쪽 데이터를 제가 다 수집을 못했고 그래서 연구자 젠더 정보를 가지고 당연히 그걸 확장해서 할 예정입니다. 다만 젠더가 모든 요소를 다 연구 경향을 그걸 다 결정하진 않겠죠. 당연히 예를 들면 30대 여성 연구자와 50대 여성 연구자는 당연히 서로 연구 경향이 다를 것입니다. 그래서 그런 나이 요소 같은 것도 저희가 지금 다 데이터가 준비되어 있거든요. 그래서 뭐 예를 들면 나이의 그 연구자의 당시 논문에 쓴 그 성별과 그리고 그 세대, 그 당시의 그 나이에 따라서 어떤 연구 경향의 그 영향이 있는지, 상관관계가 있는지도 추후에 같이 고려해서 연구를 해보고자 합니다. 네, 이상입니다.
Okay, well, we due for coffee break in a few minutes, so I'll try to be short. So, but I will address two questions. First of all, easy question about copyright. So basically, I'm a visual artist who uses university his platform, right? Because I prefer university people intelligent, educated, very nice, as opposed to art world full of some random, people, right? But I can bring this artistic, mobile approach to my research. So when we started doing our projects in 2009, we never cared about copyright. We would just download whatever data we wanted. And this is what allowed us to move very fast and in a way create these kind of methods and create like thousands of visualizations in a few years. And we never had any problem. The problem came later when we kind of published few of our studies in some kind of like academic peer-reviewed journals. In some cases it was okay, but in some cases we said no, we can't publish this visualization of let's say 50,000 Instagram images. If you want to publish it, you have to go to each author and ask for a permission, even though each image was like 1 pixel. So I said, okay, well, don't publish it. So now the second question, which is more difficult, about reduction, right? So I was kind of claiming that both cultural analytics and digital humanities, on the one hand, and generative AI share this Achilles heel of like reduction, because they're both based on statistics and machine learning. So here's the interesting twist, right? In the 20th century, there was this very standard idea that you can't fully describe images or film, right, or music with words, right? So as a semiotic system, words are more limiting. And in fact, this is this idea was my inspiration for cultural analytics, because I said, like I'm very frustrated by history, which tries to describe paintings or sculptures, and words just not able to differentiate some kind of very fine, subtle differences. So instead, I'm going to kind of extract features and measure things like brightness, saturation, texture, symmetry, composition. And since I can measure this quantitatively, it will give me like a much better language to talk about non-linguistic culture. And this is kind of true. But here's what happened, right? When generative AI, right, started to develop, and specifically kind of the network models to generate images using text prompts, at first, when you think about it, it looks terrible, right? Because you basically take images from the web, the images have this kind of short descriptions, right, in the HTML code, and then you basically train, right, you basically create this joint latent space, right, where this image, where words are correlated or connected to kind of words or phrases connected to images, right, which we describe. So when you think about it, you said this is terrible, and the results are going to be terrible, but the results are actually amazing, right? Because what I learned in the last 3 years, if you write very short prompt, yes, you will get something generic. But if you prompt like a paragraph, and if you use the right language, the system can create images in tens of thousands of styles with very particular moods, etc., etc. So in a way, right, it kind of contradicts our common sense. And it's kind of would be interesting to analyze why it works. I think partly it works because like this linguistic kind of descriptions, right? You don't just say color this or composition this. You say, well, I want the image which is like a bit surrealistic and the mood is a bit contemplative. So you're actually using this kind of higher level, right, almost abstract kind of quantifiers. And because there are plenty of examples of the stuff, right, on the web, and the neural networks can interpolate, right, between these examples, it actually works. So what I learned, right, by using generative AI is that I was wrong about language. But language is actually a much richer system for describing images than I ever thought. And that's, I think, interesting, kind of unexpected result.
Any other question? Yeah. Thank you for taking our time. Okay, we have a few minutes to the coffee break. So if you have any question of the audience, please feel free to raise. Yeah. 그 마이크 좀 전해주시겠어요?
My question goes to Professor Lev Manovich. I found your description of kind of visualizing the dynamic visuals, such as user interaction and kind of social media, interaction on social media, very fascinating. But it's hard to, at the same time, hard to wrap my head around. Could you describe what type of features, for instance, would go in a visualization like that?
Well, sorry. Well, yeah, I will be like. Okay. Well, thanks for your question. So so this is right. I declared this as one of my challenges, but we actually ourselves did very, very little work around it. I mean, we did creative visualizations, few visualizations of video games, where we basically recorded, right? Kind of recorded, members of our lab, right? Kind of playing, video game. Let's say 40 hours, 80 hours. And then, as the person was kind of playing video game, like we put a software where it was capturing the screen, right? I know every few seconds. And then I didn't put it in my presentation. And then we kind of used the same methods to visualize it. So you basically get like 40,000 or 80,000 or 400,000, like frames, right? Arranged in this array, so you kind of see like the person kind of playing video game. But I think, but that was just one attempt. I think more generally, right, the field, which is actually focusing on analyzing interactions, is human-computer interaction, HCI, and also people do it like game companies do it, right? So game companies, we have like special, parts where people are playing games, and then we're recording the play, and we're saying, okay, here, this part is very difficult, right? Lots of people fail. So we're going to make it easier. So I think the industry seems to be more ahead in figuring out ways to analyze, visualize, and use some kind of descriptions, right, of interactive culture, right? So I think it remains a very interesting challenge for us, and I think you can apply it even like to text, right? Because it's supposed to visualize, it's supposed to analyzing features in text. Maybe we can analyze instead, or in addition, like the individual process of individual readings of text, right? How do different readers read text, right? I mean, you can record eye movements, etc. I mean, you can basically devise systems to do that, right? So that's one idea which kind of comes to mind, right? Again, not analyzing the cultural artifact as it is, right? But analyzing kind of a process of reception, interaction with this artifact.
Okay. I think we have time for just one more question. Yeah. We have 5 minutes.
Okay. Wow, that's a lot of time. Yeah. A question for Sarah and Chongwan. I checked your the BERT model you used, and I was wondering because the training data came from Reddit, and one of the things you brought up toward the end of your presentation is you want to develop a model that is able to tell language from early 20th century. Have you started working on this, and have you been in conversation with other scholars? I know the Ted Underwood's team has been working on a language model that, say, only understands 19th century French or 18th century English. Have you considered training something like this that is custom made for your specific research purposes?
answer the question? Okay, that will be really ideal. So once again, that's one of our weaknesses too. The difference, the time span is dramatically different, right? So Go Emotions, yes, was trained based on really modern, right? Contemporary English, but we are dealing with the 1920s literature text. Then how can we have that kind of model based on 1920s text? Okay. As far as I know, there's nothing like that. So we might consider developing maybe similar models like that. Do you have anything to add?
Just the oral history archives.
Oh, yeah.
An additional layer where we hope to take this project is by comparing the literature against oral history archives, so recordings of veterans from different eras. Again, you'll have a bit of a distance. The time that they record their memories is not the time that they're experiencing it.
So maybe different from most of the audience members here, both of us are pretty new to digital humanities because we are coming from linguistics and literature. So this is our first project. And we realized how much we have to do actually to produce something more reasonable and more meaningful. So the oral history, we collected oral history data from World War I. So that may be a little better actually when we put the data size, according to you, okay, the big data, our big data is not really big data. So still it's really tiny based on your definition. Right? So I don't know how much we can produce more exact, okay, preferable or reasonable outcome based on the reader. So we are considering, your comment and your suggestions and those things still. Okay, we are aware of that. Okay, thank you very much.
Thank you. Okay, this concludes session 1, Big Data in Society and Culture. Thank you once again to all our speakers and discussants for their thoughtful presentations and engaging discussion, and to everyone here for your attention and participation. Please join me in giving one final round of applause to our presenters and discussants. We will now take a short break before the next session begin at 3:30.
예, 영어로 농담하려고 안 되겠어요. 네. Good afternoon, everyone, and welcome to session 2, titled Convergence of Humanities and Artificial Intelligence. My name is Hye-Yoon Jung, from Institute for Digital Hues and from Department of Spanish, Korea University, and I will be moderating this session. In this panel, we will explore how the humanities and artificial intelligence intersect, from quantitative approaches to language and literature to creative application of large language models. As in the previous session, each speaker will have 30 minutes for their presentation. And after the 3 talks, we will invite 2 discussants to share their comments and questions, followed by an open Q&A session. Let me introduce our first speaker. Our first speaker is Professor Jaume Baixeris. I practiced a lot. From the Department of Computer Science at the Universidad Politécnica de Catalunya in Spain. Professor Baixeris is a leading researcher in quantitative linguistics and complexity theory and computational approaches to language. In his talk today, From Text to Truth, he will demonstrate how these quantitative methods can contribute to digital humanities, especially in stylometry, authorship analysis, and AI-generated plagiarism detection. Please join me in welcoming Professor Baixeris.
Thank you very much. Thank you very much for this invitation. My name is Jaume Baixeris. I'm a computer scientist, so I'm not one of yours. I'm on the other side. I work in the Department of Computer Science in the Polytechnical University of Catalonia in Barcelona, Catalonia. So in this talk, I will try to do one thing, which is try to convince you that quantitative linguistics may be an interesting approach, may be helpful for humanities research. So my presentation will be divided into 2 parts. In the first part, I will present quantitative linguistics and also the work that we do in our lab, also basically to help you understand what quantitative linguistics is about. I will try to convince you that quantitative linguistics can be of interest to humanities. And if I did not succeed in convincing you in the first part, in the second part of my presentation, I will show you how quantitative linguistics can be applied to one specific subject, which is that of plagiarism. So let's talk about quantitative linguistics. This is a tree that shows the main subjects which are in artificial intelligence. Obviously, this tree is far from being complete, but just to give you an idea of where quantitative linguistics is located. Quantitative linguistics is a sub-branch of natural language processing, which is one of the main branch of artificial intelligence. So quantitative linguistics examines patterns, finds patterns, laws that apply to all languages. One thing which needs to be clear is that quantitative linguistics treats human language as a whole. It doesn't treat particular languages, but it considers human language to be a communication system of its own, and it studies this communication system. We used to find these patterns and laws using mathematical and physical and laws that also appear in physics. So a more detailed definition of quantitative linguistics, which can be a little bit harsh on classical linguists, linguistics is that of Gabriel Ullmann. He said that quantitative linguistics searches for models of phenomena and tests these models. That means we observe things in language, we propose a mathematical model, and we test this model. And this is something that is done in physics, in engineering, in every branch of science. And he opposes this view to the classical view of what he calls qualitative linguistics, that is classical linguistics, in which, according to Gabriel Ullmann, you adhere to one school and, for instance, you decide that you belong to the generative grammar linguist, branch of linguistics, you stay there and you fight against other branches or other schools. I know it's a little bit harsh because probably that's not exactly the truth, but it's just the opposition of two points of view of the same subject, language. We treat it as a physical phenomenon, and which is different from the classical view in classical linguistics. So quantitative linguistics is a discipline of its own. The basic goals of quantitative linguistics are finding, identifying laws and universals that happen in all languages. Probably some of you are already familiar with the Zipf's law. We will come maybe back to these laws later. We studied those things, but we assume that those laws and universals apply to all languages of the world, and then try to empirically test whether they hold or not in languages, as we will see soon. Quantitative linguistics also measures the complexity of languages. This is how much effort a speaker or a listener of a language has to do in order to understand, to produce and understand the sentences. It also studies how languages change in general terms over time. For instance, whether agglutinative languages tend to become inflectional over time. I'm not saying that this is true. I'm saying that this is one of the branches of the things that are studied in quantitative linguistics. We also study language acquisition. This is how children and foreign learners, L2 learners, learn a language. We will come back to that shortly. There is also a branch of quantitative linguistics, which is that of stilometry, which proposes different measures of stilometry in order to be able to map texts to authors. And in the second part of my presentation, we will go deeper into that. So from our point of view, quantitative linguistics is of interest to humanities because quantitative linguistics explains human language as a whole. It explains everything. It tries to explain everything. Its origins, its evolution, how it's learned, how it's used, and how it's evolving. And since language is the main cultural vehicle in, well, as long as I know, in humankind, then we think that the study of quantitative linguistics can be of interest to humanities. However, I will explain further and I will give you some more examples to prove you that this is true. So, and also there is an interesting thing in quantitative linguistics is that opposed to some other results in machine learning, etc., in artificial in general terms, in artificial intelligence in general terms, the results in quantitative linguistics may be easier to understand because the machinery that we employ sometimes is not as sophisticated as in other methods. But it's not always true, but it's somehow true. So let me introduce you briefly our laboratory, which is called in Catalan Lingüística Quantitativa Matemàtica I Computacional. I don't need to translate this name. We are 9 members. We have many visitors. Mostly, we are computer scientists, and that may be a little bit awkward because one may think, okay, what are computer scientists doing in linguistics? Well, we have linguists, we have physicists, and we have mathematicians. Honestly, I'm honest, we have a linguist and we have a physicist, that's true. They happen to be the same person, so mostly we are computer scientists. The list of items that are of our interest maps almost the list that I gave previously, and we will go deep into this list right away. So some of the things that we study is the testing empirically the existence of language universal in different languages, mostly in Catalan. What does it mean? We assume as a hypothesis that, for instance, the zip law of brevity, for instance, holds, and we examine large data sets containing text in Catalan, and we verify empirically that these laws hold also in Catalan or in other languages, but mostly in Catalan, in English or Spanish. We also study optimization, efficiency, and complexity in human language. As I said, this is the amount of effort that a speaker or a listener has to do in order to understand or to produce sentences in a language. We also study how children acquire language. We have a couple of papers which explain how children acquire polysemy when they learn a language. What we did was to take conversations of adults. Here we have 3 adults, father, investigator, and mother, with children. So they start speaking to them when they are 10 months old, 20 months old, 30 months old, etc., etc. And we test the average polysemy of the words that are used by each group. Polysemy, we assume that polysemy is the number of different meanings that a single word can have. For instance, bank may mean a place to sit, or also a financial institution, for instance. So what we see in this graphic, which appears in the paper in 2018, is that children, when they learn a language, they use words which contain low polysymous words. And then during the period of between 10 and 30 months of age, their average polysemy reaches that of adults. The interesting fact here is that psychologists, linguists, etc., have already observed that children tend to speak well. It means tend to make sentences that make sense, that are grammatically correct, etc., when they are in this period of time between 30 and 40 months old. So our results matches the observations which were performed before by psychologists and linguists. Obviously, here the explanation or the interpretation of this result is still open. Don't they use polysemy because it's difficult for them, because they are not exposed to? Well, they are exposed to, because if we look at the average polysemy of adults at the same age, it remains constant along the time. So parents and adults use the same amount of polysymous words, regardless of the age of the child. Yet children, they don't have the same capacity to use those words at the beginning. Do they start to speak well because they have been able to acquire this amount of polysymous words? Again, this question remains open. We also study communication systems beyond human language. That is, how animals or chemical compounds communicate. Because again, quantitative linguistics takes language as a communication system. Our 2 members of our group have published a textbook in quantitative linguistics in Spanish, which has been translated into Italian and will be soon translated into Romanian. And well, that's it. That's the first part of my talk. So I don't know if I convinced you much if quantitative linguistics can be of interest to you or not. I hope I somehow did. But now I will show you one application of one branch of quantitative linguistics, which is stilometry. And stilometry facing one problem which is currently present, which is that of plagiarism. Plagiarism is the guy behind the door, the ugly one. And well, plagiarism abounds. Here we are all lecturers and students, and if we are all honest, we will agree that this is a real problem. So now I will show you some weird cases of plagiarisms. I think that I don't need to convince you that plagiarism is a problem, but I will give you, nevertheless, some examples. I will ask whether AI detectors can detect AI texts. And then I will show you how quantitative linguistics handles this problem with stilometry. So this, to show you just one single example of how difficult it may be to distinguish between real things and not so real things. I have this funny example. Please, can you play the video?
はい、こんにちは。私はタムです。テキサスから来ました。英語を勉強しています。やった。I love the Japanese people, obviously. Shooting Last Samurai was extraordinary. They also make incredible timepieces. Just the sparkle. Misa sparkle. Shut up! Okay, do I need to go and do an Australian accent for the Australian market? We did Japan, right? We're good on that motion?
Okay, thank you. Well, this is just one funny example. Obviously, this video is fake, but it's fake because the oops. Oh, thank you so much. It's fake because I told you that it was fake because it comes from an X account which is called Deep Tom Cruise, which suggests that probably the video is fake. It displays Tom Cruise speaking in Japanese, etc. However, the video looks very, very true. I mean, if Tom Cruise was not doing those weird things and talking about those weird things, probably it would be something that we could think that it could be true. So this is just to show you that we are surrounded by things, and now it's very difficult to distinguish real from fake things. So from now on, I will just stick to written text. I will leave behind video, images, and so on. So some extreme weird cases of plagiarism is, for instance, the possibility, you already know that Amazon offers the possibility to self-publish books, which has a good side, which is that it democratizes the publishing of books. Also, it has some bad sides, which is the fact that everything can be published. And in fact, they are flooded by texts which are AI generated. Another weird case of plagiarism is that of an author, which well, one of his friends called him and said, okay, I saw your paper in this journal, which has been accepted, congratulations. And that person was shocked because that paper, well, he knew nothing about it, but it was authored by him. And in fact, it had been accepted in a conference. And somebody used his name to fake a paper, submit to a journal, the journal accepted it, and it was on the system. So the paper was not written by him, it was clearly AI generated. Another weird example of plagiarism is that of Deloitte, which decided that instead of finding help in AI systems decided that AI systems should do all the work. So they just issued a work which contained simply false information. This document passed through because on the surface it looked legitimate, and that's the problem with AI, that everything that produces, it looks legitimate, it looks human, but then if you analyze it, it's not human, and that's the problem. So one legitimate question would be, can AI detect AI? I did a small experiment on my own. So what I did was to take an article which was published in a website. This article is called The Alabama Solution, which is a review of a documentary with the same name. And I prompt ChatGPT the following. I have an article in English. Can you write an article mimicking the same style and the same subject? I need it to be of the same length. So ChatGPT produced this, well, that's the header of both papers. So you can see if you read both headers, both look legitimate. They look, well, at least to me, but I'm not a native speaker of English, so, but they look legitimate to me. The only problem is that the AI-generated text obviously contained some hallucinations, as they called the errors that appear on AI systems. So for instance, the lost one is not the name of any film. I checked on the Internet Movie Database. There were some lost one films, but they were films, not documentaries. Nia Caldwell is not a film director. At least it doesn't appear in IMDb. And sadly enough, Greenwood Youth Rehabilitation Center seems not to exist. But in order to verify it, I asked ChatGPT, which produced this text, to check for this place. And the same ChatGPT answered that it was not able to find credible evidence that this youth rehabilitation center existed. So one may think that, okay, if a text contains hallucinations, probably it's very easy to find out that it's not a legitimate text. So what I did is to check those 6 AI systems, AI detectors, whether they could tell me if this text was legitimate or not. GPT-0 and Copilix performed pretty well, but the remaining 4 did not. So I did another text using asking ChatGPT to produce a text similar to that of one article written by Ampar Moliner. Ampar Moliner is a Catalan writer, journalist, author. She also appears on TV. She has a very specific style, so we thought that because of that, it would be easily copied. It's like what we saw previously. Tom Cruise has a very specific set of features which make him very, well, unique, let's say. He's very histrionic, so it's quite easy, I guess, to copy him. That's the case of Ampar Moliner. So in this case, ChatGPT performed really bad, Copilix really bad as well, and Just Dan, which previously performed really bad, now performed really well. So I'm not claiming that those AI detectors are not good enough, because I did 2 experiments. I have to say that those 2 experiments were not cherry-picked. We just did those 2 experiments and we had contradictory results. However, there is a paper which is published in Spanish in which what they do is they create 3 sets of text in Spanish. Human text, text created by AI systems, by large language models, and mixed text, which is something that we will see now that it also exists. And they check the performance of 3 detectors against text generated by ChatGPT, Gemini, and Grok. What they said is that statistically, texts which were mixed were not well detected by those 3 systems. And the conclusion is very clear. You take a huge risk if you rely solely on those detectors. So, and yet we need to distinguish between texts which are generated by humans and texts which are generated by large language models. For ethical reasons, obviously, also for legal reasons, and also for a practical reason, which is that we have to prevent to feed, to train those large language models with texts which have been created by themselves. Those systems need to be fed with materials of human origin. So I will show you now very shortly in 4 papers short how stellometry in quantitative linguistics may handle this problem well. This paper is very interesting because what they do is they take text from Ernest Hemingway and Mary Shelley, and they ask ChatGPT to generate similar text. They have 3 prompts. They say, can you generate a text like this one? They also say, can you generate a text like this one, mimicking the style of the author? And finally, they say, can you generate a text like this one, mimicking the style of the author, and also talking about the same theme? So they compare the text, and they want to distinguish between text generated by humans, I mean the original text, and those generated by LLM systems. The conclusion is that LLM systems can imitate very well the style of a writer, just as we saw previously in the case of Tom Cruise. I mean, it was Tom Cruise, but it was not, except for the fact that it was not. So they do that. They imitate the style very well, but if you perform an in-depth analysis, then you catch them. In this paper, what they do, they analyze academic papers. They claim that a large language model overused some words in some different periods of time. Let's say that in 2023, some words were overused by large language models. In 2024, some other words. In 2025, some other words. So what they observed is that words which were overused in the past are not overused now in academic papers. And words which are currently favored by large language models are now increased its presence in academic papers, which according to the authors seems to suggest that authors, they take information from large language models and they edit the papers. There are 2 more papers which are relevant because they classify well text generated by humans and text generated by AI models. This paper here and this paper here, using different stellometric measures and sophisticated machine learning methods, they are able to distinguish things. So it means that quantitative linguistics seems to be very good in distinguishing between text created by humans in a consistent way and text created by large language model. We don't have those things that in some cases we do it well and in other cases we don't do it well. The results are very consistent and very determinant. Quantitative linguistics has a set of methods that seem to work in this case. The only 2 problems that may be attributed to those methods that we've seen before is that they may be difficult to train because some of the methods need to be trained and it costs, and also that the results may be a little bit difficult to interpret. I mean, the results, the outcome of these systems is clear. This is a human created text, this is not. However, to understand the reason why it classifies this text as human or as non-human may be a little bit difficult to understand because of the sophistication of the systems. So from our laboratory, we have proposed a new measure, which is that of semanticity. Semanticity is the number of different words that the semanticity of a word, for instance, the semanticity of the word house, with a distance d, is the number of different words which are found in text at a distance from this word. it may be a simple measure. It captures some a little bit of syntax, which is this distance, and a little bit of semantics, which is the different number of words this word is related to. But we have used successfully to distinguish content words and function words in Catalan. And we are using currently this measure to distinguish human and LLM generated text. The good thing about this measure is that it's very simple, it's very easy to compute, it's very easy to interpret. So if we have successful results, the results will be very easily interpretable. So the conclusions. We cannot ignore the presence of AI, and we cannot ignore the fact that we have to deal with the burden of having to distinguish human-created text and AI-created text that exist, that will exist, and that will be forever. There is no magical rule. I mean, maybe those methods which are successful now will not be successful in the future because large language models in particular are becoming every time better and better. So what we need to do is to improve our methodology when those methods improve. But the thing that I want to stress here is that we provide models. Models say things, but they need to be interpreted. Meaning needs to be given to those models. We give mathematical equations, we give statistical methods, but still we need to interpret, we need to give meaning to those models. And I think that this is the job of humanity researchers, to understand what we do and interpret it and give it back to society so that it can help to explain what's going on in the world. So if I have to conclude, and the general idea of my talk is that computer scientists, which is this robot there in the right-hand side, and humanity researchers, which is this Greek philosopher, we need to work together and we need to be friends. 감사합니다.
Thank you, Professor Baisheri. What I find especially very relevant in your talk is how your quantitative approach helps us confront one of the most pressing issues in digital scholarship today. As you have shown, plagiarism, 표절, in the age of AI is no longer a simple matter of copying, but a complex question of authorship, ethics, and human verification. So thank you for letting us to think about it seriously. Please give another applause to Professor Baisheri. Now I will present the second presenter. Our second presentation is by Professor Sung-hyun Jang from the Department of English at Korea University. His areas of specialization include British Romantic poetry, Victorian poetry, and digital humanities. His talk today, Tracing Tennyson's Stylistic Shift, presents an ongoing digital humanities project that examines the stylistic evolution of Alfred Tennyson's poetry through computational analysis. So floor is yours, Professor Jang. Yes.
전 슬래트 파일은 어떻게 돼요? Okay, so good afternoon, everyone, and thank you for being here. Today, I'm excited to present Tracing Tennyson's Stylistic Shifts, stylometric insights from early lyrics to late epics.
We all know Alfred Lord Tennyson as the voice of the Victorian age, a poet whose career spanned over 6 decades. Literary critics have long debated the evolution of this style. But what if we could measure this evolution? What if we could use computational methods to track the precise changes in its language, sentence structure, and vocabulary? And this is the core question of my research. Using a digital humanities approach called stylometry, I will analyze Tennyson's poetry not just as art, but as data. My primary goal is essentially twofold. First, I want to answer the what. Does Tennyson's poetic style exhibit statistically significant changes across his career? To investigate this, I've categorized his work into 3 distinct periods: early, middle, and late. Second, I want to answer the why. If we define quantitative changes, what is their nature and what caused them? And this is where we move from data to interpretation, placing these shifts within the rich literary historical context. As the slide indicates, my methodology is hybrid. I am combining quantitative stylometric techniques with qualitative literary interpretation. The study I'm presenting today is research in progress. It is an active and ongoing investigation, not a fully concluded project. Therefore, the findings I will be sharing are preliminary, but they are already revealing fascinating patterns that I'm excited to discuss with you. As I mentioned, I have divided his long career into 3 phases. First, the early period, covering the 1830s and 40s. And this corpus includes his celebrated lyrical poems like The Lady of Shalott, Mariana, and Ulysses. These are the works most defined by the rich romantic imagery and psychological introspection. Second, the middle period, which I have focused on the 1850s. This period is unique as it consists of a single monumental text, In Memoriam AHH. The reason for treating it as a standalone period is that it was composed over 17 years. It therefore functions as a microcosm in itself, a personal and stylistic journey captured in a single volume. Finally, the late period covers the 1860s through the 1880s. This is represented by his massive epic cycle, Ideals of the King. This work represents the culmination of his motto style and his role as a public poet laureate, engaging with grand national and moral themes. So now to analyze the collective style of each era, as noted at the top of the slide, I consolidated the texts from each period into 3 main files. Okay, so the next question is how to measure the stylistic differences between these 3 periods. First, to get a high-level visual understanding of the relationships between the 3 periods, I am using Stylo for R. This is a widely used package within the R programming environment. And it is a standard tool in the field of digital humanities for stylometry. It's powerful because it can statistically analyze text based on word frequencies and other features. Using Stylo, I will perform 2 key analyses. First, a cluster analysis. Second, I will conduct a principal components analysis, or PCA. The first result, which comes from the cluster analysis, this method creates a family tree or dendrogram for my texts. To do this, I first broke down the 3 corpus files into smaller, equal-sized segments. In this case, each leaf on the tree, each label, represents a 3,000-word chunk. The analysis then measures the stylistic similarity between all of these chunks. The specific fingerprint used here is the frequency of the 100 most frequent words, or MFW. And the distance metric is Euclidean distance. Now let's look at what this tree tells us. The analysis clearly separates the text chunks into 2 massive, distinct branches. The bottom branch in green consists entirely of chunks from the late period. The top branch contains almost all the chunks from the early period in red and the middle period in blue. And this is a clear finding. The style of Tennyson's late work is dramatically and consistently different from everything that came before it. But what about the middle period? If you look closely at the top range, the middle chunks are nested within the early cluster. And this visually confirms that in memoriam, still shares a stylistic DNA with his early work. Okay, so different parameters, but a similar pattern. And I ran the analysis one more time, again adjusting the parameters. And as you can see, the overall structure is remarkably stable. We see the exact same primary split with the late period forming its own supercluster, separate from the early and middle periods. But the most interesting part of this analysis is the middle period. If you look at the blue labels, you see that all of the middle chunks are now grouped together in one single cluster. And this analysis shows them as a cohesive stylistic unit. To further test the reliability of these clusters, I performed the bootstrap consensus tree analysis. And you can see a deep fundamental split in the data. On one side, all the late period chunks branch up together, forming a separate and unified cluster. On the other side, we find all the early and middle period chunks. And crucially, within that early and middle branch, the middle texts once again form their own subcluster. And this confirms that they are stylistically similar to the early works, but also distinguishable from them. And this is principal components analysis, or PCA. Or PCA takes the complex high-dimensional data and reduces them down to a simple 2D chart. The two axes, PC1 and PC2, represent the two strongest dimensions of stylistic variation. The result provides a powerful confirmation of the cluster analysis. So notice how this PC1 axis creates an almost perfect division. To the right of the central dotted line, we have a large dense cluster of all the late period chunks. To the left of the line, we find all of the early and middle chunks. And what about the middle period? You can see they are positioned firmly in the same territory as the early texts. They are not up in their own separate space. And this visually confirms that in memoriam, it is stylistically very close to the early works, even as it forms its own cluster within that larger group. Okay, so similar results. Okay, now let me briefly summarize the key conclusions drawn from all the style results we have just seen. First, there is a clear, major, statistically significant stylistic break in Tennyson's career. The late period on one side and the early and middle periods on the other. Second, the middle period in memoriam has a dual identity. It is stylistically closer to his early works. However, it is not identical. The middle period chunks form their own subcluster, proving it has a unique and highly consistent stylistic signature of its own. Okay, so now the stylistic analysis has given me the macro perspective. Now, I need to move to micro perspective. For this deeper, more granular analysis, I am using Python. As the slide states, I selected Python because it has an incredibly robust ecosystem for natural language processing, or NLP. And using Python, I'm conducting a suite of specific analysis, and this slide outlines my roadmap. And this analysis will, together, help me build a complete picture of how Tennyson's style evolved. Yeah, this slide shows the crucial first step of setting up the analysis environment. The code you see on the left is the first cell from my Jupyter notebook, which imports all the necessary tools. My primary tool for the deep linguistic analysis is the Spacey library. I chose Spacey because it's a modern, state-of-the-art NLP library that is fast and efficient at parsing text, is particularly powerful for the syntactic complexity analysis I mentioned earlier. And as you see in step 3, I am not using a simple, small statistical model. Instead, I've specifically installed ENCO Web TLF. This is a powerful English transformer model. And by using this, species can understand words in their context, which provides far more accurate and linguistically rich annotations for everything from part of speech tagging to sentence structure. And this superior accuracy is fundamental to the entire Python portion of my study. And this is the foundational data, the total number of sentences and tokens that species identified in each period. A token here refers to an individual word or punctuation mark. This table confirms the significant difference in text length between the corpora. And this difference is precisely why normalization is critical for all my upcoming frequency analysis. So using the sentence and token data parsed by the speech transformer model, I can now present my first set of findings on syntactic complexity. This table shows 4 key metrics I calculated to understand the structure of Tennyson's writing. The definitions are on the slide. Mean and median sentence length are straightforward. The average length and the middle value length of a sentence. And subordinate per sentence is a crucial direct measure of grammatical complexity. It counts how often he uses dependent clauses. And finally, MDD, mean dependency distance. This is a more sophisticated computational metric. It measures, on average, how spread out or nested a sentence's grammar is. The higher MDD score suggests more complex phrasal structures. Okay, this slide provides a visual representation of the mean sentence length data we just saw in the table. As the bar chart shows, there is a clear and progressive increase in the average number of tokens per sentence as Tennyson's career progresses. And as the text on the right explains, in literary stylistics, this isn't just about length. It's a strong indicator of greater syntactic elaboration, more complex narrative structures, and the kind of Victorian-style periodic phrasing that we associate with grand subjects. If a mean sentence length told us his sentences are getting longer, this metric, subordinate per sentence, tells us they are getting more complex. The bar chart itself shows a clear trend. The list style of Ideals of the King is not just defined by long sentences, but by sentences that are grammatically more intricate and layered. In short, it's a direct measure of syntactic depth and what linguists call a hypertactic style. A style where ideas are hierarchically nested within a sentence, which is typical of formal Victorian prose and poetry. Okay, this chart shows the mean dependence distance. This is perhaps the most sophisticated metric for complexity. It doesn't just count what is in a sentence, but how the sentence is arranged. In simple terms, a high MDD means that grammatically related words, like a subject and its verb, are often separated from each other by other words or clauses. And this spreading out of grammar is a hallmark of highly complex, nested sentence structures. Now, the data on this chart does not show the same simple linear increase as the other metrics. The middle period in memoriam shows a slight dip to 2.77. And it suggests that even though the sentences in memoriam are longer and have more subordinate clauses, their internal structure might actually be more regular or orderly. This might be due to the poem's very strict and uniform stanzaic form, which could channel the syntax into more predictable patterns. In the late period, the MDD lives to 3.31, by far the highest of the three. The style of Iris of the King is definitely the most complex. He is not only writing longer sentences with more clauses, but he is also arranging those clauses in more intricate, spread out ways, which is characteristic of the grand epic style he was aiming for. Okay, I'm going to skip this. And all right, so I have looked at the structure of his sentences. My next set of analysis focuses on his vocabulary, specifically his lexical diversity. This slide defines the key metrics I used. Tokens is simple, the total number of alphabetic words in the text. Types is the count of unique words. Now, the most basic measure of diversity is the TTR, type token ratio, which is just the number of types divided by tokens. However, TTR is deeply flawed when comparing texts of different length. A longer text naturally has a lower TTR. To get a reliable comparison, I must use more sophisticated length-independent metrics. I've used two. First, MATTR, which stands for Moving Average Type Token Ratio. And this method solves the length problem by chopping the entire text into small, equal-sized windows, in this case, 5-word chunks, calculating the TTR for each chunk, and then taking the average of all those scores. Second, MTLD, or Measure of Textual Lexical Diversity. And this is a very robust modern metric. In simple terms, it scans the text and measures, on average, how many words it takes for the vocabulary diversity to fall below a specific threshold, which is 0.72. For both MATTR and MTLD, the higher score means greater lexical richness and diversity. Okay, so this slide visualizes the data from the previous slide, which makes the trends much easier to see. A key discovery is that Tennyson's great middle period poem, In Memoriam, represents the peak of his lexical creativity. The metrics show that the late period was written with a slightly less diverse vocabulary than his middle period work. Okay, now, the MATTR and MTLD values I just showed you were single average scores for each period. A single number, however, doesn't tell us the whole story. It doesn't show us the variance or the uncertainty of this measure. So, to get a more reliable and statistically robust comparison, I've applied a bootstrapping method. Bootstrapping lets me move from a single point estimate to a full sampling distribution. This is a much more powerful way to visualize the uncertainty and robustly compare the periods. Let's look at this first bootstrap chart, which analyzes TTR. As noted at the top, I did not just calculate one TTR for each massive text. Instead, I took many random 5,000 token samples from each of the three periods, and then I calculated the TTR for each of those equal-sized chunks. Okay, I applied the same bootstrapping method to MATTR, and this final box plot shows the bootstrap results for MTLD, which is arguably the most sophisticated and reliable metric for lexical diversity. And as the points on the right explain, MTLD doesn't just average the diversity, it measures the dynamism of the vocabulary, how long on average it takes for the text to become repetitive and for the TTR to drop below a set threshold. Therefore, a higher MTLD score means greater, more sustained lexical variety. 10분 남았는데요. 제가 이거 저도 동시에 이거 지금 켰거든요. Okay, there are two conclusions I draw from the three box plots for TTR, MATTR, and MTLD. First, in memoriam represents the peak of Tennyson's lexical richness and vocabulary dynamism. The second conclusion shows why using multiple metrics it is so crucial. If you look at the TTR and MATTR plots, they both suggest that the late period has the lowest local diversity, and this indicates a style that is more repetitive. However, when you look at the MTLD plot, we see a different story. Here, the late period is more lexically sophisticated than the early period. This is not a contradiction. It's a key insight. The late style is structurally more repetitive, but globally more sophisticated than his early work. Yeah. So in the previous slides, the box plots visually suggested that the lexical diversity scores were different across the three periods. But in quantitative research, a visual observation is not enough. So I needed to determine if these differences were statistically significant or if they could have been the result of a random chance. To do this, I performed the Kruskal-Wallis age test. I chose this specific test because it is the correct non-parametric method for comparing the distributions of three or more independent groups without assuming the data is normally distributed. This table shows the results, and I want to draw your attention to two key columns. First, and most importantly, is the p-value. This tells us the probability that the observed differences are a fluke. And the standard threshold for significance in science is usually 0.05. As you can see, the p-values for all three of my metrics are infinitesimally small. And this means I can confidently reject the null hypothesis. The differences in lexical diversity that we saw in the box plots are real and statistically significant. Second, the p-value tells me the difference is real, but it doesn't tell me if it's big. For that, I will look at the epsilon squared, which measures the effect size or the magnitude of the difference. As the slide notes, both TTR and MATTR show large effects, and MTLD, our most sophisticated metric, shows a solid medium effect. So the Kruskal-Wallis test gave me a single global answer. Yes, there is a statistically significant difference somewhere among the three periods, but that's not specific enough. It doesn't tell me which periods are different from each other. To answer this, I perform a Dunn's post hoc test. This is the standard follow-up test. It performs a pairwise comparison for every possible combination, early versus middle versus late, and early versus late, to pinpoint exactly where those significant differences lie. This table shows the p-values for those comparisons, specifically for MTLD. And let's read the results. First, look at early versus middle. The p-value is far, far below the 0.05 threshold. This means the middle period is statistically significantly different from the early period. The middle period is also statistically significantly different from the late period. But now, the most interesting part is early versus late. The p-value here is 1. This means there is no statistically significant difference between the early and late periods in terms of the lexical diversity as measured by MTLD. And this is a crucial discovery. Tennyson's middle period is a strong stylistic deviation in terms of vocabulary dynamism. His early and late styles are, statistically speaking, similar, while his middle period stands alone. Okay, now I move to the frequency of archaism. First, as the slide explains, I used an archaic lexicon, which is a predefined list of archaic words. Second, I specifically sorted for words with the historical verb suffixes ETH and EST, as these are strong markers of an antiquated style. The crucial column in this table is per 10K. This shows the normalized frequency of all archaic forms per 10,000 tokens. And this bar chart visualizes the normalized data from the previous table. And this per 10K metric is the only way to get a fair comparison, as it adjusts for the different length of the corpora. A higher bar means a higher density of archaic language. And what we see is a clear progressive increase in the use of archaisms across Tennyson's career. The late period jumps to the peak of over 300. And this is Idris of the King. So to write an epic poem about the medieval world of King Arthur, Tennyson made a conscious and deliberate stylistic choice to adopt an archaizing style. Now I'm introducing another very different type of analysis. This is the Jensen-Shannon distance, or JSD. And what is this and what am I measuring? JSD, as I'm using it here, allows me to zoom in on a very specific subconscious layer of style, the distribution of function words. And these are the non-lexical grammatical glue of the language. An author's preference for these words is often a deep unconscious habit. Now let's look at the results in the table. First, as the slide notes, all the values are relatively low. It confirms that we are dealing with a single author. At this fundamental grammatical level, Tennyson's authorial fingerprint remains consistent across his career. However, the trend of these values is the real story. Notice that the distance is increasing. It shows a progressive stylistic drift. Its fundamental grammatical structure or syntactic rhythm is evolving. And it confirms that the most marked evolution in this deep structure happens after the middle period. Okay, so far we have explored the structural changes in Tennyson's style, sentence length, lexical diversity, and the frequency of archaisms. Now I want to dig deeper into the thematic content. What specific words are most characteristic of each period? To do this, I performed a likelihood ratio k-needs analysis. This is a powerful statistical test that identifies diagnostic words. It finds which words are statistically overrepresented in one corpus when compared to another. And this slide shows the output, the top 15 keywords that are most uniquely characteristic of each period, along with their anti-keywords. The next slide summarizes the meaning of those results. This LLR analysis allows me to trace Tennyson's stylistic trajectory, not just as a set of abstract numbers, but as a concrete thematic evolution. Okay, following the thematic analysis from the LLR, I wanted to see if these stylistic shifts were also reflected at a deep grammatical level. To do this, I calculated the proportional distribution of major parts of speech, or POS, for each period. The land graph shows the proportion of adjectives, adverbs, nouns, proper nouns, and verbs. The results paint a picture of its stylistic progression, and it aligns with my other findings. And my final analysis moves from sentence structure and vocabulary to the emotional layer of the text. I wanted to see if I could track the dominant sentiment or emotional trajectory of Tennyson's poetry across his career. To do this, I used two different tools as they are built differently and capture different things. Vader, which is a balance-based dictionary specifically optimized for short texts. A text block, which is a general-purpose analyzer that provides two key scores, clarity and subjectivity. The table shows the average scores for each period. For me, the most fascinating finding on this slide comes from a text block's subjectivity score in the orange table. So look at the TB subjectivity values. The early and late periods are both more subjective, but the middle period, in memoriam, has the lowest score. This is an insight. This score means that in memoriam, his great poem of grief, his great elegy is ironically the most objective and least opinionated of his works. Okay, another emotion analysis using the NRC emotion lexicon. A crucial conclusion from this is that Tennyson's stylistic evolution seems to have occurred within the same core emotional framework. In other words, while the linguistic architecture of his poetry was rebuilt over his career, the fundamental emotional tone of his voice remained steady. Okay, so this brings me to the end of my analysis, and thank you very much for your time and attention.
Thank you, Professor Zhang, for your talk. Your stylometric tracing of Tennyson's stylistic evolution resonate actually my own research on the complete poetic works of Spanish poets such as Miguel de Unamuno, Luis Cernuda, and Antonio Machado. Actually, I work with him right now to compare between the stylistic variation between Antonio Machado and T.S. Eliot, by the way. It's fascinating to see how quantitative method can illustrate a poet's creative trajectory over time. Now, we are going to receive the third and final speaker. Our third and final speaker is Professor Richard Spratt, currently a research scientist at Sakana AI in Tokyo, in Japan. Prior to joining Sakana AI, he served as a research scientist at Google, working in both New York and Tokyo, and as a professor the University of Illinois at Urbana-Champaign, right? Okay. And Dr. Sprout's research spans computational linguistics, speech and text processing, writing systems, and statistical modeling of symbolic communication. Today, he will present his talk entitled Large Language Models for Constructed Languages, Being Creative while Proving What LLMs Know About Language. Please join me in welcoming Professor Richard Spratt.
So I hope you don't mind. I can't be tied to a lectern, so I'm going to move around a little bit, okay? Let me just make sure I've got the controls here. Is this... no, that's not it. Oh, is this the button, the green?
No, you can click the big one.
Big one. Okay, fine. So first of all, thanks to the organizers for the invitation. Second of all, I have to admit that I'm not sure this counts as digital humanities, but then I'm not entirely sure I know what the bounds of digital humanities are. But it's the end of the day, so I hope at least you'll find this amusing, if nothing else. But there is a more serious point here. So, you know, unless you've not been paying attention at all to the news, you will know that there's been a lot of hype about large language models and general, so-called artificial general intelligence. And but I'm a linguist by training, and my interest and the interest of other linguists in particular has been on what do large language models actually know about language? And there's been a whole bunch of work on this question, from various angles. I'm not going to have, time to summarize any of that stuff here today, but what I am going to do is sort of take a somewhat different take on looking into this question by asking the question of, large language models clearly know a lot about languages, so they know, well, in particular English, and to a lesser extent other languages as they get less and less frequently represented on the web. But how much do they know about language in kind of the abstract, or in particular linguistic variation, okay? So one way to probe this is to ask them to construct a new language. Okay, just make up a language, okay? Now, what do I mean by that? Well, of course, there's a whole field of constructed languages, which is often called conlangs for short. And, obviously, most famous example probably is Esperanto, which was actually made up to be a language that would substitute for a real language. And I believe there's about 1 million speakers of this language in the world, something like that. So it actually is used. But then maybe you're perhaps even more familiar with, if anyone's watched The Lord of the Rings, right? The Quenya, the Elvish language is one example, so the Tolkien's languages, also in science fiction, Klingon, things like that. There's so-called logical languages, there's philosophical language, so maybe one of the most famous examples is the English philosopher John Wilkins, who created a philosophical language, as he called it, and so on and so forth. And there's a whole community of so-called conlangers. Now, I am not a member of this community, but I have, in my time, created languages. But just out of curiosity, how many people have made up their own language in this room? Don't be shy. Okay. Okay, well, okay, a few. Okay, cool. We have a paper out. So this was joint work with my intern from last summer, Chihiro Taguchi, who is at Notre Dame University. And we created the system. You can get the paper from archive, and you can also, if you want to play around with it or look at the outputs, you can look at, we have a GitHub site. The name is a little bit of a construct in itself. We made it the name Iascabi, which happens to be the Irish Gaelic word for fish, when I work at sakana, so which is fish in Japanese, so it's kind of all fits together. Now, shortly before we put out this paper, there's another paper that came out that kind of got scooped, right? Somebody else had actually done similar work, and I was a little bit disappointed about this. But then I realized, well, okay, I tend to work on kind of weird stuff, and the fact that somebody else has also worked on this suggests maybe it's not that weird, and it's actually something sensible here. Okay, anyway, so what's the point? So we're basically going to use a large language model as an assistant to develop the phonotactics of the language. So for those of you in this audience who are not linguists, phonotactics means basically what words look like. So, you can have languages like Japanese, which have a fairly simple syllable structure, or you can have languages like Russian, which have an exceedingly complicated syllable structure, for example. Well, I'm going to skip that point. We then develop the morphosyntax of the language. Again, this just means, how the words are put together into sentences and how you change the words. So again, languages vary a lot. English doesn't have very much inflection. Korean, of course, has a great deal of inflection, and so on and so forth. And the way we do that is we're going to translate in stages from a source language original into the target language, okay? And I'll show you an instances of all of that. We then we'll actually use the phonotactics to fill out a lexicon. This is done kind of offline. It doesn't involve a large language model, although in principle it could be. We develop an orthography. Right now, this is based on an existing script, and I'll show you examples of that. And again, we use that to basically populate the lexicon with spellings of words. And then we write we actually have the system write a short grammatical treatise of the language, basically a couple of pages describing the language, okay? And have it make up a name for the language. You'll see that's kind of interesting in itself. And then so on and so forth, you can actually have it translate by adding morphemes to the lexicon. And, well, unfortunately it's covered here, but basically the point is we're particularly interested in these first three issues to see what the large language model understands about language, okay? Okay, so for example, I want a language that has Welsh-like phonotactics. Why Welsh? Well, I've been interested in Welsh for many years, and actually the CTO of our company is a Welsh native speaker, so that's two reasons, I guess. Syntax and inflectional morphology similar to that of Turkish, okay? An orthography that uses the Cyrillic script, so you can ask for these kinds of things. And some research questions, and this is really the important part. Can it indeed come up with a model that looks like the language I asked for? Okay. How well does it understand my instructions on how to create morphosyntactic features for the language? And how well, so how well does it understand each of these features? And how reasonable are the orthographic choices? And let's sort of start with the phonotactics here. So what are we going to do actually is this is what's termed these days an agentic system, where basically it's you prompt it to design a system saying, I want a language that has phonotactics similar to Welsh or Japanese or whatever. And this is going to give you basically a set of sounds, phonemes, and their nominal frequencies. So some sounds, of course, are more frequent in language than others, and so it gives you its sense of what the nominal frequencies are. And then it's going to produce Python code. This is something that language models are very good at these days. You know, had we had this 20 years ago, Professor Bach would not have needed me to teach him, and we could have just had a large language model do it. Then it's going to look at its code and its outputs, and it can say, okay, is there anything wrong with this? Maybe the code doesn't run at all in some cases, but you know, even if it does run, it may produce outputs which are not, you know, quite right. Then it can revise the code, and so go around in this loop, and eventually you, well, at the bottom here, again, it's covered, but basically you'll get a model, a Python program that you can run and actually have it produce words. Okay, so here's an example. Now, I realize probably nobody else in the audience knows anything about Welsh, but one thing I'll tell you about Welsh is that this is a set of the consonants, okay? And one of the most characteristics of features of the Welsh language is this so-called lateral fricative phoneme. So, for example, the word for library is llyfrgell, okay? So those ll and the end, that's a very distinctive sound in Welsh, and it was missing this on, this is, by the way, using Claude, the Anthropic system, the Claude Sonnet 3.5. This was actually missing it on the first iteration, but on the second iteration, it said, you know, it realized it was missing it and picked it up, okay? So I thought it was kind of cute. I mean, it was sort of realized that it made a mistake, and it sort of has some sense about, you know, Welsh phonotactics. Okay, so this is all very cute and everything, but how do you evaluate this? So what I did is I took, we took, you know, about 50 languages from Wiktionary, which have IPA, International Phonetic Alphabet, transcriptions in the lexicon. We use these to build a traditional old-style n-gram language model, which turns out to be, you know, traditionally has been used. It's quite good at, say, detecting, you know, is this English or is this Dutch based on letter frequencies. That's a very common technique. And so, you know, the closer it, you know, depending upon the distribution of the letters or the sounds in this case, you can say it's okay, it's closer to English or it's closer to, you know, Welsh or whatever. And then you generate, you use the grammar to generate, you know, say 10,000 morphemes, and you compute the perplexity, which is just basically a measure of how similar it is. The lower the perplexity, the more similar the two things are. And, you know, if it did it well, then, well, you know, it should be most similar to that language and not to some other language, okay? So there is a caveat here, and that is that Wiktionary has a very, I don't know if anybody's looked at Wiktionary from, you know, for different languages and their, you know, how they represent sounds, you know, of the language, but there's a great deal of, you know, great distribution in how fine-grained the transcriptions are. So, for example, for Japanese, if you take the word reigetsu in Japanese, the way that appears in Wiktionary is on the left here. So, you know, this is how it appears in Wiktionary. This is a very, very fine-grained phonetic transcription. Whereas over here is sort of more at the level of what you might get from the large language model. Okay. Okay, so how did it do? Well, I mean, there's still work to be done here, but it is interesting. There's actually, between the language models that we compare, there is a difference. So Claude gets actually 4 out of 10 languages. So on the left is the target language. I want a language like English, I want a language like French, I want a language like German, so on and so forth. On the next columns are the languages that it was most similar to in this set. Okay, so in the case of the top one, say, most of them got them as most similar to English, although for some reason Lama got it as most similar to ancient Greek. I have no idea why. Also, Turkish seems to be a common confusion for reasons I don't understand. And then you can ask also how often, okay, maybe it's not the top one, but how often is it in the top 10? And again, Claude is somewhat better. So, you know, Claude is in the top 10, or, you know, at least in the top 10 for 5 out of 10. So there's clearly a lot of work to be done. But to be fair, this is actually not an easy task, right? Because basically, if I asked a phonetician who knows Python, write me a program to generate a language similar to that, you know, it'd be hard for them to get it exactly right. But, you know, what this suggests is that at least they know, you know, something about some languages, okay, so there's some coverage there. Okay, let's move right on. So basically, I mentioned earlier that we basically build up a morphosyntactic annotation starting from a source language. And the source language in all of our experiments was English. It doesn't have to be English, but we, just for convenience, we used English as the starting point. And we had a set of 45 grammatically balanced English sentences. What I mean by grammatically balanced is that they are trying to cover the kind of phenomena that in some language might be marked in some way. Okay, now hopefully this will become clear. So you start with word order, for example, and you prompt the model to transform the English sentence into the target order. And then for instance, each syntactic feature, you prompt the model to annotate the sentence with that feature. So basically you're building up annotations, okay, on the sentences, okay? And we instructed not to remove any annotations that it had done on the previous phase. Unfortunately, it doesn't always follow that instruction. Sometimes it drops stuff, so that happens. We also ask it to lemmatize, that is, put the words into their sort of dictionary form. Words like, dogs would become dog, for example. The reason we do that is because we don't want, at the end of the day, we want dog to be one particular word, one word in the target language. And if that target language inflects, then it would also add those inflections to the word dog. But we don't want dog and dogs being confused, right? Again, we'll see that that doesn't always work either, quite. So here's an example. I want to take English and convert it into Turkish-like syntax. So for example, one of the things of Turkish is like Korean, like Japanese, it's verb final. So it's the first thing it does is it moves to the verb to the end. That works so far, so good. Turkish has a negative marker on verbs. So you can see here that it's adding, the negative marker. Turkish also marks case, unlike English, so it adds a nominative case, so subject case, and accusative case, object case to the words, and so on and so forth. Or let's say I want to go to Arabic-like syntax. So in standard Arabic, at least, has verb initial order, so it's a VSO, verb subject object language, and it also marks case. Okay. So we had a bunch of languages. So when I say, when I talk about a language like Welsh or Turkish, I'm not actually talking about Welsh or Turkish. I'm talking about a set of a language that has features like that language, okay? So this is like Welsh-like syntax would have, for example, a bunch of different features, but in particular, the main thing here is the verb, subject, object order, okay? Or this language, Ishkarayana, I'm going to see what translation does with the Ishkarayana down here. Very curious. I don't see it. Oh, well. If it shows up, oh, there we go. Oh, it didn't. Okay, well, fair enough. It didn't try. Okay, so anyway, so it has OVS word order, which is very unusual. It also has an inclusive-exclusive distinction. So that's, unfortunately, neither English nor Korean has that. So when you say we in English or uri in Korean, you don't know whether you're talking about yourself including the hearer or not. But there are languages that make that distinction. Okay? So, Mizo, another language that we included, OSV order, very unusual. It also has ergative absolutive marking. Okay, so that means, if John saw Mary, the John is the subject of a transitive sentence. There's an object there too, so John would be marked in the ergative case. But if John left, John would be marked in the absolutive case because that's an intransitive sentence. Okay, and then we had a hard feature set, what we called hard, which was basically a collection of different features that are unusual, like OSV order, ergative absolutive case marking, prefixing case, that's exceedingly rare in world's languages. The adjective agreement strategy also was prefixing. Nominal number is singular, plural, and dual. I mean, most of these features can occur in some language, but the collection of all of these together is a little bit unusual, or quite unusual. Okay, so how do you evaluate this? So what we did is we took our 45 sentences and we actually had 9 language configurations, including that hard language, okay? And we basically by hand, this was a fair amount of work, this was what Chihiro spent a lot of time doing, was basically annotating the target of what we expected the system should produce. And obviously there's some wiggle room here, but the point is we should, if you ask for verb, if we ask for Turkish-like syntax, you at least expect to get the verb at the end of the sentence, okay? And you at least expect to get, certain kinds of case marking on nouns and so on and so forth. Okay, so how do you evaluate the results? Well, there's a whole bunch of different measures. I'm not going to go into them. I'll just highlight one, basically, this morphosyntactic error rate, which is a combination of two things, which is what we call the stem error rate. That simply forgets any of the things you might add to the words and simply looks at their overall order to make sure that they got it basically in the right order. If nouns are supposed to occur before adjectives, then the noun should occur before the adjective and not the other way around. And then the morphological feature rate is, well, ignoring the possible errors in syntax, does it at least mark the features you asked for? If it asks for an ergative absolutive case marking system, do you get an ergative absolutive case marking system? Okay, and they're also unfortunately obscured at the bottom here, but basically there's this kind of a lemma error rate, which is how often it does the lemmatization correctly that I mentioned earlier. Okay, so how do we look? Okay, so I'm going to have to tell you what these languages are because you cannot see it. So let me just, this is Arabic-like, this is Fijian-like. I'll put at the top, by the way, what the word orders of these target languages would be. This is French-like, this is Ishkariana-like, this is Mizo-like, this is Turkish, Vietnamese, sorry, I got off one, Vietnamese, Welsh, and the hard set, okay? And you can see it's kind of across the board. The main point is lower is better, okay? Because we're talking about error rate here, right? But one of the things that seems to be true, by and large, is that you get things like VSO or SVO or SOV order. Well, Turkish seems to be kind of an exception to this. But generally speaking, those kinds of word orders work okay, whereas unusual orders like VOS or OSV tend to be less well covered. Okay, this again mixes both the syntax and the sort of morphological inflection, so it's a little hard to see what I just said. But one thing you can see is that when you can sort of combine a whole bunch of hard features together, things generally look worse. There is, again, a lot of variation among the different language models. So it's a kind of messy plot, but I mean, it does show that there's a great deal of variation, and that, by and large, things that are harder, that is, things that occur less often in the world's languages, seem to be less well represented. Okay. Quickly on orthography, this is, just to give you an example, it's sort of like the phonology one, but basically now you're asking it to come up with how do you spell these things. So this is like a Welsh-like phonotactics using Cyrillic orthography. I'll just point out one feature which I found kind of cute, which was, how do I go back here? Is there a back button? Sorry. Left one. Ah, there we go. So unfortunately you can't see the thing there, but basically this is an extended Cyrillic letter that is actually used for the Chukchi language, which is a Siberian Kamchatkan language, where they actually have this sound, the hl. And I didn't even know this. I learned this from Claude. So I didn't know that this extended symbol existed. It doesn't surprise me, but anyway. Then, okay, just briefly, writing the handbook, right? We present a bunch of features of the language. We give it some examples. We give it an example of the lexicon and so forth, and we ask it to then produce basically a breakdown according to a certain structure. We ask it to talk about the phonology, orthography, morphosyntax, and basically, as I mentioned before, to invent a name for the language. Okay? So here's one example. Here's a language called Kuhuran. And it is a Japanese-like language with a Cyrillic script and Ishkariana-like syntax, which is, again, OVS, right? well, it describes it. It likes to make comments like, this orthography is simple. Well, actually, they're all simple because they're basically very simple segmental orthography. It mentions the fact that there's an inclusive exclusive, which is correct. It mentions the fact that it's supposed to be OVS, but unfortunately, well, you can't see the example again here, but it turns out it's not OVS because the verb is actually not in the middle. It's actually, they put it at the end. So this is an example. If you ask for an OVS order, you tend to get the verb at the end because OVS is really, really weird, right? It's just not many languages have it. Anyway, moving right along, here's a sample of the lexicon. Okay, one of the kind of the cool things is the the names for the languages. I'll just go through this very briefly. When it's for the Latin script, these names often look like things out of fantasy fiction and stuff like that. At least to my sensibilities, right? If you go down to Arabic, these look vaguely, Middle Eastern, kind of that kind of sort of word. If you go down to Cyrillic, well, sometimes they're kind of boring, like Cyrillic ergative. I don't know, that's kind of a silly name, or Kyrillic. But sometimes they look sort of Central Asian and so forth. Whereas Greek tends to look, well, you got silly words, names like Neo-Syllabic and Neo-Lexical. These are all names that the language models made up, okay? There's kind of I think it kind of makes sense. The Latin script is the most widely used script in the world, so it doesn't really bound to any particular geographical area in the modern world. The Arabic script, on the other hand, is much more localized, although it is widely used. It's, basically in much of the Muslim world. It's also used in, in Muslim world, including North Africa and Middle East and, a little bit into Central Asia. Cyrillic is used widely by languages, particularly languages of the former Soviet Union. So it's a wide area from Central Asia all the way to East Asia, whereas Greek is only used for Greek. I mean, it could have been used for other languages, but it really is only used for Greek. So I'm sure everybody here is wondering, but, what if I did it for Hangul? So the answer is, well, it kind of doesn't look that good, unfortunately. I actually tried giving it full Hangul syllables as a way to do it, so that didn't work at all, really. So I ended up asking for having it do jamo, so the basic, components of the syllable. And these, well, you can kind of see it sometimes try to combine things into syllables, but it doesn't look very nice. So, this is something, unfortunately, Hangul is not easy to adapt, and it, in fact, has only been, as far as I know, adapted to one other language besides Korean. That's the Jia language of Jia language or whatever of Indonesia. There's just one language to which Hangul has been adapted. Anyway, so we can also get it to translate. These are actually large language model generated stories where it's translated a language with the dual, and notice that it actually correctly translates dual as both towers should come out as dual, which indeed it does. Okay, takeaway points. Summing up here. What do large language models know about language? Well, the knowledge of phonotactics is obviously imperfect, but there is a clear difference between different large language models. On balance, I would say that the Anthropic models seem to do better at these kinds of tasks, and that also applies broadly to the morphosyntax for whatever reason. All of the models struggled with the so-called hard morphosyntactic combinations, okay? So, generally asking for things like unusual combinations of case prefixes, it almost never gets right, as it turns out. Even though it's kind of easier to describe, but somehow it doesn't want to do it. Less common word orders tend to be problematic, okay? Models are instructed to lemmatise English, but for some odd reason, this actually is harder for the models if the target language is less complex, is more analytic. So a language like Vietnamese, or target language with Vietnamese-like characteristics, I should say, it doesn't do as well. And this was actually significant across all the language models we tested. And generally, I would say the results are not surprising, but they kind of point to a couple of things. First of all, obviously, large language models, they know a lot about language, but they're not all knowing, right? They're not yet good substitutes for a linguist. If I told a linguist, create me a language with case prefixes, I think they could do it fairly consistently, right? Whereas the large language models seem not to be able to do it. At least we weren't able to get them to. They are very powerful pattern matching models. I don't think they're, some of you may have heard this phrase stochastic parrots that became popular a few years ago by Emily Bender and others, right? I don't think that's quite an accurate characterization. On the other hand, I don't think you could argue that they haven't really internalized general linguistic knowledge at a sort of a deep level. Okay, there's obvious limitations. I think many of you, all of you have probably realized at least some of these. Obviously, translation from English is not necessarily the best way to go about this. The best you're going to get is translationese. Phonology is obviously more than phonotactics. We actually have a phonological change model, but it's sort of integrated into the whole system. Morphology is obviously more than just suffixes and prefixes. Also, morphemes are always generated with single forms, so that would be pretty good for a language like Korean, where most of the time the morphemes, if you want a plural suffix, for example, it's going to be the same thing. But obviously, languages like Russian or Spanish or Catalan or whatever, they have much more complex morphology than that. Features like gender, number classifier systems, those are going to be problematic. Actually, it's not clear how you'd even do gender, right? Because, if I'm starting with English, what would I decided, let's say it had masculine, feminine, and neuter gender, how would it decide to assign gender to a given word? Orthography is limited to simple segmental writing systems using existing scripts. And obviously, actually one of the kind of striking features of conlangs in, say, fantasy fiction, like, say, The Lord of the Rings, is probably nobody has any clue about what they're babbling about when they're speaking Elvish, but you have a good visual image of the so-called runes, right? So we'd like to actually have it be able to create new symbol systems. That's sort of a research project in itself, and so on and so forth. So with that, I will just leave you with the fact we have, as I said, the GitHub repository if you're interested, and also the archive paper on archive. And good.
Thank you. Let's give him a applause. Thank you very much, Professor Sprout. As a linguist, I was deeply intrigued by your exploration of how far large language models can replicate human linguistic structure and creativity. Your talk opens up essential questions about the intersection between theoretical linguistics and computational modeling. Now, thank you, by the way. Thank you very much for all three presenters for those inspiring presentations. Let's give all of them a big hand right now. We will now move on to the discussion session. So I'd like to invite all the presenters and panel discussants to come forward, like in the previous sessions. 선생님 나와주세요, please. Yeah. And our discussants are Professor 성훈 Jung from Gyeongbuk National University. Professor Mi-sun Yoon from Inha University. Each discussion will take about 10 minutes to share their reflections and comments or questions on the presentations we just heard. Okay. So, Professor Mi-sun Yoon, would you start?
Do I go first? Okay. Hi, I'm Mi-sun Yoon, and it's a great honor to be a respondent to the fantastic three presentations of this session. I really appreciate your insightful speeches. And Professor, I'll just read read from the script I have prepared. And Professor Baisheris has introduced the quantitative linguistics as discipline that enables us to explore the universal properties of languages and communication, whether among humans or across species. Or if you don't like the word universal, it seemed to me it's a kind of the system of communication as a whole. And as a scholar of English literature who often works with the particularities of language use, I found it both delightfully surprising and highly illuminating to encounter such an approach that seeks to reveal a latent, long-standing concern of the humanities, the quest for universality in communication. And because actually I'm not trained in linguistics and do not know the details of the discipline of the quantitative linguistics, what drew my attention most from the perspective of digital literary studies was its potential applicability to stylometry, and especially the recent concern in distinguishing between human writing and AI-generated writing. In your discussion of how AI-generated writing might be distinguished from human writing or a video, I was led to wonder actually whether such a distinction would involve considering that each large language model has its own latent universal structure from which diverse outputs emerge according to prompting or tuning. So it's more like sort of a theoretical curiosity rather than the questions about the details. So if so, I would be interested to hear whether you also envisage a kind of a universal structure that extends across models, and actually these sort of modeling would help, and how actually these modeling would this modeling help to distinguish the difference between the human writings and the AI-generated writings? And I think this naturally leads to my question to Dr. Sprout instead of Dr. Zhang. Dr. Sprout's introduction to the fantastic realm of constructed languages actually reminded of the time when I wrote an exchange diary with a close friend of mine, with the secretly coded letters and rules between ourselves. It seems an unquestionably valid and exciting approach to explore the LLM's linguistic capability with asking them make conlangs and thereby investigate the characteristics of human languages. And according to your approach in the experiment, which makes the conlangs according to different types of languages, different families of languages, and the conclusion marked by your sort of final line, actually, it was not shown at the presentation, but according to the slides you gave us beforehand, you said sort of Chomsky was not right in saying, in talking about sort of the universality of languages. So it's a kind of a different sort of approach to the languages. So it seems sort of we already have from your part an answer to the question I just asked Professor Baisheris, that so you seem to say that there are no common tendencies or language patterns among different LLMs, perhaps. So you also seem to suggest that even the linguistic knowledges differ from model to model, if I understand rightly. Then my question is whether actually if LLMs were to learn from or about these linguistic knowledges, not just about sort of how to generate or sort of imitating human languages, then do you think their generative capabilities might be improved with these linguistic knowledges? And and would the multilingual knowledges in that sense contribute to revealing another dimension of a sort of a regularity or universality worth thinking about in relation to Professor Baisheris' approach? These are my questions to the fantastic linguist, and actually I'm not an expert in linguistics, so these questions may sound too sort of broad, but still I think I'm really curious about these aspects. And okay, now this is the question to Dr. Zhang. I think actually I was sort of called to be here as a respondent to Zhang initially because I'm a literary scholar. And Professor Zhang has shown how stylometric analysis can illuminate the shifts in literary style and possibly theme and genre across Alfred Tennyson's long creative career. And working with both R and Python and employing widely used tools and methods, you presented clear stylistic distinctions that align with the poet's evolving interests and periods. It was both surprising and reassuring to see how sort of neatly the clustering and PCA visualizations corresponded to our sort of conventional understanding of Tennyson's two different phases. So my question arises from this very correspondence, but actually, because I didn't have the slides which sort of showed your interpretations, so my question is actually my questions already sort of have the answers from your presentations today, but still I'll just read the questions first, and then let's just make it sort of more into the detailed questions. And do you think the clustering might also reveal nuances that go beyond what we already know, something that complicates or refines our sense of Tennyson's stylistic evolution? Yeah, and I know that you answered that the sort of middle period is a kind of a very strange the period. And you mentioned that your broader aim was to connect the stylistic change with the shifting intellectual and cultural climate. So actually, could you elaborate on what your results might suggest about that relationship? I mean, the shifting intellectual and cultural relationships to the specific aspect of Tennyson's evolution of the style. And this question also extends to the results drawn from the syntactic complexity matrix, which show that sentence length and the use of subordinates increase as Tennyson's style becomes more mature. So a notable exception appears in the mean dependency distance, which particularly interests me. And actually, yeah, you already provided the answer. And I was wondering, I could see sort of this very characteristic aspect from the slides you have provided that the middle period shows a sort of strange sort of estrangement from the tendency we thought of. So could you explain why the middle period shows a shorter distance between tokens and their dependent words than the early period? So while other indicators of a complexity point in the opposite direction, and this feature seems to suggest something distinctive. And could the shorter this dependency distance be closely related to the finding that lexical diversity is greater in the middle period than in the early or late phases? Yeah, sort of you have already said it, but anyway, it would be really helpful if you sort of give us some more explanations. And again, actually, this might be the real question. And could it also have something to do with the genres Tennyson explored through the poem In Memoriam? And how might this pattern invite reflection on the broader cultural or intellectual influences shaping his poetic languages, which seems to be your actual sort of ambition in doing this digital humanities approach to understanding the Victorian poetry. So this is my questions. And then I also wonder whether you find any possibility or idea of further stylistic tools or frameworks that could help advance such an understanding, especially because we are witnessing the rise of deep learning and LLMs. And it would be fascinating if you could illustrate this point with a few poetic lines, perhaps guiding us briefly into Tennyson's world. Thank you. This is it.
네, 안녕하세요. 저 경북대학교 국어국문학과 정성현입니다. 저희 돼요. 저희 그냥 드리면 될 것 같아요. 네, 제가 한국어로 토론을 해서 여러분께서 좀 불편하신 것 같은데, 네. 저는 제 전공이 언어학이고요. 그 다음에 그 전산언어학, 아까 첫 번째 발표에서도 나왔지만 계량언어학 전공을 했기 때문에 이 자리에 불러주신 게 아닌가 싶습니다. 그래서 이 논문 3편을 제가 지난주 토요일 날 받아보고 열심히 공부했습니다. 반갑기도 하고 제 분야이기도 해서 열심히 읽었고 공부도 열심히 했고 저도 많이 공부가 된 것 같습니다. 그래서 이 자리에서 제가 느꼈던 점하고 그다음에 궁금한 점들을 같이 나누고 같이 공부했으면 좋겠다는 생각으로 토론문을 많이 작성했는데요. 배고프시죠? 예. 빨리 질문을 드리고 답변을 드리는 것으로 하겠습니다. 첫 번째 발표를 제가 들으면서 많은 생각을 했고요. 이게 사실 핵심은 뒤에 앞에도 많은 걸 설명하셨지만 뒤에 이제 표절 문제를 좀 많이 얘기하신 것 같아요. 결론부터 말씀드리면 사실은 최근에 챗GPT나 이런 것들이 많이 발전하면서 이 문제들이 사실은 발전하면서 생긴 문제죠. 예전에는 너무도 확연했던 구별이 되는 문제였는데 요새는 이제 구별이 안 되기 시작하면서 나타난 문제 같아요. 그런데 아까 이 뒤에 번역을 보면서 아직은 조금 괜찮구나, 구별이 되겠구나 싶었던 게 그 퀀터테티브 링귀스틱스를 양적 언어학이라고 이렇게 번역하더라고요. AI가 번역한 겁니다. 저희 쪽에서는 계량 언어학이라고 하거든요. 그러니까 그런 걸 보면 단어로서 아직까지는 이렇게 포착할 수 있을 것 같아요. 그런데 실제로 이제 점점 이제 AI가 발전되면서 구별이 안 되기 시작하고 게다가 이제 하이브리드, 인간이 그러니까 컴퓨터가 번역한 걸 인간이 다시 조금 가공을 하기 시작하면 더더욱 이제 포착해내기 어려울 것 같아요. 그러면서 이게 어떤 언어학적 특징으로 이런 걸 잘 포착해낼 수 있을까를 좀 고민해 봤고요. 반대로요. 점점 그러니까 디텍팅하는 능력, 그러니까 기술들이 발전되면서 거꾸로 생각해 봤습니다. 어떻게 하면 안 걸릴 수 있을까? 그런 점들이 어떤 점들이 있을까? 혹시 그런 것들에 대해서 조금 의견이 있으시면 좀 말씀해 주셨으면 좋겠고요. 또 하나 이제 제가 한 분당 두 개씩 질문을 조금 생각해 봤었거든요. 또 하나는 제가 이제 인문학도로서 계량 언어학을 공부했고 전산 언어학을 공부했기 때문에 이제 또 저희가 이제 디지털 인문학이라는 학문을 하고 있다 보니까 이제 계량 언어학이 사실은 중요하다고 말씀해 주신 것 같은데, 그리고 랩도 이제 계량 언어학 중심에 이제 랩이 있었잖아요. 수학자, 물리학자, 언어학식 다 모여 있는. 이제 전체 이제 인문학을 할 때 저희가 그러면 이제 계량 언어학 혹은 또 크게 보면 언어학이 디지털 인문학에서 어떤 도움을 줄 수 있을까? 어떤 기여를 할 수 있을까? 거꾸로 디지털 인문학으로 언어학이 어떤 도움을 받을 수 있을까? 좀 이렇게 좀 너무 거대하지만 좀 그런 생각들을 해봐서 여기에 대한 의견이 있으시면 조금 말씀해 주셨으면 좋겠습니다. 그리고 이제 두 번째 발표도요. 제가 사실 문학도는 아니거든요. 제가 언어학 계속 학부 때부터 언어학을 공부했기 때문에 문학을 전문적으로 공부해 보진 않았는데 제가 최근에 한시 자료를 가지고 좀 연구를 하고 있습니다. 그래서 시 관련해서 조금 도움이 될 부분도 있고 해서 열심히 공부해 봤는데요. 제가 사실은 준비했던 질문이 제가 처음에 발표문을 받았을 때는 아까 보신 것처럼 덴드로그램이나 표만 계속 받았어요. 그리고 이제 결론 부분이나 이렇게 그런 간략한 요약본을 받아가지고 첫 번째 질문이 덴드로그램이나 이런 거 그렸을 때 상위 100개의 빈도들을 단어를 좀 제시해 주시고 설명해 주셨으면 했는데 사실 앞에서 다 설명을 보완해 주셔가지고 설명해 주셔가지고 발표하시면서 제가 갑자기 질문을 하나 만들어냈습니다. 그게 뭐냐면 아까 PCA 분석을 하셨잖아요. 이게 그러니까 차원이 많은 걸 2차원이나 3차원으로 축소해서 간략하게 보여주는 시각화 분석인데 보셨을지 모르겠지만 밑에 PCA X축이 17%, 18% 요 왔다 갔다 하고요. Y축이 7%, 8% 왔다 갔다 하거든요. 결국 그러면 1차원과 2차원이 그 전체 시의 한 20% 정도만 설명하고 있는 거예요. 물론 그 20%로 초기, 중기, 후기를 거의 잘 구별하셨지만 나머지 설명되지 않는 80%가 있다는 거거든요. 나머지 설명되지 않은 것들은 뭐라고 생각하시는지 좀 궁금했고요. 그 다음에 두 번째 질문도 좀 너무 간단한 질문이긴 한데요. 그 제가 한시를 분석하거나 뭐 이럴 때 보면 이제 아까 센텐스하고 토큰이라는 개념을 쓰셨는데 센텐스라는 게 사실 좀 너무 쉬운 개념이면서도 사실 분석할 때는 어려울 수 있거든요. 예를 들면 한국어 같은 경우에 철수는 집에 갔어, 밥을 먹었어 라고 말했어 라고 하면 사실은 이게 한 문장으로 처리될지 집에 갔어, 밥을 먹었어라는 안에 있는 쿼테이션 마크 안에 있는 그 문장 두 개가 따로 해석될지가 사실은 어떤 기준으로 삼을지가 굉장히 조금 중요해지거든요. 여기에 대한 답은 물론 아직까지는 저도 못 찾긴 했는데 처리하실 때는 어떻게 처리하셨는지 혹은 어떤 방법이 앞으로 조금 더 개선돼야 될지 좀 이런 것들도 좀 궁금했고 마찬가지로 토큰도 그렇거든요. 이 토큰이 이제 한국어를 처리할 때 토큰하고 영어를 처리할 때 토큰들이 다르고 이 토큰들을 어떤 기준으로 이제 처리하셨는지가 궁금했고 이게 사실 그리고 시라는 장르잖아요. 사실은 문장이라는 개념보다는 행과 연이라는 개념이 조금 중요할 수 있습니다. 라임이나 뭐 이런 것들이 있어서 그래서 문장으로 분석하셨을 때는 혹시나 그 연으로 이렇게 문장이 안 끝났지만 이렇게 연으로 해서 한번 분석해 보셨는지도 그런 아이디어가 있으셨는지 혹은 해보셨는지 조금 궁금해서 그것도 한번 여쭤봅니다. 그리고 마지막으로 그 스트로트 선생님께 한번 질문을 드려보고 싶은데요. 이것 들으면서 저는 한국 분들은 다 아실 텐데 아스날 연대기 드라마가 생각이 났어요. 거기에 네안타러라고 혹시 들어보셨을까요? 요새 그 언어가 어떻게 그러니까 여기서는 이제 그 포노테스틱이라고 해서 저희가 음소 배열론이라고 언어학에서는 번역하거든요. 그거는 어떻게 했냐면 한국어 어저를 그냥 반대로 그러니까 그 자음모음을 반대로 배열하는 거예요. 그래서 문이라고 하면 미음, 우, 니은을 니은, 우, 미음, 누무로 그냥 발음하는 약간 그런 식의 패턴으로 조작해서 했던 거로 알고 있거든요. 그러니까 그런 거를 좀 생각해 보면 이게 참 재미있는 연구가 되겠다 싶었습니다. 그리고 그래서 좀 질문을 좀 드리면 사실은 쿠란어라는 새로운 언어를 만드시면서 이제 음소 배열 쪽으로는 일본어, 그다음에 통사적으로는 그 카리브해 언어라고 제가 찾아보니까 나오더라고요. 히슈카리아나어를 가지고 오셨고, 그다음에 정서법, 철자법으로는 끼릴문자를 하셨는데 사실 일본어는 이제 고저 악센트가 있는 언어예요. 그래서 자음 모음이 번갈아 가는 가장 간단한 패턴입니다. 그 음소 배열론 쪽으로 보면. 발음이 굉장히 단순해지죠. 그리고 그 히슈카리아너 같은 경우에는 사실 OVS 언어여서요. 어순으로 보면 굉장히 희귀한 언어예요. 그러니까 전 세계 언어가 한 5,000개에서 6,000개라고 그냥 좀 좁게 생각해 보면 SOV나 SVO 언어가 거의 한 70%, 80%를 차지하거든요. 대부분의 인간의 언어들이 그런 식으로 작동하고 있는데 이건 사실은 좀 빈도가 낮은 혹은 나타나기 어려운 어순이기도 한데 이런 걸 이제 선택하셔서 하나는 너무 간단한 배열이고 하나는 좀 복잡한 통사적으로 조금 어려운 배열을 결합해서 독특한 언어를 만드셨는데 그런 이유가 혹시 있으셨는지 이게 언어 유형적으로 좀 재미있는 부분이어서 한번 말씀드리고요. 또 하나는 마지막 좀 큰 질문일 수도 있는데요. 이러한 그 연구들이 이제 그 언어학에서도 언어 유형론이라는 게 있거든요. 언어 유형론이나 혹은 뭐 기계 번역, 그다음에 대규모 LLM이죠. 대규모 언어 모델에서 어떻게 더 이제 좀 기여를 할 수 있는지 조금 이렇게 구체적으로 좀 말씀해 주셨으면 좋겠다고 생각을 했습니다. 네, 제 토론은 여기까지로 하겠습니다. 감사합니다.
Before we start to hearing the answers from presenters, we only have 10 minutes and we have another session will be going on. So please allow me to say that like each presenter will have a 3 minutes. Yeah.
Okay, I will try to be brief. So if I can condense your questions into one single question, I would say modeling, having models, general models for all languages can help to distinguish AI-generated text from human-generated text. That would be correct to condense your questions into that single question. Well, very briefly, those models are old. I mean, they didn't appear with computers. Zipf's laws, which are probably the oldest mathematical models of language, appear when the computers didn't exist at all. He computed by hand with lots of people helping him. So my question would be, the models probably do not help to distinguish text. Models maybe help to distinguish a communication system, a feasible communication system from an unfeasible communication system. Why do I say that? Because there are papers which prove that laws like Zipf's laws and similar laws are not random. They appear for a reason. If you generate a text with random words, Zipf's laws do not emerge. So it means that it says something underneath a human language. But the thing is that large language models copy this very well. So these models alone cannot distinguish. What can distinguish text of both origins are things like the work of my colleague here, in which you take a bunch of stilometric metrics and you use machine learning methods to distinguish things. So the features are the many stilometric measures that we have, and then you apply sophisticated machine learning models to distinguish between them all. And as for the other colleague, I think he's asked two questions. The first question would be, how can I avoid to get caught, if I'm correct? The second is how humanities and computer scientists can interact. What can we expect one from each other? So as for the first question, my answer would be, don't do that. Don't copy. Don't use AI to generate text. Use it to write a text in a more correct form, to have some words which may sound better, text which can be more idiomatic, but do not try to generate text, because but I cannot answer your question, because we have methods to detect language generated by LLM methods, by systems. But as I tried to explain in my presentation, interpreting them is very difficult, because you have a large array of measures, stilometric measures, and the combinatorics is very, very, very complicated. So I could not tell you, don't use sentences of this length with adjectives which go blah, blah. This I cannot say, because it's very complicated. But again, my advice is, don't do that, because we will get you. And finally, humanities and computer scientists. As I said, human researchers, from my point of view, they have the mission of interpreting and finding a meaning to the findings that we propose. So we say, this is a model. This is a law that appears all the time, or this is something that appears in our languages. I think that it's your job to interpret this model. We probably don't have the background necessary to do that. Vice versa, we would expect from you interesting questions. For instance, one interesting question which is being addressed now is, has the language of young people changed because of the emergence of Twitter and all those systems in which you use short sentences, etc., etc.? Does it imply that they have less vocabulary, that their syntax is simpler, and in fact that their expressivity is not as good, they are not expressive as their parents used to be? That would be an interesting question, and in our field we are expecting this kind of questions. So that's it. I don't know if I answered both of you.
Okay, so yeah. Okay, thank you for your questions. That's insightful, and I'm proud of me to think more deeper about my project. Okay, so Tennyson has long been my favorite poet. That's why I chose Tennyson for this this kind of digital analysis. And I said that my goal is twofold. Bridging the quantitative approach to the text with introducing the qualitative interpretation of the text. And I'm still working on, constructing that bridge between two kinds of analysis. And I have to work further on adding, my own qualitative, subjective interpretation to this digital analysis based on, previous studies. Traditional close readings of Tennyson's poetry. So yeah, I'm still working on creating my own qualitative interpretations, and so how to conclude about the implications of this quantitative analysis. Digital analysis of Tennyson's texts. And also, you asked about what kinds of new insights I have gained from this analysis. I learned a lot in working on this project. One of the things is that, in memoriam, which is a great elegy for the death of the poet's close friend, Arthur Hallam, is actually neutral, relatively neutral, compared to other poems by Tennyson. Elegy tends to be very emotional, charged with grief and mourning. However, this poem is relatively neutral, objective, compared to other great poems by Tennyson. And the other insight I'd like to introduce is that, the epic poem, Idylls of the King, of course, are very complex and highly, intricate grammar structure than other previous poems. But actually, it's more repetitive in terms of lexical variety. So that's a new thing for me. And okay, and now I'd like to answer your questions. May I answer in Korean too? Okay, 예, 좀 질문이 한국어셔서 답변도 그냥 한국어로 하는 게 나을 것 같은데, 이제 PCA의 적용 문제에 대해서 말씀하셨는데 사실 그게 굉장히 큰 중요한 이슈거든요. 그러니까 MFW 100개, 이제 가장 많이 등장하는 단어 100개를 이제 PCA를 할 때, 그러면 그 데이터는 무려 100차원의 데이터거든요. 그거를 이제 뭐 한 2차원으로 줄이게 될 때 PC1과 PC2가 차지하는 퍼센티지가 낮을 수밖에 없게 되는 거예요. 그래서 뭐 제 연구에서는 뭐 PC1이 뭐 한 10% 후반, 20%는 넘지를 않았는데, 그러니까 사실 그 정도면 좀 높게 나온 거고요. 이제 선행 연구를 보면 10%도 안 되는 그런 경우들도 제가 봤어요. 그래서 그러니까 사실 이게 다른 학자들도 이미 뭐 연구를 했던 문제이고, 제가 알기로 이제 문학 작품을 이제 PCA를 할 때에는 PC1과 PC2가 차지하는 비율이 낮을 수밖에 없다라는 게 이제 학자들이 이제 내리는 결론이고, 그래서 이제 PCA를 그냥 단순하게 이제 문학 작품에 적용해서 해석을 하기는 좀 한계가 있다라는 거죠. 그러니까 PCA만 보고 그거를 이 문학 텍스트를 좀 해석하기는 어렵다라는 거예요. 그러니까 어디까지나 이제 PCA는 우리가 쓸 수 있는 방법 중에 하나인 거고, 이제 여러 가지 이제 방법을 함께 이제 써야 되는 거죠. 그리고
네, 선생님 지금
예.
너무 죄송한데요.
오케이.
저희
예.
Okay, so I'll try to be as brief as possible. First of all, Professor Yoon's question. So just one note, when I said in the sort of preliminary version of the slide that Chomsky was not right, I wasn't particularly referring to his particular theories about language, but rather his completely dismissive attitude towards large language models, as saying they're basically useless and don't tell us anything. I think that's completely wrong. If I understood the question, the main question though was like, do I think do I think we could somehow improve the generative capabilities of these models with linguistic? And I think the answer is we hope so. That obviously there's a large amount of interest in particular, not just in constructed languages, but also in dealing with real languages that are so-called low resource, under-resourced, or there just isn't enough data, probably never will be. So how do we get large language models to deal with those? And there's an active research area in trying to see, can we sort of inject linguistic knowledge into these systems so that they can actually cover these kinds of things. So I hope that sort of at least partly addressed your question. And Professor Jung's question, if I understood it, it was sort of, okay, so all of these linguistic properties are interesting, but why the distribution? Why does it occur? I mean, that's a very interesting question. It's a very deep question, and I can't hope to answer it here. I mean, people have asked, just to take word order, why is it that, SOV word order and then SVO word order are very common, but others are less common, and people have various theories about why this should be the case. None of them seem to me terribly convincing. They all often start with the presumption that there was an original word order, the Ur language that we all spoke when we were wherever we were when we studied invented language, had some word order. That seems to be very presumptuous. We don't know anything about this language, whether it had a fixed word order or not, and therefore to sort of start with that assumption and sort of evolve towards, particular word orders that we see in modern languages, who knows? I mean, so I think it's a very interesting question, but I'm afraid I don't think I can really answer the question at this point because it's really quite deep. And
Thank you for your short and swift response. And this concludes our session 2. In fact, according to the schedule, we don't have break, but we will need to have break right now because everyone is getting tired. So we will have a 5-minute break, and then we will have a post session prepared by undergraduate student on digital humanities. So, yeah, here, yes. So that's it. Thank you very much for every participant in session 2.
Everyone, thank you all for being here today. It's a pleasure to see everyone here. I'm Hak-Sun Kim, professor of Chungnam University, and I am going to chair this session. I am an analog human being. I am studying Japanese ninjas and monsters. From now on, I'll also be interested in digital. And we will now start today's discussion. The presentation time is 5 minutes. 5 minutes. The first speaker is Ionu Im-Suyeon Kwon from Korea University. Are you prepared? Okay. Please.
Hello, everyone. This is Suyeon Lim from Korea University, and she is Yeonu Lee, also from Korea University. Let me start our presentation. Our theme is about a comparative study on the localization of Korean drama in Japanese and in Japan and audience reception, focusing on Itaewon Class and a Japanese remake Roppongi Class. And about introduction, our research objective aims to compare and analyze the reception patterns of the Korean drama Itaewon Class and its Japanese remake Roppongi Class within Japan. To this end, it examines the cultural correspondences and adaptation revealed during the localization process, as well as the commonalities and differences between the producers' intentions and the audience perceptions through an analysis of both works and their reviews. About the previous studies, morpheme extraction focused on nouns, verbs, and adjectives, which carry rich information, is suitable for capturing core themes, actions, and emotions. While some episode comparisons focus on drama reviews analysis and localization, cultural and directing elements, qualitative analysis per episode, and quantitative analysis of audience reactions remain insufficient. The research subjects are the Korean drama Itaewon Class and its Japanese remake Roppongi Class. About our methods, about data collections, we collected and refined 9,685 reviews for Itaewon Class and 10,045 reviews for Roppongi Class posted on the Japanese review platform Filmmarks through web crawling. About qualitative analysis, the two dramas were compared and organized episode by episode based on storytelling, cultural elements, and directing techniques. About quantitative analysis, key terms were selected from the qualitative analysis of each element, and data analysis of co-occurrence between core terms and peripheral terms were conducted for each character using Python's collections library with a window size of 1. About the results, the qualitative analysis, First of all, the storytelling, the protagonist Miyabe Arata's personality and goals, the atmospheres of Nagaya family, and the approach to handling foreigners and social issues were adapted differently from the original work. The personalities and behavioral patterns of some characters were also adjusted. Second, about cultural elements, localization tailored to Japanese society was implemented, including the educational curriculum, festivals, social media usage, and the legal drinking age. Third, the direction. Editing the scene changes tailored to Japanese context were observed, including altered filming time periods, deletion of certain characters, adjustment to broadcast scene directions, and modification to female character imagery. About the quantitative analysis results are as the following. For conclusion, in the story, characters became flattened during localization, reducing viewer immersion. Regarding cultural elements, the Korean setting and lifestyle were transformed into Japanese-style elements, yet viewer interest in the location decreased. In production, some scenes and characters were deleted or altered, reducing depth and flattening the narrative, which diminished character appeal. About the future task, additional analysis of Japanese viewer review data from Itaewon Class and Roppongi Class, and examination of patterns of cultural adaptation and transformation through localization are further needed. Thank you for listening.
Thank you for the meaningful presentation. The next speaker is Lee Ji-won, Choi Jae-sung, Kim Ga-ryung from Harlem University. Start, please.
Hello, we are the students from Harlem University, and my name is Ji-won Lee.
And Ga-ryung Kim.
And Choi Jae-sung.
So now I'm gonna start my presentation. Okay. Good afternoon, everyone. Today I would like to introduce our project on Pride and Prejudice. and explain how we conducted the narrative through data analysis and visualization. So the Pride and Prejudice presents a well-structured story that connects dialogue and inner emotion. Because the novel contains rich and complex interactions between characters, we were able to uncover both structural and psychological patterns embedded within the narrative. More specifically, this study focuses on confirmation bias, exploring how Pride and Prejudice influence perception and judgment among characters. It let us understand about how personal bias shapes the interaction between characters in the novel. The following session outlines the method we use to analyze the emotional structure of the text. For this project, we use an open source dataset from GitHub, which is listed at the bottom of the poster. We conducted our analysis using NLTK, which is a Python library that includes Vader, which is a sentiment analysis tool. It measures the positive, negative, and neutral emotions in each line of text. We follow mainly 3 steps in our process. First one is the selecting main character, and then we ran through the basic pre-processing process so that we can extract all of the speeches from the text, and also cleaning the stop words. And then by using Vader sentiment analyzer, we calculated sentiments scores for each line of speech. And from the data that we got by using Vader, we categorized the results into positive, negative, and neutral sentiments, and visualize all these outcomes through 3 different kinds of graphs, which is a sentiment distribution, emotion density, and word counts compared with emotion intensity. We will now take a look at the main findings from our analysis. First, if we look at the emotion distribution, which is at the left part of our poster, and Mrs. Bennett's line include many positive and negative words, showing her emotional ups and downs. In the story, she often overreacts about her daughter's marriages and social status. And about the second graph, it is about the density of the emotion. And there is the highest part is about the Lydia, and it shows that she is really emotional status. Yeah, so we don't have enough time, so let me talk about the conclusion. So by this graph, we can see that Elizabeth and Darcy express their emotions in a more restrained and extended way, revealing their feelings gently over longer speech segments. In contrast, Lydia and Wickham express their emotions through shorter but more intense statements, which makes their emotion tone more noticeable. Overall, so we were able to uncover hidden emotion patterns that may not be immediately visible through traditional listening. For the further information about our project, please scan the QR code below the poster. Thank you very much for listening, and hope you enjoy the rest of the conference.
Thank you for the presentation. The third speaker is Kim Seon, Icheong, Shindong from Sungmyeong Women's University. Please start the presentation.
We are students from Sungmyeong Women's University. I'm Chae-myung Lee, and this is Seon Kim. Today, we will present our study titled SUNPIC, a data-driven model for quantifying cultural heritage value. In recent years, more and more foreign tourists have been paying attention to Korea. At the same time, they are also showing great interest in our heritage. However, they only visit a small number of well-known sites, and this creates an imbalance in tourism. Many valuable, lesser-known sites are being overlooked. The problem is, we don't really know why they prefer certain sites. Just counting visitors or searches isn't enough. Our research aims to solve this. We work to reveal the potential of lesser-known sites and encourage sustainable tourism. Let me briefly explain our process. To begin with, we collected data. We selected 15 heritage sites, including both well-known and lesser-known ones. We gathered over 2,200 reviews from Google Maps and TripAdvisor. In the next step, we analyzed this data. We used topic modeling such as TF-IDF and LDE to find the main keywords and themes. Then we used cosine similarity to compare the attractions of well-known and lesser-known sites. Our analysis revealed three main insights. First, attraction factors were clearly different for each heritage type. Traditional architecture was about history and emotional immersion. Religious heritage was recognized for its peaceful atmosphere and elegant design. Natural heritage focused on nature, scenery, and calmness. And experiential heritage often mentioned activities like wearing hanbok, making kimchi, or taking photos. Second, from our sentiment analysis, we found that most reviews were positive and a few were in between. In many positive reviews, words like beautiful, peaceful, and fun appeared often. This shows that visitors enjoy emotional experiences. They prefer feeling the place and the moment, not just sightseeing. Lastly, we found that several lesser-known sites were highly similar to popular ones, such as Seonnungdan Shrine, Jingwansa Temple, and the Yugansun Memorial. All of them showed over 0.99 similarity scores. This means that these lesser-known sites could become successful heritage destinations if given more attention and support. Through this study, we tried to understand the value of cultural heritage more clearly and practically. Sunpik is designed to reflect people's emotions and moments beyond simple numbers. We hope this study can be a small step toward seeing our heritage in a broader way. For more details, please scan the QR code, our full slides on the left, and demo site on the right. Thank you for listening.
Thank you for the presentation. The next speaker is An Yoo-jin from Seoul National University.
In 1987, a young man escaped from a welfare facility in Busan. His body covered with bruises. His story was almost unbelievable. The place was the brothers' home, where those labeled as vagrants were unlawfully detained. People were subjected to violence in the name of rehabilitation during authoritarian regime. Decades later, the Truth and Reconciliation Commission investigated this case and published official reports to uncover what really happened. My name is Yoo-jin An, a third-year undergraduate student in the Department of History at Seoul National University. As a student of history, I wanted to understand not just what these reports say, but how they tell the truth. And as I read those reports, one question stayed on my mind. What does it mean for a nation to tell the truth? Does the truth of violence sound the same when spoken by the state and when spoken by the survivors? To explore this question, I analyzed 3 reports on Brothers' Home case published by the Truth and Reconciliation Commission of Korea between 2022 and 2024. I divided the text into 2 corpora: the official records written in the institutional voice of the state, and the personal narratives which summarize victims' testimonies. Both discuss the same tragedy, but they speak in the very different languages of truth. To examine how those languages differ, I applied latent directly allocation topic modeling and keyword network analysis. Topic modeling detected recurring themes across hundreds of pages, while network analysis visualized how the main words are interconnected. In short, these tools help to translate complex narrative of violence into patterns that we could see and compare, not to reduce meaning, but to reveal how meaning is structured. The contrast was striking. In the official records, the most central words were control, protection, and society, terms that frame the case through procedure and responsibility. But in personal narratives, the language shifted. Words like father, escape, and especially 소대장, meaning squad leader, became the central nodes in the network. The 소대장 was a mid-level enforcer inside the facility, a keyword rarely mentioned in the official account, but one that appears again and again in the survivors' testimonies. This difference shows that violence was not only top-down, but also reproduced through internal, micro-level power relations. This finding reminds us that truth is neither single nor stable. When spoken by the state, truth is institutional. It assigns responsibility and closure. But when spoken by the survivors, the truth is experiential. It conveys memory and the texture of lived violence. By using digital tools to compare these voices, my research aims to reveal the politics of narration that underlie how truth and reconciliation are documented. In the end, this study is less about algorithms and more about what they reveal. That truth is shaped through language, context, and power. While future research will integrate these findings with qualitative analysis to further explore the narrative structures of power within victims' testimonies, this study focuses on tracing patterns across the official and testimonial corpora. By bridging the quantitative and qualitative approaches in future work, my goal is to deepen our understanding how the voices of the state and the voices of survivors together shape the memory of the state violence, and ultimately, how a nation remembers its own truth. Thank you for your attention.
Thank you for the presentation. The fifth speaker is Kim Do-hee, Lee Kyu-hye, Lee Jun-seok from Hallym University. Please start.
Hello, everyone. I'm Kyu-hye Lee from Hallym University. I apologize for not being able to represent my another coworker because of their personal circumstances. I'll start my presentation on the analysis of emotional and relational networks through a novel, Wuthering Heights, authored by Emily Jane Bronte. Wuthering Heights is a story that contains emotional conflicts of love like a storm between Catherine and Heathcliff. We try to understand their relationships and their linguistic features in this story through network visualization. So, we analyze the language usage patterns of the characters in Wuthering Heights to show their complex and dynamic emotional relationship through a network visualization. Our research objectives were to answer two questions presented in our poster. First, we used Python to extract 3,096 lines of narration data and 3,468 lines of quotation data from the original text of the novel. This whole data was reviewed again manually based on the mentioned character from the speaker, although the process of extracting data wasn't mentioned in our poster. It allowed us to analyze how the language of love is expressed in Wuthering Heights, focusing on the patterns of the expression and vocabulary usage within characters' dialogue and the narrative, which can measure the intensity of the love like a storm between Catherine and Heathcliff. After that, we used GPhi, a software for network visualization, to analyze which characters used which word and how frequently they did so. Especially, we derived the results centered on the volume of speech between characters, influence, and keyword clusters. It allows us to visualize the network visualization of the relationship of the characters through speaker-listener interactions and the differences in the frequency of language used among characters. The right image in figure 1 shows the relationship of the main characters, while the left image shows a partial enlargement. Note size represents the degree of character speech from listener to speaker, and color indicates betweenness centrality. Catherine's nose is smaller than positioned towards the periphery, indicating a relatively low volume of speech. Heathcliff and Edgar function as dominant speakers within their respective relationships, represented by thick and unidirectional arrows. The connection between Isabella and Heathcliff is visualized with bidirectional arrows of equal thickness, signifying a manually balanced interactions. The picture number 1 in figure 2 shows a clustered keyword-based sentiment relationship network for individuals. Picture number 2 and 3 in figure 2 are partially enlarged from picture number 1. Node size represents the degree of word frequency of each character, while node color indicates between its centrality. As shown in picture number 2, in figure 2, Joseph and Harrington share dialectal expressions such as word, die, thee, forming a distinct group of Yorkshire dialects in England. Their use of colloquial language shows that they were in the lower social class. As shown in picture number 3 in figure 2, Kathy and Linton show their sophisticated and grammatically precise language patterns, shaped by their similar socio-educational backgrounds. However, the cases of Nellie and Edgar and Isabella suggest that their linguistic patterns cannot be explained solely by social and educational factors. Through this study, we confirmed that the relationship between Catherine and Heathcliff showed their distinct emotional asymmetry, while the relationship between Isabella and Heathcliff contained emotional dynamics. Furthermore, through the relationship between Nellie and Edgar and Isabella and Nellie, the linguistic characteristics of these characters are significantly influenced not only by social educational factors, but also by emotional and relational factors. Meanwhile, this study has some limitations. This network visualization didn't fully capture the emotional and contextual nuances in characters' interactions. And the language uses patterns are related not only to social background, but also to relational and emotional influences. Therefore, we believe that further research should be done with the semantic analysis and sentiment analysis among characters to investigate how emotions and relational dynamics are reflected and developed through the language in Wuthering Heights. This concludes my presentation. Thank you for listening.
Thank you. Thank you so much. The final speaker is Yunsa from Chungnam National University. Please.
Hi everyone, I'm Eunso Lee from the Department of Linguistics at Chungnam National University. Today I will present my study on a list of the news headlines focused on The Guardian, USA Today, and the Korea Herald. Headlines may look short, but they play a big role in shaping how readers view events. Their wording reflects each newspaper's values and national style. In this study, I'm comparing how three countries frame similar topics differently to identify whether the Korea Herald follows a British or American style. I collected a total of 1,800 English news headlines, 600 from each newspaper, published between January and May 2025. They were evenly divided into three sections: politics, socio-economy, and culture. Using Antkunk, I analyzed the word list, collocation, and kick to explore close the national difference in word choice and framing. First, let's look at the overall tendency. The Guardian tends to be analytical and critical. USA Today is natural and factual. And the Korea Herald blends the local focus with global awareness. Now, let's look at the different points in each section. In the politics section, the differences are very clear. The Guardian often linked Trump with the verb like ban and criticize, showing ideological framing. USA Today used the verb like signs and announced, focusing on factual action and neutrality. Meanwhile, the Korea Herald combined the lead with the press and apologize, and emphasizing personal responsibility and morality. In short, the British evaluate, the American report, and Korean personalize. Next, in the socio-economy section, the Guardian contacts the trade and the traffic with the crisis and impact, highlighting global instability. USA Today linked Tat and Bill with the stock light, focusing on market trend and efficiency. The Korea Herald used the experience like BOK, Bank of Korea, cut late and shares open higher, showing domestic stability. Finally, in the culture section, the difference become even more distinctive. The Guardian frequently used words like review, film, and book, showing a critical and evaluative tone. USA Today highlight World Cup and award emphasizing entertainment and global event. The Korea Herald focused on K-pop, UNESCO, and Seoul, promoting Korean culture to the world. To sum up, The Guardian is critical, USA is factual, and the Korean Herald is a hybrid. It combines the British analytical tone and the American factual detail, and added the Korean cultural perspective that promotes the national image globally. Even short headlines reveal national tendencies, showing how language reflects the power, responsibility, and identity. Thank you for listening.
Thank you. All the presentations are over. Now it's time for questions, but we are very hungry. So only two questions, please. 예, 한국어로도 하시면은 예, 영어, 한국어 다 괜찮으십니다. 예, 번역기가 있으니까. 예. 지금 마이크가
Thank you for all the participants' presentation. First of all, my name is Taryn Lee, and I'm currently a master degree student in this university. I would like to give a question to from Sungmyeong Women's University students. Actually, that was quite interesting about analyzing the cultural heritage section, and how do you want to develop this result to promote the Korean cultural heritage?
일단은 저희가 그 문화유산 분류하는 기준은 국가유산청의 분류 기준이 나와 있어서 그 기준대로 분류를 진행을 했고요. 그 중에서도 이제 그 선정 문화재라고 해서 조금 유명한 문화재와 상대적으로 덜 유명한 문화재를 비교를 한 분석인데, 유명한 문화재는 그 리뷰가 많은 순서대로 정렬해서 저희가 그 상위 리뷰 길이를 기준으로 해서 상위 50개를 선정을 했고요. 유명하지 않은 문화재는 저희가 그 문화재 카테고리에서 랜덤으로 추출해서 리뷰를 수집을 했습니다.
그러면 그걸 어떻게 제안하고 싶으신 방향이 있나요?
저희는 일단 이 키워드들을 보고 어떤 요소가 외국인들한테 매력적으로 다가오는지 확인을 하고 싶었고, 이 부분을 통해서 나중에 정책적으로나 아니면 문화재를 정량적으로 평가하는 데에 활용하고 싶다고 생각을 했습니다.
괜찮으세요? 예, thank you. 예. So one more question. 한 분 더 있으실까요? 없으실까요? 예, 알겠습니다. It looks like time's up. Thank you for your attention. 예, 감사합니다. 고생하셨습니다. 감사합니다.
This concludes today's official program. Thank you for participating and staying so late through all day. Thank you so much. Some and some, yes. First, I will tell you in Korean. Oh, so it's gone. Okay. Okay, good. 자, 지금 저녁 식사가 있을 거거든요. 근데 혹시라도 이제 지금 저희 학회 참석하시고 오늘 내일 발표하시고 사회하시고 하신 분과 지금 포스터 세션에서 지도하신 분, 또 사업단 교수님 다 누구신지 아실 겁니다. 그래서 귀빈 대상으로 지금 학교 주변에서 패컬티 하우스 송님 저희 조교들이 다 안내를 할 겁니다. 그래서 그냥 따르시면 되고요. 그다음에 또 해외에서 오신 분들을 위해서 지금 저희가 저녁 식사 끝난 다음에 호텔로 라이드를 드릴 거고요. 8시 경에. 그리고 내일 아침에도 오늘처럼 또 학교로 오는 라이드를 또 드릴 겁니다. 그래서 그 안내가 지금 부분적으로만 됐다고 하셔가지고 말씀을 드리고 내일은 오전 10시 30분부터 다시 세션이 있는데 등록을 굳이 하실 필요는 없고요. 여기 오셔서 내일은 2개의 세션과 마지막에 라운드 테이블이 있을 겁니다. 그래서 계속 디지털 인문학과 함께하는 시간이 되실 것 같습니다. 오늘 고생 되게 많이 하셨고요. 조교 선생님들 그리고 청중 여러분들 모든 참여자 발표자 그리고 내일 발표하실 분 너무너무 감사합니다. 감사합니다.